Hello everyone, my name is Anson, and in this tutorial, I will teach you how to build a web API using the Express.js framework. Express is the most popular server-sided web framework in the Node.js ecosystem. It is widely used by many developers. It's in over 20 million projects according to GitHub. It has over 27 million weekly downloads according to NPM, and it is used by a lot of companies ranging from startups all the way to Fortune 500 companies. But why is it so popular though? Well, mainly because Express.js is very easy to learn. It makes it very easy for you to set up an API in less than 30 seconds. It's unopinionated, which means there's not much, if not, there's really not any overhead at all. You don't have to worry about configuring a bunch of different properties in your application before you can actually use it. All you have to do is just install the package, instantiate the Express app, and then listen to a port, and then begin listening to requests. And that's it. There's no right or wrong answer when it comes to building web APIs using a framework that is unopinionated like Express.js. And because of that, that is why till this day, over the past perhaps 10 years now, Express is still the dominant framework that many people choose to use whenever they want to build their next project. Now, for those of you who are not really familiar with how web APIs interact with other applications, I have a simple diagram over here that we're going to go over. Right now, Express.js, remember, is a server-sided application. So pretend that right over here on the right-hand side, this server is where our Express application is going to live. And then we have our clients. So these are typically just regular users that will use your application either on a mobile device, such as a phone or a tablet, or they'll use it on a computer, either via the web browser or a desktop client. Now, let's say, for example, we have an e-commerce website, and that e-commerce website, when you visit it, it displays a list of products. Those products needs to come from somewhere. They don't just randomly appear. When you click on those products, you can see more information about it, but where does that information come from? Where does all of the data come from? Well, most of the time, it comes from a server. It comes from a web API. But the client doesn't just automatically receive that data from the server. The client needs to make what is called an HTTP request. HTTP stands for Hypertext Transfer Protocol. It pretty much just means, hey, this is how I want to exchange data with you. Okay, there are many different types of protocols, but HTTP is one of the most popular ones out there. So let's go back to our example of the e-commerce app. The moment that you visit the homepage of the e-commerce app, what happens is the code on the client side will make an HTTP request to the server-side application. Okay, in our case, it will be the Express API. The Express API will receive that request and it will say, okay, I just received the request to send back a list of products for the client. I don't care how the client uses it. I don't know what they're going to do with it, but my responsibility is just to get that list of products and send it back to the client. So what the server will do is it'll perform some business logic and then it will produce an output. Okay, in this case, the output is retrieving the list of products. And the client itself never actually sees this operation going on. So think of it like this. Let's say you're at a restaurant and you sit down, you're at a table, the waiter comes to you. The waiter in this case is the server. The waiter asks you what you want. You request to the waiter, hey, this is what I want to eat. The waiter will send that request back to the kitchen, back to where all the chefs are working. So you can think of the kitchen like the server. You never actually see what's going on in the kitchen. All you know is that after a certain amount of time, the waiter will come back with a response. In this case, that response is going to be your food. In our case, for our e-commerce application, the response that we are getting from the server is going to be a list of products. Hopefully that makes sense. And now we are finally ready to dive into setting up our Express.js project and writing some code. So let's go ahead and get started. So right inside my Windows PowerShell, I'm going to go ahead and create a new directory. I'm going to call this Express.js tutorial. I'm going to go ahead and cd into that directory. And let me just clear up my console. I'm currently using Node.js version 21.4.0 as of right now, the time of recording this video. However, there hasn't really been any major breaking changes with Express.js between different Node.js versions. So even if you're using an earlier version or a later version, you really won't run into any issues at all. So don't worry about that. So let's go ahead and type npm init -y to initialize this folder as an npm repository, and this will give us a package.json file that's generated for us. And let's go ahead and open up Visual Studio Code or whatever text editor you prefer to use. And let's just take a look at this package.json file. And there's nothing in here for the dependencies just yet. We need to install it. So let's go ahead and install Express. So I'm going to type npm I, or install. I is short for install, and then Express, and just hit enter. And now this will install Express for you. And that's it. That's the only package that we need to install. It's that simple. Let's go ahead and install actually one more tool for development. I'm going to install NodeMon. And what NodeMon allows you to do is run your application in watch mode. So as you're saving changes to your source code, the process will automatically restart based on file changes. So you don't have to manually exit out of the process and restart it again. So I'm going to install NodeMon as a dev dependency. So I'm going to use the -d flag, as you can see right down over here. Let me zoom in a little bit more. And I'll type NodeMon. Okay. And what I'm going to do is I'm going to set up a script. So right inside the scripts object, I'm going to set up a start:dev script. And this will use NodeMon to run our main JavaScript file. So that file doesn't exist yet. We need to create it, but I'm going to go ahead and create a folder called source in just a bit. And the main file will be called index.js. So this will be the entry point to our application. I'll create one more script called start, and this will just be a simple script to just use the regular node command to run our application. So not in watch mode. So this will typically be for production when you're ready to deploy the API. Now, there's one more thing that I want to do inside this package.json file. I'm going to go ahead and set this type property. And you can see that there's two values, common JS or module. I'm going to set it to module. And what this will allow me to do is use ESM as my module system. So that way I can use the modern import-export statements instead of having to use require to import modules and module that exports to export stuff. Because I'm using ESM modules, I need to actually change the file extension to MJS in order for this to work. So let's go ahead and do that. And don't worry, everything will still work fine. It really doesn't make much of a difference except for you have the latest modern versions of importing and exporting modules. That's really all it is for. Let's go ahead and continue. I'm going to go ahead and create a new folder called source src. And I'll create a new file called index.mjs. And now what we're going to do is we're going to import Express from Express, just like that. So I'm basically importing the entire Express module from this Express package. Now, the imported value of this Express name is actually a top-level function, and we need to call this function in order to create an Express application. So what I'm going to do is I'm going to first declare a variable. Let me zoom in a little bit more. I'll call it app, and then I'm just simply going to reference Express and then invoke that function by using parentheses, and that's all you have to do. Now that we have our Express app, I can reference the app variable, and whenever I use the dot operator, you can see that there are a bunch of different methods and properties that I can reference. Now, it might be a little bit overwhelming at first, but don't worry. The method that we need to call is the .listen method. And this pretty much allows you to listen to a port for incoming requests. This is actually what starts up the Express server on a specific port, and then you can begin receiving incoming HTTP requests. So let's go ahead and set a port. You can pass in really any port you want. I'm going to go ahead and pass in port 3000, but instead of just passing in a hard-coded number for the port, for best practice, it's best to assign your port to a variable called port in this case. And then you can reference process, which is a global in Node.js, and then process has an object called env. And from here, you can access your environment variables. So we would assume that there is going to be an environment variable for ports, but if the environment variable for port is undefined, then we can have it assign this left-hand value with our logical OR operator right over here. Let's go ahead and reference app now and call .listen and pass in port. And then I'm going to go ahead and pass in a callback function. So you can use this to perform post-processing operations once your server has started up. So maybe if you want to send an event to some centralized logging system, So that way they know that the server was just started up at this time. You can do that inside this callback function. However, I'll simply write a console log and I'll use string interpolation. And then I'll go ahead and write running on port and then I'll log the port. Okay, so let's go ahead and start up our application and make sure that it works. So I'll go into the terminal now and I'm going to run that start dev script. So let's type npm run start :dev, and now you're going to see that NodeMon will start up this application, and you can see that now it says running on port 3000. Now, if you want to test this out, you can simply just go to your web browser and just type localhost : and then the port number that you are listening to requests on. Since I'm listening to requests on port 3000, I would type localhost : port 3000. Right now you can see that it says cannot get, and this is because we don't have anything registered just yet. Okay, we need to actually register what's called a route in order for us to start requesting something from the server and then receiving a response. So hopefully this all makes sense. So now that you finally know how to set up a simple web server using Express.js, I'm going to show you how we can define routes and access those routes to receive different responses. But first of all, what exactly is a route? Well, think of it like this. Currently, we're trying to access localhost port 3000. Okay, and this was the base route. And we actually don't have anything set up to be returned from the base route. So whenever we try to access it, that's the reason why it said cannot get / because we didn't have any resolver to map a response back to that route. But a route in general is, think of it like a path in your Express application. So determining which path you want to take gives you different outputs. So for example, if you go to, let's say, the user's route, let's say if I have a user's route defined on my server, this will give me a list of users. If I wanted to get a list of products, I would access the products route. And all you do is you just add this / and then the name of the route at the end of the host name and the port. In actual real applications that are deployed, you typically don't have the port exposed like this, so it would just be after the host name, like something like localhost test.com/products. Okay, so you define these routes on your Express server, and then you allow your clients to make requests to those routes. Now, remember how in the introduction I mentioned in order to request data from the client to the backend server, you need to make an HTTP request? Well, there are actually different types of HTTP requests, and these are known as HTTP verbs. So these verbs pretty much are ways on how you can tell the server to perform some operation. So for example, you don't always want to just get data. Sometimes you might want to create data by saving it to the database once it's reached the server. Sometimes you want to update data. Sometimes you want to delete data. There are different types of request methods that we use to handle these operations, and you'll learn that later on. But first, let's go ahead and set up a simple GET request. So let's go ahead and reference the app. And we're going to go ahead and call this get method right over here. And it's going to take in an argument, which is going to be a string as the first argument. And right over here is where you can specify what route you want to register in your Express app. So currently I don't have any route handling the base / route. So I'm going to go ahead and configure a route for that. So whenever the user visits this route, they will receive a response. But we actually need another piece in order for this whole thing to work. We need what is called a request handler. And that is actually the second argument to app.get. So the request handler is just a function, but in this case, it's a callback function. So it would look like this. So I'll pass a simple arrow function. And this callback function has two arguments. Okay, it has a request argument, which is the request object itself. This contains everything related to the incoming HTTP request. So for example, if you passed in HTTP headers from the client side to the server side, that would be inside the headers property in the request object. If you were to send data in the request body, that would be accessed by grabbing it from the request body property. If you wanted to access cookies, if you want to access the IP address, all of this stuff comes from the request object. Okay. Now the second argument is the response object. The response object is what you can use to modify the response and send it back to the user. So you can set the status code as an example. You can send back data, you can send back text, you can send back HTML, you can send back text, you can send back HTML, you can send back a JSON object, whatever it is that you want. So let's go ahead and reference the response object to send back a response. So I can reference response and call the send method, and I'll just send back a simple hello world string, just simple plain text. So now if I visit the localhost port 3000, and if I go to just the base route, you can see it says hello world. Okay, pretty simple. I can go ahead and also send back a JSON object. I'll say hello. If I refresh, I now see it is parsed in this JSON format right over here. I can also set the status code as well, so I can do that very easily by referencing response.status. And this is a method, so you can just pass in whatever status code you want. I'll set it to, just for demonstration purposes, I'll set it to 201. 201 is actually used for post requests whenever you create a resource, but I just want to show you that this is what the status code is, because by default, the status code, whenever it is successful, is a 200 status code. Okay, and after you set the status code, you can actually chain these methods together. So after I call .status, I can also just call .send and then just pass in a response body. So now if I refresh, and let me open up the let's see, the network tab right over here. You can see that now the status code says 201. Let's go ahead and define a few more routes so that way you all get the hang of this. So I'll go ahead and define a route called /users. Now, whenever you are building APIs, you typically want to prefix all of your endpoints with a /API prefix. And this is industry standard. A lot of companies that have APIs do this. It's just good practice. So I would highly recommend you all to follow this approach. Okay, so /API/users. So this is now our route. So whenever we access this in our browser, we don't visit /users, we're visiting /API/users. Okay, so as a second argument, we need our request handler, of course. So let's pass in the request and response object. And what I'll do is I'll simply just send back an array of fake users. So I'm just going to pass in an array in the send method as an argument. And in my array, I'll just provide some users. So I'll set the ID to 1, username, Anson, display name, Anson. We'll keep it simple. I will just copy and paste this a few more times and just change up the values. So let's do Jack. And then Adam. Now let's save. Okay, and now whenever I go to the browser, and let me just kind of like move this over to the side a bit. When I go to /API/users, this is the route or the endpoint. I'm going to use those terms synonymously, route and endpoint. This is the route that I am going to be making a request to from the browser. In this case, the browser is our client. Okay, we're making a request to /API/users. And then when I hit enter, you can see as a response, this is what I get back. I get back this array, and this array has 3 users. Okay, and if you were getting this data, let's say on your React code, you would render this out to the client so they can actually see all the users. Okay, let's go ahead and create one more. Let's do app.get. Let's do /API/products. Request and response. So now you should get the hang of doing all of this. And the whole reason why I'm showing you multiple examples is that way so you are familiar with this. So once again, we have our endpoint, our route name defined right over here, /API/products. And then we also have our request handler, and I'm going to go ahead and send back a response now. So I will reference the response object, and I'm going to go ahead and call .send. And then what I'll do is I'll just send back a JSON object, which is in this case is going to be an array. And I'll do the same thing, ID of, let's do 1, 2, 3, username, or what am I doing? Not username. Let's do name. Let's do chicken breast. And then price. Let's do $12.99. Okay, and now if I go to the browser, and if I visit /API/products, so I'm making a request to this route, it's going to give me that array of products, and I can see this stuff right over here. So now what I will do is I'll show you how we can use route parameters to be able to dynamically pass data to the server in the route, and this can actually make it so that we can receive dynamic data based on whatever the value of that parameter is. So I'll give you an example. Right now, we are only able to receive all of the users. Let's just pretend that this users array comes from a database. We are receiving all of the users in an array. But what if I wanted to actually receive only one user based on some unique identifier, such as the username or the ID? How would I do that? Well, this is where route parameters come into play. You can use route parameters to pass in a dynamic value in the route path, and then the server would receive that request. It would check what the route parameter is, and then since we know that we're going to be dealing with users because we would be visiting /API/users, and then the route parameter would be placed after that, we would go ahead and grab the correct user from our database. In this case, we're going to grab it from our array. So the way that you define a route parameter is like this. So right underneath my API/users route, I'll go ahead and set up another one, but this time we will be using a route parameter. So I'll call app.get, and then /API/users, and then /, and then here's where I want to define my route parameter. What I can do is I can use the colon symbol and then give my route parameter a name. I'm going to go ahead and give the name ID, and then we're going to pass in a request handler. So the same thing that we've been doing so far. And now whenever I visit /API/users and then and then the ID, whatever I pass in, it's going to go ahead and hit this endpoint. So I have one endpoint or one route defined to give me all of the users. And then I have another route that has a route parameter that gives me a single user record based on the route parameter ID. Let's go ahead and do this. I'm going to show you first how I can grab that route parameter. And we do that by referencing it from the request object. So I can go ahead and console log this right now. If I reference request.params, this is an object that gives you all of the route parameters, because you can have multiple. You don't need to only necessarily have one. You might have more than one. You might have an ID, maybe you might have a username, but typically in this situation, we really only need one. So what I'll do is I'll console log this, and I'll go back to my browser, and I'll show you what happens when I visit /API/users, and then /1, and then let me show you the console. You can see that right over here, the console logged an object, and that object contained that route parameter as a field ID, and then it mapped to this value of 1. So hopefully that makes sense. So and again, like I said, I can pass in literally any value I want. I can pass in 500, and then whenever the server receives that request, it will log this object ID as a field of 500. So what I'll do is I'm going to go ahead and grab the user from the array by its ID. So let me just first take this array, and I'm going to move it up top over here, so that way I can reference it all throughout my code. Const mock users, and I'll assign it to this array. And then let me just send back that mock users array. And then what I'll do is a couple things. One, notice how if you looked at the logs, the value of ID is actually a string. But in our case, our users have a numeric ID. So we want to convert that into an actual number. And this is kind of like a brief little intro to how you can perform validation for your incoming GET requests. Okay, so what I'll do is I will create a variable called parsed ID, and I'm going to use the parse int method, and I'm just simply going to pass in request.params.id. But here's the other problem though. We don't know if the user even provided an ID at all. Well, if they didn't, then it would go to the API/user route. Like for example, if I didn't pass in an ID, it would just go to /API/users. So because this is the case, we don't really need to check if ID is defined because we know that it's going to be there. But we do need to make sure that the value is valid. In our case, we want to make sure it's a valid numeric value. So what I can do is I can parse this params.id value, and if it is a valid numeric string, then it'll convert it over to the actual integer itself. If it's some regular non-numeric string, then it will be not a number. So if I were to console log parsed ID, and then if I go to the browser and if I refresh, and I just pass in some invalid numeric or some non-numeric ID, in the console, it will log not a number, nan, which stands for not a number, for the parsed ID value. So we can use an if condition, and we can use this is not a number function, and then I can just pass in parsed ID. Okay, and in this case, since we're passing in an invalid ID, isNan would return true. So if it is not a number, then what I want to do is I want to return perhaps a status code that indicates that this is an invalid response or this is an invalid request. So what I'll do is I will return response, and I'm going to go ahead and call the status method, and I'll pass in for the code the number 400, which means bad request, and then I'll just simply call send, and then maybe an error message, bad request. Okay, and I can even add additional notes, invalid ID. All right, so now if it is in fact a valid number, then we can perform some operations. We can interact with our mock users array. So I'm going to go ahead and now write the logic to find the user. So const user or find user equals mock users, and I'll just simply use the find method, and I'll pass my predicate. So we're going to search based on the ID. So we're going to pass in this callback function, our predicate function, and we're going to have access to the user object that is currently in the array, and we'll check to see if user.id matches, so triple equals parsed, oh, whoops, I forgot this is actually parsed ID. Sorry about this. It's parsed ID, not parse ID. So parsed ID. Okay. And now, if the user does exist, well, let's do if the user does not exist, then I'll just return response. So we're going to do the same thing that we did above on line 29 right over here. So this is the point where you have different paths that your controllers or that your request handlers can take. So in our case, we have 3 different outputs, and later on around the end of this tutorial, you'll learn how to unit test these functions. But you can see right over here that currently I have 3 different outputs, whether the ID that I passed was invalid, so it sends back a 400, or if the user is not found, then we want to send back a 404 because that indicates not found. So I'll return response.status and pass in 404. Or there's also the I think there's a send status method, so that way I can just send the status and I don't have to call .send again at the end. And then if the user is found, then we'll just return response.send find user, just like this. So we have 3 different possibilities for this endpoint. Okay, so hopefully that makes sense. Now let's go ahead back into our app. If I refresh, you can see it says bad request invalid ID. If I pass in, let's say, an ID of a user that does not exist, it says not found, and you can see on the console, it gives us that 404. If I pass in an ID of 1, it finds the user, and I can see it right over here. And same thing, if I pass in 2 and 3, I get all of the users that are in that array. So hopefully that shows you how to use route parameters. So now I'm going to go ahead and talk about query strings and query parameters and how they are used in backend development and how we can actually use them ourselves. So many of you may have seen something at the end of the website address. So in the browser address URL, you might see this question mark, and then you might see something like key equals value. And then you might see an ampersand symbol, and you might see another key equals value. This is known as a query string. So right over here, this question mark symbol denotes that we have a query string, and they go at the end of our defined route over here. Okay, so you have the domain, and then the route, the path, and then the query string at the end. And then after the question mark, you basically just pass in whatever key value pairs you want. So for example, I have a key called key, and I use the equals operator to assign a value to it. So it's kind of like assigning a value to a variable, but only we're doing it in the address bar. So key equals value, and if I wanted more query parameters in the query string, I can just simply use this ampersand as a delimiter. So ampersand, and then the next key value pair, so key 2 equals value 2. I can have as many query parameters as I want. Now, there are different ways that you can use query parameters in web development. You can send query parameters from a page to another page on the client side, so that way you can send data across different pages. So let's say if one page needs data from another page, when you're navigating, then you can grab the values from the query string. If you're sending it from the client side to the server side, typically you would send a query string to add additional data to the request that you normally wouldn't add in a request body. We haven't gone to post requests just yet, but I'll stick to a GET request as an example. So when you make a GET request, remember that you are performing a request, an HTTP request, to get data in read-only format. You're not manipulating any data at all on the server side. So sometimes you might need to retrieve the data, but you also want to have that data already manipulated in a certain way on the server side. So for example, up top over here, I added a couple more user objects. So let's say I have this users array, and let's pretend it's from the database. And let's say I want all of these users returned back, but I wanted it sorted in alphabetical order based on the username, or you can also have it sorted based on the display name. Maybe you might also want it sorted in from least to greatest based on the ID value, since these IDs are integers. So you would use a query string to do that. Let's say if you also want to filter out some results from the users itself, maybe you don't want to get every single user from the database. You only want to get only specific users that match, where their username matches a substring. So maybe I only want to get all the users that have an A in their username field. So hopefully that makes sense with query parameters and how they can be used. So let's go ahead and see how we can actually send query strings and query parameters to our server. So inside my /API/users route, inside the request handler function, I'm going to go ahead and console log this request.query object. Remember how I said earlier, the request object has everything that you can possibly get in regards to the request itself. So earlier we referenced request.params to get the route parameter. So to get the query parameters from the query string, we just reference request.query. So let's go ahead and send a query string when we are making this request to the /users endpoint. So I'm going to use the question mark symbol and then provide some key value pairs. I can literally pass any key value pair I want. So let's do something like filter, and we'll assume the filter is going to be based on username. So I'll do filter Anson, and I'll go into my console. Let me actually just rerun the request. So you see how whenever I send a request, a GET request to that endpoint, in the console, it logs that request query object. And it has the filter, which is the key that I passed in, the query parameter filter. It is showing up as a field in that object, that query object. And we have the string Anson as the value. So the query string gets parsed into a JSON object by Express, so we can very easily grab the values. Let's go ahead and actually do something realistic with the filtering. So what I'll do is this. I want to make it so that I can filter based on some substring. So I want to go ahead and also make it so that I can also set which field in this mock users array in these objects. I want to make sure I can set which field I want to filter on. So maybe I want to alternate between filtering by username or display name. So for the filter value, we can expect it to only be two possible values, username or display name. And this will tell us what key in the user object, what field to filter by, or yeah, what field to filter. And then we will add an additional query parameter. You can call it whatever you want, but I guess we can call it a value just to keep things simple. And then this value will basically be the text, the substring that you want to have that username contain. So if I want to filter everything where it contains the AN substring, so AN substring, then we would have to search for that. Okay, so I'm going to send these two query parameters to the server. Okay, so now I'm going to go back to the request handler for the user's endpoint. And what I'll do is this. I'm going to destructure that query object from the request object. And then I also want to destructure from the query object the two query parameters, filter and value. And I can do that all in one go like this. So after query, I can additionally destructure properties from query. So let's do filter and value. And so what I want to do is I want to make sure that both of these query parameters exist, because of course, if they don't exist, then we're not going to do any filtering at all. So the easiest case that we can handle is we check to see if both of these values are undefined, because if they are, then we don't need to do any filtering. We can just return mock users as is. So you write an if case. If there's no filter and there's no value, then we will just simply return response.send and then call, or not call, pass in mock users in this .send method call. Okay, that's the easiest case. I'll write a simple comment when filter and value are undefined. Okay? And we always want to make sure that both of these query parameters are defined, because you need both of them, of course. You can't have a value and not know what field in the user object you want to filter by. And if you have the filter query parameter defined, you need to make sure you have an actual text that you want to filter based on. So we need to make sure that both of these are defined. So we'll do if filter and value. If filter and value, we will return, and we'll call response.send. And from here, I should just be able to write a simple filter function. So mock users, I can use the filter function on the array and pass in a predicate. So what we're going to do is we're going to pass in this callback function, also known as a predicate function. And this callback function has the user as an argument. And then what we want to do is we want to filter out all the user objects that match, that have that value as a substring. So it's pretty easy. We can do user.username, because remember we're filtering by the username. Or actually, it would be user square brackets filter. Okay, and this is assuming that filter would either be display name or username. So user filter. So this would grab the correct field, and then we would want to. So this is going to be a string. So we would want to make sure we check to see if the string contains that substring. So we actually have this includes, and this method returns true if search string appears as a substring of the result of converting this object to a string. Okay, so I can pretty much call .includes and I'll pass in the value. So this will filter this will basically grab all of the user objects that pass this predicate. So if the user, and whether we are filtering by username or display name, if, let's say, for example, let's stick with username. If the username includes the value that we're trying to filter, then it's going to return that into a new array. And then once all of the filtering is done, we're going to send the entire array back. So let's go ahead and test this out. So right now, let's do this. If I don't have any of the query parameters at all, you can see that it will just return the array as is. Okay, it doesn't do anything. We have everything sorted. We have everything the way it is. Nothing is sorted. Nothing is done. Let's go ahead and add a filter. So let's filter by username. And now notice how if I were to only have the filter but no value, you'll see how it doesn't return anything yet. The request is still pending. That's because we need both filter and value. Okay, we'll handle these cases as well. So let's go ahead and handle the case where we have both filter and value as a query parameter. So for the value query parameter, I will set this to be an. And now you'll see this will grab me all of the user objects where the username has an as a substring. And if you look right over here, it seems to be filtering correctly. I can go ahead and do another simple case where let's filter the username where it includes E as a substring. And you can see that it seems like the only username that I have that has an E as a substring is Henry. Okay, let's see what else. Let's try A. I have 1, 2, 3, 4, 5. So it's missing this object, Henry. So our filtering is working great. Okay, well, so let's just finish this out. So let's make sure we handle all the other cases where if we don't have both of these defined, then we return the same mock users that is in memory, so we don't do any filtering at all. So I think the easy thing to do is actually this. Instead of doing this if check right up here, where we check both a filter and where we check if there's no filter and there's no value, what we'll do is we'll check if there's a filter and if there's a value. And if this condition fails, and that means it only has one or the other defined, or both are undefined, so then we'll just return response.send mock users. So I just realized that. So I'm going to fix that real quick. And now when I go back to the browser, if I only have one query parameter, it won't do any filtering at all. Okay, hopefully this makes sense. Now that you all know how to retrieve data from the Express API using GET requests, I'm going to show you how you can create data using what is called a POST request. Now, let's say, for example, you want to create a resource on the backend, and that backend will save it to a database or save it to a file or save it just somewhere. Doesn't matter where it is. You want to create, let's say, a user. So your client, your front-end application will have a user form. They fill out their username, password, email, and other additional fields. Once they are ready, they will click that sign up button. When you click that sign up button, it will make an API request to the backend. Doesn't have to be necessarily an Express API server. It can be really any API server that's running that handles that POST request. Okay, so the front end, the client side, would make an HTTP request, a POST request to the server. Okay, once the server receives that request, the server needs to obviously be able to grab the data that we're trying to send from the client side to the backend. And that data that you're sending is known as a request body. So whenever you make POST requests, the data that you want to send to the backend server, you send it via a payload or a request body. You use those terms synonymously. So payload, request body are interchangeable terms. The backend will then take that data and it will perform the necessary operations it needs. So typically validation, if it needs to do additional parsing, if it needs to make sure that it has the proper fields. It will do all that stuff before it can proceed with either saving it to a database or saving it to some external API source, whatever it is that it needs to do. Once it's done saving that record to the database or somewhere, it will return a 201 response, or a 201 status code, which typically just means that the resource was created. Sometimes it might also return the new record that was created, so that way if you need to use it on the client side for whatever reason, you can do so. Now, before we actually can make any post requests, we do need an HTTP client to actually make those requests and also be able to send a request body to our Express API. Because on the browser, there's no built-in tool that enables you to send request bodies, unless if you to write the code in the JavaScript console, but we're not going to do that. So there are different clients that you can use to interact with your API. So currently we've just been using the browser, which we're limited to just making GET requests by simply typing in the address in the address bar. We want to be able to make post requests where we can send actual data. Okay, so you can use tools like Postman. There's also Hopscotch, which is an alternative to Postman. For this tutorial, I'm going to keep things simple. I'm going to keep everything inside VS Code. And we're going to install this extension. So on the left-hand side, or wherever you have this extensions icon, just click on extensions. And you want to search for an extension called Thunder Client. And Thunder Client is a very lightweight REST API tool for VS Code. It's integrated in there. You just have to install it. And it allows you to make API calls to your Express server. So I'll go ahead and click install. Okay. And then I'm going to go just close this. And then let's go ahead. On the left-hand side, you should see the Thunder Client appear right over here as an icon. That's the Thunder Client. And I'll click on it. And now what I can do is I can create a new request by clicking on the new request button. And you can see now it looks kind of identical to Postman if you've used it before, or really any other REST client. But we have an address bar where we can type in the address or the URL that we want to make requests to. So I'll type in localhost port 3000 /API/users. I'll make a GET request, so I can select this dropdown and select GET, and I'll click send, and you can see that it gives us back the data just like that. Okay, and we're going to use this client to switch between different types of HTTP requests that we want to make. So we'll switch from GET to POST, and then in later videos when I show you how to handle put requests or delete requests, we will switch to these HTTP requests as well. Okay, so let's close this out. Just wanted to show you all how to set up Thunder Client. So now what I'm going to do is set up our post request to be able to create a brand new user. So what I'm going to do is right underneath my API/users route, I'll go ahead and reference the app variable. And since I want to register a post request, I'm going to go ahead and call the post method. So this method is very similar to all of the other HTTP verb methods such as get, put, delete. It takes in a path. So over here, I'm going to go ahead and pass in /API/users. Now you're probably wondering, well, should we be able to reuse the path? And the answer is yes, because you have a different HTTP request type being used. So this is for post request, and the one over here is for GET requests. Okay, when your HTTP client is making requests, the server knows if it's making a GET or a POST request. So that way there's no confliction between these two different types of requests, despite the route being the same. So we'll also pass in a request and response, or we'll pass in the request handler function, which will have these two arguments, request and response. And then for now, I will just return a response.send. I'll just pass in a 200 status code, or I'll just pass in 200. And I'll just console log the request body, just so that we can see what our data is looking like when we send it from the client. So let's go back to Thunder Client. So I'll click on the Thunderbolt icon. I'll click on new request, and up top where you see gets, just click on that drop down and select post, and we're going to change the URL, and we're going to type in localhost port 3000 /API/users. Okay, so once again we have two different types of HTTP methods, but they both use the same path. Okay, so whenever I call a post request to /API/users, I don't even need to send any data for now. It's just going to give me back a 200 status code. Now I can go into the body tab in my Thunder client, and I can select JSON if I want to send JSON. So if I try to send a request body, let's see what happens. Let's click send. So in the console log in our terminal, you can see that right now it's actually logging undefined. When I try to send it again, it still logs undefined. And you're probably wondering, well, what's going on with this? Why is it undefined? Well, the reason why it's undefined is because right now, by default, Express is not parsing those request bodies that are coming in. So whenever I am sending JSON to the Express server, the headers set the content type to application/JSON. Express doesn't parse those payloads by default, so we need to tell Express to do so. Now this is going to require us to use a middleware, so this is kind of like a brief little intro to middlewares, but don't worry so much about it. Once we actually get into the topic of middlewares, you'll better understand how they work. But all a middleware is just a function that is going to be invoked before certain API requests are being handled. So in my case, I want to make sure that right before my post request is being received, I want to make sure that that middleware that parses the JSON payload accordingly is being invoked. So you would typically want to register your middleware as early as possible. So the best way to do it is doing it up top after you create your Express app instance. So I'm going to go ahead and reference app, and I'm going to call the use method. And this is the method that you use to register middleware. And the middleware that we're going to register is actually already built into Express. So I can just reference Express and call this JSON method. Okay, so now you can even read over here, it looks at requests where the content type header matches the type option. So in this case, this is express.json. There's also other things that you can parse too. Like let's say if you're trying to send text, or if you're trying to send URL encoded or raw data. So hopefully that makes sense. So in our case, we'll keep it as JSON. And let's go ahead and see what happens if I send the request again. So let's go back into our Thunder client. I'll click send. I'll just click it again. And now watch this. You can see that in the console, it is logging that request request body that I am sending to the Express server. And I can literally add as many fields as I want. I can add a display name. Let's do Anson the dev. Click send again. And you can see that it is being logged right over here. Okay, perfect. All right, cool. Now let's go ahead and actually do something with the data. So like I said, right now we don't have an actual database. So all I'm going to do is just push this user to the array. So to do that, what we'll do is we'll assume that the request body is valid. But then in the next section, I'm going to show you how we can actually validate the request body. So I'm going to go ahead and create a variable called new user equals. So we need to actually grab all of the fields from the request body, but we also need to attach an ID to the request body. And once again, since we don't have a database to manage our IDs, because typically the database is responsible for generating those IDs, all I'm going to do is just take the last element, the last user in the mock user array, take the ID of that last user, add 1 to it, and assign that to the new user, the new user's ID. Okay, so what I'll do is I'll first do this mock users. So I'm just going to reference mock users, and then I'm going to want to get the last element. So mock users dot length -1. Okay, so the length of our array is going to be 7. And I want to reference the last element, so that's going to be at index 6, because remember, arrays are 0 indexed. And then we're going to reference ID and just add 1. I know this is kind of like a hacky way to do it, but I'm just doing it just for a very simple example. And then what I'll do is I'm just going to assign, or I'm going to destructure the request body. So I'm going to destructure body from the request object. And then I'll just simply use the spreader operator on the body object to take all of the fields from the body object and unpack it into this new object that I am creating that is assigned to new user. And then I'm just going to reference mock users.push new user. And then I'm going to go and just return the new user. And remember, we want to send back a status code of 200, or I'm sorry, 201, because if I were to send this right now, you can see that I do get back the user, but it sends me back a 200. And for good practice, you want to make sure the post request sends a 201. So I can just set response.status, call the status method, and pass in 201, and then call .send. So we did this in an earlier part of the tutorial where we were making GET requests right over here. Okay, so let's go ahead and test this out. Click send. All right, so you can see whenever I click send, it will just keep creating a new user, and it'll send it back to the client, which is this Thunder client, as a response, and it has the ID auto incremented. So that's pretty cool. All right, so aside from GET requests and POST requests, there are also a bunch of other HTTP request methods that you can use to handle in your Express API. However, you don't need to know all of them, but there are 3 others that I think is worth knowing about, okay? Because you will be seeing them everywhere in documentation when you're working with APIs, and you yourself will need to use it as well. So let's talk about it. So the other 3 are the put request, patch request, and delete request methods. Okay, put and patch requests both are used to update data, but they are technically different on how you update data. So to better understand put requests, let's first talk about patch request first. So let's say, for example, you want to update some data on the backend. Using our users example, let's say I want to update one of my users' username. So maybe I want to change my username from Anson to Anson123. I would do that using a patch request. Okay, a patch request updates a record, but it updates it partially. And what that means is you're not updating the entire user itself, you're only updating a partial field, you're only updating a portion of that entire user record. So instead of updating everything of that user record, you're only updating username. You're not updating username and display name. Okay? So hopefully that part makes sense. Now with put request, you're not actually just updating a partial entity of that record, you're updating the entire resource. Okay? So whenever you make a request to update something on the database using a put request, you're including every single field in that request body, even if you're not updating it, because if you don't include that field, then those fields will pretty much be removed. Or if you're using like a SQL database, those fields will be null. So the next time you fetch the data, those fields will always be null. Of course, if you're using MongoDB, they'll just be updated in the document and they won't even appear at all. So hopefully that makes sense. So think of it like this. Put is for updating the entire record. Okay, so even if you only care about updating username, but you don't want to update display name, then what you need to do is when you update the username to whatever it is that you want, you need to make sure that you include the current value of whatever display name is, otherwise it will be overridden. With patch, you can pretty much just update only a portion of that user record. So you don't need to include anything that you're not trying to update. So if you update only the display name, you only include the display name in the request body. You don't need to include the username. And if you only want to update the username, then you don't include the display name. So hopefully that helps you better understand the difference between put and patch. Delete is pretty straightforward. It's used to pretty much just delete records from the database. Okay, so you only really use it if you need to delete a resource, whether you're deleting a user or if you're deleting a product or an order, whatever it is. Okay, so hopefully that explanation makes sense. So let's go ahead and set up a put request for updating a user by its ID. So we're going to reference app and call the put method. And for the path, I'm going to reuse the path that we used earlier for our get users by ID request. So I'll just copy this up top over here and paste this over here. And like I said before, we can use the same path, but as long as we have different request methods, it will still work fine. Okay. And we'll now pass in the request handler function as a second argument in the put method call. So now we also need to make sure we are grabbing the route parameter from the request body or from the request object. And we also want to make sure we're grabbing the request body as well from the request object. So let's do some destructuring. So I'll go ahead and from the request object, I will go ahead and destructure body. So I'm going to get the request body because we need that, because that is what is to contain the data that we're using to update the current user object. And then I'm also going to destructure the params object, and then from the params object right over here, I'm going to destructure ID just like that. Now let's go ahead and parse the ID, convert it into an integer, and check to see if it is not a number. So that way we ensure that we're only passing in numeric strings, and then we can convert them accordingly. So const parsed ID equals parse int ID, just like that. And then we'll use the is not a number function to check if parsed ID is not a number. So if this condition is true, if parsed ID is not a number, then we want to return response.sendStatus, and we'll just do 400, which just means invalid, a bad request. Okay, and now we can continue. So what we'll do next is we want to find the user that we're trying to update, but we want to get the user's index though. We don't actually need to get the user object, just the user index. And even with the index itself, we can use the index to retrieve the user by referencing it using the square bracket operator on the array itself. So I'll show you what I mean by that. So first, let's grab the index of where the user is located. So I'll call this const find user index. And then we'll reference mock users, and I'll call find index. So now we'll pass in a predicate function, and we want to search for the user by its ID. So I'm going to reference user, which is this argument in the predicate callback function. And then we'll search for the user by its ID. So user.id is equal to parsed ID. Okay, not ID, but parsed ID, because we just converted it from a numeric string into an actual string. So now what we'll do is we do need to check to make sure that the index is not -1, because if we actually don't find this user, if this predicate returns false, then that means the return value of find index is actually -1, which means that that user is not found by its ID. So we'll check if find user index is equal to -1, and we'll return a status code of 404. So response.sendStatus 404 if find user index is equal to -1. So if find user index is not -1, that means we actually were able to get the index of the user based on the predicate function right over here. So that means we can use find user index to access the user that we're trying to update. Okay, so hopefully that makes sense. Now let's go ahead and do this. Let's go ahead and reference mock users, and then we'll use the square bracket operator and pass in find user index in between the square brackets, just like this. So this allows me to access the element at the mock users array by its index. And remember, we're updating this entire user object. So I can just simply assign this user object to whatever this object is. Now keep in mind that since we are using a put request, remember we are updating the entire object itself. We're not updating only one or two fields, we're updating the entire thing. Okay? And we're updating the entire thing based on whatever the request body is. So let's say, for example, if the request body is missing certain properties, but those properties are currently existing on that user we're trying to update, then that means those properties will no longer be on the user once we update it. But there are some properties, though, that you never will update at all. So, for example, if you're using a database and once we do get to it, you'll see that we're never going to actually modify the ID at all, because the ID is auto-generated by the database server. So let's leave the ID alone. So I'll keep the ID as parsed ID, just like this. But everything else, all of the other fields will come from the request body object, which is this body object right over here. So I'm going to just destructure body, so that'll take all the fields from the body object, unpack it, and put it into this new object right over here. Okay, and since we are not going to be passing in the ID in the request body, that's also okay as well. Okay, so what we just did was we kept the ID the same, and whatever the user passed in the request body is going to be used to update the user. Okay, so if there were values that we did not include in a request body, well, they are now gone, assuming that the user had those values defined. So let's go ahead and finally return a response. Let's send a status code, send status of, let's just do 200. You can send 200 or 204, but I'll just keep it simple and send 200. And now let's go ahead and click new request. Let's select put, and let's change this to localhost port 3000 /API/users. And now we're going to go ahead and update the user using a put request by the ID. So currently we only have 7 users. Let's update Jack. So the ID is 2. So for the route parameter, we're going to pass 2. And remember, make sure you have put request selected. We're going to go ahead and select the body tab, and let's pass a request payload or request body. So remember this, okay? We are trying to update Jack, this user object that has the ID of 2, username Jack, and display name Jack. If I want to only update, let's say, the username, but I don't want to update display name with a put request, then I must include all of the current values as well. Okay, so for example, let's update username. So let's update it from Jack to Jackie or Jackson, and let's keep the display name as Jack. So we'll assume that we're using the same value, which we are. Click send, and you can see we get a 200. Okay. Let's go ahead and make a get request. So let's do new request, get the user by ID of 2. You can see now we updated the username, but we also did override the display name because we passed that in as the request object. We passed that in the request object as well. But now watch this. If I omit display name and then I click send, now watch this. When I request the user by ID of 2, you can see that it only gives me the correct user, but we only have username now. Okay, that's because we omitted the display name, and so that just pretty much gets removed. Okay, it's pretty much just taking the request body and using that request body to update the entire user object as a whole. Of course, we're never updating the ID as well. Now watch this. If I remove username and I click send, and if I try to get the user of ID 2, it just gives me this object with only the ID field. So hopefully you're starting to understand what exactly the put request is. Now, of course, if this is not what you're trying to do and you only want to update a partial part of the user object, so you only want to update the username field without having to worrying about passing in the display name or other fields, because your user field can have, your user object can have a lot of different fields, and it can be a nuisance to pass all of those fields in the request body. So this is where patch comes in. Okay, so we'll work on the patch request next. But I just wanted to show you this as well. If I were to just pass in a invalid ID, it's going to give me a bad request. If I pass in a valid numeric value, but that ID did not exist in the array, or that user cannot be found in the array, it's going to give me 4 not found. So that is good. Okay, cool. Yeah, so hopefully that makes sense. All right, so let's go ahead and set up a patch request. So patch request basically allows us to update an entity or a resource or a record, whatever you want to call it, partially. Okay, so in the put request example, we are updating the entire resource based on whatever we provide in the request body. So everything just gets updated as a whole. For the patch request, we only want to be able to update either 1 or 2 or just a partial amount of fields without having to include every single field in the record that we're trying to update. Okay, because it can become annoying if you have, let's say, a user with 10 different fields and you don't want to include that all the time. So let's go ahead and set up a patch request. So app.patch/API/users. So we're going to reuse the same path, of course, because we can, since we're using a different request method. And then let's go ahead and pass in the request handler function in the as a second argument for the patch call. And since we're going to do the same thing with the check for the ID, for the route ID, sorry, the route parameter ID, I'm just going to go ahead and copy actually most of the stuff up over here, but I will explain again for those of you who are watching just the segmented part of the entire Express.js tutorial, because I have this in a about like a 1 hour to 1.5 hour long video, and also in its own individual videos as well. So in case you are not watching the entire tutorial series, so what we're doing here is we are destructuring the request body object as well as the route parameter object, and then from the route parameter object I'm destructuring the ID, all from the request object. Okay, then I'm going to parse the ID. So I'm basically taking the ID, which I'm expecting it to be a numeric value, so I use the parseInt function to ensure that when I pass in the ID, the return value of parseInt or of parseInt with that ID gives me a valid numeric value. So we use the isNaN function to check to make sure that parse ID was parsed correctly and is not a number, because if you were to pass in a string, let's say, just random name instead of a number, then parse ID would resolve into nan, which is not a number, so we would return response.sendStatus. Then what we're doing over here on this line, which is identical to what we did up here in the put request, is we're just simply searching for the user in the mock users array based on the ID. And that's where this whole line comes in. We pretty much just check if user.id is equal to parse ID. Okay, and additionally, if find user index, if its value is -1, that means find index, the method call, was not able to find that user by the ID. So that predicate failed, so it was not able to find the user, so it returns -1. But if it returns anything but -1, then that means it was able to find the user. So hopefully that makes sense. So we do this check right over here. If find user index equals -1, then we return a status code of 404, because that means the user was not found. So hopefully that makes sense. I didn't want to have to rewrite that whole thing again, but I hope it is straightforward. So, and if it is a little bit confusing, just rewatch the previous video on the put request, so that way you understand. But that, I only did that for people who are watching the segmented part. Okay, so now the major difference here is the way that we update the user record. In the pull request, we updated the entire thing. You can see the only thing that we did not update, of course, was the ID, but we took the entire request body and we pretty much just put it into took all the field values and put it into this new object, and took that object and assigned it to, well, we overrid the current existing user. Okay, in the patch request, we're not going to override every single field. So the body itself, the request body, might only contain, let's say, one field that we're trying to update. So any current field values that are in that user record must not be touched at all. So they must stay the same. So the way we can do that is, first let's reference mock users and pass in the square brackets find user index. So that way this is the user that we're trying to update. And what we're going to do is this. We're going to go ahead and we're going to copy this mock users find user index. I'm going to reference it. I'm going to use the spreader operator on this mock users reference at find user index. Okay, so I'm going to take all of the current field value pairs and put it into this new object. So all of the current values will be inside this new object. And then I am going to take all of the field value pairs from the request body, use the spreader operator on it, and put it into this new object. So basically what I'm doing is this. I'm taking the existing user currently that we're trying to update, taking all of its key value pairs, putting it into a new object. Then I want to take the request body and all of its key value pairs that we are using to update the actual user and unpack it and put it into this new object. So that way it will override those current values. Okay. So imagine if you had the current user, let's say, for example, right over here, the current user is currently ID of 3, username Adam, display name Adam. I'm taking all of this data right over here, putting it in that new object, and then the request body would have whatever key value pairs that we were sending over to the server. So if we sent username, it would override, it would use the request body's username field and override it with the current username field. So Adam would get overridden with whatever we passed in for the request body. Okay, and if we didn't pass in the display name, that's okay, because display name would not be touched at all and it would stay the same. So hopefully that makes sense. And let's go ahead and just return, let's do send status of 200, because we can also send either 200 or 204 as a status code for patch as well. So let's actually try to use the patch request. So first, let's grab all the users. Let's make sure everything is okay. So I'll go ahead and update Jack, but this time we'll use a patch request. So I'll just change it from put to patch. The ID is going to be number 2. Okay, so now watch this. When I use the patch request, I'm going to update the username from Jack to Jackson. Okay, we got a 200 okay status. Now watch this. When I make a GET request, you'll see that username is updated and display name stays the same. Now remember, in the put request, if I don't include the display name will be overridden. Okay, with the patch request, I can only update what I just want to update. I don't have to include display name and put a value for it. I can just update username, and then only username gets updated. If I only want to update display name, let's do display name to Jackson. I can just update the display name. If I want to update both, so let's update both back to Jack. Oops, not password. Display name, Jack. Okay, click send, and you can see now both fields get updated. So hopefully this helps you understand the difference between put and patch requests. You use both of them to update data, but the way that you update the data is different. Remember, put is used to update the entire resource. In our case, we would use put to update the entire user object. Patch is used to update only certain fields on that user object. Okay, so hopefully that makes sense. All right, so now we will take a look at the delete request method. So it's pretty easy to use delete, and it's pretty straightforward. You just use it to delete stuff on the backend server. And the backend server typically deletes it from a data source like a SQL server or MongoDB, any general database. So what we'll do is we'll reference app and call the delete method. And I'm going to reuse the same path because it doesn't make sense to not reuse it. So now we have /API/users/:ID for the route parameter. And we have this path registered with a delete method. We'll pass in the request handler callback function. Now with delete requests, you actually typically don't need to pass a request body. You can if you need to. Perhaps you might need to provide extra data in the request body. So just wanted to point that out as well. But typically, if you're just deleting stuff, it's pretty straightforward. So you don't really need to provide, like a payload. But if there's other things that you would like to do on the server side and it requires data in the payload, then you can definitely pass a request body. So we'll do the same thing. We'll go ahead and grab the route parameter. So I'm going to do the same thing that I did earlier for the patch request and the put request. I'll simply just destructure request.params. I'll destructure the ID from request.params. Actually, I'll do it like this. Params ID, just like that. It looks more cleaner. And then what I'll do is I'll parse the ID to make sure it is a valid numeric ID. So const parse ID equals parse int ID. And then we'll do the if is nan check. We want to make sure that parse ID, if it is not a number, then we want to return a response with a status code of 400, which means invalid, which just means bad request, which is because of the invalid ID. Okay, so now we want to, of course, just remove the user from the array itself. Or if you're using a database, once we get to that, we would actually remove the user from the database. In our case, we have to remove the user from the in-memory array. So what we can do is this. So I'll go ahead and use the splice method. And what I need to do is I need to get the index of the user that we're trying to remove. So let's do that. So we want to get the index, and then we'll pass it into splice, and that'll just remove the user from the array. So let's do this. Const find user index, mock users find index. And I'm going to go ahead and pass the predicate function, which is just going to find the user by its ID. And remember, find index will return -1 if we're not able to actually find the user at all in the array. So we need to do a check to see if find user index is equal to -1. And if it is, we'll do the same that we did in our patch input request. We'll return response.send status, and we'll do 404 because we can't find the user. All right, so now that we were able to handle this case, at this point we know that the user, we have the user index of where they are located. So what I can do is I can call mock users.splice, pass in starts. And I don't think we need delete count because it will just remove the element from the array. I think it will just remove only one, I think. Okay, hopefully that makes sense. And now what I can do is I'll just return response.send status 200. And let's see what happens. So let's go into our Thunder client. Let's click new request. We'll make a request. We'll make a delete request. So I'm going to select the delete method. And let's do localhost/API/users. I want to delete user with ID number 2. So I'm going to pass number 2 as the route parameter. And we're not going to put any request body. We're not going to send any request body. Let's see. Parse is not defined. Did I mess something up? Let's see. Oh, whoops, I forgot to change this to, I forgot to write the rest out. It's parsed ID, not parse ID or parse. Yep, sorry about that. Yeah, this is kind of this is one of the downsides of JavaScript. I do need a linter though, I agree. with needing a linter to detect these issues, but it's okay. We fixed it, and let's go and run our app again. So going back to VS Code in the Thunder client, I'm going to go ahead and click send, and let's just see if I can get the user by its ID. So it says 44 not found. Let's make sure the user's array is valid. Let's see. So it seems like okay, so I know what the problem is. So it seems like it's spliced everything starting at the index. So we actually only need to delete. We need to specify the delete count, because I think it removes everything after that index. So let me actually fix that. So we have all of our users. Let's try to delete the user. So delete. Okay, and let's try to get all the users again. Okay, so all of our users are here. I'm not sure why, though, it is returning as gray this time. That's kind of weird, if you ask me. But if I try to get the user by its ID, it's not found. But I can grab the other users. Okay, so that works. So that's pretty cool. And you can see that in the browser, I don't have the user by its ID anymore. So let's just delete a couple more. Let's delete 3. If I refresh, I don't have user of ID 3 anymore. Let's delete user number 1. Okay, so now I'm only down to 4 users left. So that is pretty much how you can use the delete method. Okay, so hopefully this makes sense, and hopefully you now better understand how to use all 5 of these HTTP request methods. We have went over GET requests, POST requests, we went over PUT requests and PATCH requests, and then finally we went over delete requests. Now, if you want to see a list of more HTTP request methods, you can go over to the Mozilla docs over here. You just Google this HTTP request methods. You can see that there are GET requests. There's also a head method as well. But, you know, you don't really use these that much, but sometimes you will use them. There's also the connect method, options, trace. I personally have never really used these that much, but there might come a case where you do need it. But in that case, you can just read up about it and, you know, see what you're supposed to do with these methods and use it accordingly. All right, so now I'm going to go ahead and teach you all about how middleware works in Express.js. Keep in mind that middleware can be defined differently in different environments, but in the general sense, it really just means one thing, and that means it's just a middle process between one or two or many different functions or other processes. So in the context of Express.js, a middleware is just a function that can have logic, but the middleware function also is a request handler as well. So that middleware function has the request response arguments as well. And you can actually use the middleware function to return a response if you want to. So I'll show you a simple example of what a middleware function could look like. So I'll create a simple function. I'll call this logging middleware. And remember, this middleware function will have access to the request and response objects as arguments. Okay? And additionally, the middleware function or the request handler function also has access to this next argument, which is a function that you call when you are done with the middleware. Okay? So what I'll do in this simple example is I'll console log 2 things. I will console log the request method, and then I'll console log the request URL. Okay, and then once I'm done with logging that to the console, I'm just going to call next, and that's it. In order to now use my middleware, there's 2 ways. I can enable it globally, so all of my routes will have this middleware be invoked right before its request handler is called, or I can enable it for each specific endpoint. So I'll show you both examples. So let's call app.use to register our middleware globally. So all I do is I just pass in logging middleware as a function or as an argument like this. Okay. Now, if I were to go into, let's say, my browser, if I visit the base URL of our application, you can see that in the console, it now logs the request type, so gets, it logs gets and then the URL that we're trying to visit. If I go to /API/users, it will go ahead and log that as well. If I were to make any request to any endpoint, it's going to log that. Okay, so it is enabled globally. If I only want this middleware to occur for only certain endpoints, so instead of logging it globally, or instead of registering globally, I want to take this middleware. Let's say I only want to do it for this base URL. So what I can do is I can pass that middleware function as an argument like this. Okay, so now if I go back to, let's just go to /API/users, and you'll see that nothing is being logged. However, the moment I go to the base URL and make a request there, it logs it to the console, so that is good. Now, one more thing to mention is that you don't even need to assign it to a variable and pass it in like this. You could just pass it in like this if you really wanted to, and then pass in the arguments, request, response, next. Okay, now one thing to mention is that if you don't have the next function and if you don't call it, it's not going to go ahead and call the next middleware. So in this situation right over here, I have two middleware functions. Let's call this one middleware A. Okay, middleware A will be called first, and then after middleware A is called, it has the option, notice how I said option, to call the next middleware. The reason why I say it has the option is because in this middleware, you can control the request and send back the response if you need to. So this allows you to write additional logic that you can reuse for different endpoints that might share that same logic. And let's say, for example, if the incoming request is missing some kind of authorization token, you don't want to continue to the next middleware or the next request handler. So you want to reject that request by sending back maybe like a status code of 401. Okay, so for example, what I'll do is I'll just simply log base URL, and I'm not going to call the next function. Now watch what happens. If I refresh, you'll see how it is stuck in this pending state. And it does log base URL, but the client never receives a response back. That's because we're not calling the next function. So you need to make sure you call the next function in order for it to call the next middleware down the chain. Okay, you can have as many middlewares as you want called in sequential order. So I can even add two more like this. And then I'll just call next after each one. And if I refresh, and if I look at the logs, you can see every single middleware was called. And let me add 1, 2, and 3. So you can see that it is called in sequential order. Base URL 1, 2, and 3, all being logged in sequential order. So hopefully that makes sense. Another thing that I also want to mention is middleware must be registered before a route if you're using app.use to register it. So what I mean by that is if you want a middleware to be registered for all of your routes, you need to make sure that you call app.use right before you call, app.get, app.post, app.put, etc. Okay? If you were to register the middleware, let's say after you called those app.post and app.get methods, your middleware is not going to be registered for those routes. So order matters in this case. So I'll show you an example. Let's say I'm going to go after /API/users. I'm going to go ahead and call app.use right over here on line 44 and pass in the logging middleware. So what I'm doing is I'm registering the middleware for all of the endpoints that are registered after I'm calling this app.use. So these two endpoints right over here will not have the logging middleware registered. So I go into the browser, and if I go to the base URL, you'll see that the console does not log anything. If I go to /users or /API/users, you'll see that the console doesn't log anything. But if I were to go ahead and make a post request or a get request to this endpoint. So let's make a GET request to /API/users/1. You will see that it now logs in the console the request type or the request method and the URL. Okay, so remember, order matters. And one more thing that I do want to talk about is in the app.use method call, you can also pass in as many middlewares as you want, and they will also be called in sequential order as well. So just one more quick example, I'll pass in another middleware function, and I'll just write a console log, and I'll say finished logging, and I'll call next, and let me refresh, and you should see that it says, so at first it logs the first thing, which comes from the logging middleware, and then once that middleware is done, it calls the next middleware, okay, and then it logs finished logging. And now once we are done with this next middleware, remember we call the next function, and then it'll just go down to the endpoint level. So remember, the request and response handler is also a middleware as well. So it also takes in the next function, and then you can also call next in here as well. But if you don't have any additional middlewares after it, then there's no point to add that argument in the function signature. Okay, so hopefully that makes sense. Okay, so let's go ahead and take what we just learned and put it into work. So what I'll do is, since I have a lot of reusable logic for a lot of my endpoints, so notice how in this app.put endpoint, I have a lot of the same logic right over here that is written in the app.patch method and the app.delete method. Okay, so what I'm going to do is I'm going to take all of this right over here, I'm going to copy it, and I'm going to go ahead and create a function up top over here, and I'll call this handle user by ID, or maybe I should call it resolve user by ID. Okay, because the goal of this logic is to really get that index by the user ID. So maybe I should call this resolve index by user ID. Yeah, let me call it this instead. Okay, so this will be an arrow function. I'm going to paste the logic in here. And remember, because it is a middleware, and a middleware is also a request handler, we have the request, response, and we need the next argument as well. So 3 arguments altogether. And now here's the thing though. What I want to do is I want to use this middleware right before I, let's see, I want to use this middleware right before I call this request handler. Because remember, this middleware that I'm creating right now, the purpose of this is to grab that user index where it is located in the mock users, and we want to be able to have the next middleware that is called use it. But in order for the next middleware to actually be able to use that information, we need to be able to pass it somehow. Now, there's no direct way to passing data from one middleware to the other, but what you can do is you can attach properties to the request object. Since we're using JavaScript, we can dynamically attach properties very easily to the object. So I can reference request, and I'm going to go ahead and reference find user index. So this obviously does not exist on the request object, but I'm just going to assign it to this, just like that. Okay, so now in the next middleware, and all of the succeeding middlewares that are being called, assuming that we don't ever delete find user index from the request object, they will have access to this find user index property, which is going to be a numeric value. So once we are done, we're just going to call next. Okay, and now one more thing that I also did not mention is that next actually does take an argument, but it expects an error object or null. So if you do pass an error object or an error instance, such as like this, like new error, this will actually throw an error at the express level. If you don't pass in anything, then it won't throw any error at all, and it will just assume that everything is successful. Okay, but we are handling errors though with these checks and sending back the correct status based on whatever data that we send to the server. So we should be fine. Okay, and since we're not referencing the request body in this middleware at all, because we actually reference the request body at the final request handler function, we're just going to remove the structure of the request body right there. So let's actually use this for one of our endpoints first, just so you all can see how this works. So what I'll do is I'll use it for my put request to update the user by ID. So we just pretty much take that middleware and we pass it as an argument right before our final request handler, which is this request and response, handler over here. Now, since all the logic that we have inside resolve index by user ID, all this logic that we see over here was moved into that middleware function, so I can just delete all of this. Okay, so I'm going to just remove all of this. I still will need the request body though, so I will remove at least the destructuring of the request params, but I'll leave the destructuring of the request body right over here. And remember, we never modified the request body at all. Now we do need a reference to find user index in this request handler scope, so I will need to destructure that, and I can, now that in the resolve index by user ID middleware function, I got the index and I attached it to the request object. Okay, so at this point, if we hit this part right over here, we can assume that find user index is in fact defined, because if it was not defined, then we actually wouldn't even be in this final middleware at all. Okay, so now I can access find user index from the request object, but now I also need to fix this parsed ID, because that was something from that we had before, but we no longer have that. But that's fine, because I can still reference mock users, use find user index to reference the exact element at the position in the mock user array, and then just simply reference .id like this. Okay, let's go ahead and just test this out before we modify the other endpoints and see how this works. All right, so back into our Thunder client, let's make a put request. So put, and then localhost slash API slash users. So I guess we'll update user with ID 3, which will be Adam. So let's send the request body. So let's do username. Let's change this to Jackie. So if I click send, everything works fine. If I were to get that user again, the username was updated, and since we didn't provide a display name, that was pretty much just overridden. Okay, so that is working just fine. So let's just update the other endpoints as well. But before, let's just recap of what's going on. So whenever I make a put request to /API/users, and then the route parameter we provide, which was number 3, it's going to go ahead and first call the first middleware. Well, first it will call all of its global middlewares if there are any that are registered before that route. In our case, we only have express.json, which we need to parse that JSON into an actual JSON object. So that is invoked first, obviously. Then we don't have any other global middlewares invoked. So we invoke the resolve index by user ID middleware, and then it will go through this logic. Basically the same thing that we've been doing already, just moved into a separate function. The only difference is that we attach this find user index property, or we add this property to the request object and assign it a value, which is the index of where the user is in the mock users array. And then we call next. So once next is called, it will now call this final request handler, which is also middleware. And then from here, we just simply update the mock users, or update the user in the mock user array. And then we return a status code of 200. That's it. Let's go ahead and update our patch request. Let me just copy this middleware function name, pass that in there. Same thing, just remove that params destructure. I don't need all of this anymore. And then let's see, let's destructure find user index. And I think that's it for patch. Let's just test that out, make sure that patch works. So I'm going to go ahead and update user number 3. So since we restarted the server, the username should be back to Adam, and so the display name be there as well. I'll just update the username using the patch request. There we go. And if I click send, you can see the username was updated. Okay, so the patch request is working good. And of course, if I were to provide an invalid value, the middleware will pick that up for us. You can see it says bad request invalid ID. And that is handled right over, let's see. Should be handled somewhere over here. Oh, you know what? We haven't done it for the get request yet. We'll do that later. Okay, but at least let me do this. If I make a put request to this, you can see that this part gets handled by the middleware for the put request, and same thing for the patch request as well. We get a bad request. If I were to pass in a valid numeric ID, but there's no user with that ID, then it'll just give us a 404, and that is all being handled by the middleware that we just created. Okay, cool. Let's go ahead and do the same thing for delete. So let's pass in resolve index by user ID. Let me remove all of this stuff right over here. Yep. And for this part, we just need to grab the find index user, just like that. So that way we know where to splice, or I'm sorry, it's find user index. Okay. Now let's go ahead and try to delete a user. So I'll delete user with ID 3. If I try to get that user, it's not there anymore. Okay, see how user of ID 3 is not here anymore. Okay, let's just go ahead and fix up the last one, which is the get request. So let's see. We need to... So the way that we are actually returning the user in the get request is done differently, because we're using the find method and not find index to actually get the user object itself, and we're just returning that as a response. But what I could do is I could still use the same middleware, resolve index by user ID, and I can grab the find user index value from the request object, and then I could just use that to reference the mock users array to return the correct user. So let's just do that, just so that everything is consistent with each other. So let me remove all of this, and I'll go ahead and destructure find user index. And I'll just do this const find user. It's always good to just double check just to make sure, even though we know that find user index does 100% resolve to a user in that array, but it's always good to check just to be safe. So mock users, find user index. And if there's no user, we'll just return the 404, and if there is, we'll just return find user. Okay, so we're still utilizing our middleware for all of our endpoints that we're using the user ID to search or perform operations on. So now if I try to get the user by ID, it says mock users. Oh, let me fix that. I think it's mock. I misspelled that. It's case sensitive. Let's try again. Okay, there we go. So that is pretty much it with middleware. I know it's a lot, but middleware is very powerful, and understanding how it works is very worth it when you're using Express.js, because everything in Express.js that you're going to be using has to do with middleware in some way, shape, or form. So it's good to learn how middleware works, learn the ins and outs of it, and understand how you can use it to your advantage. Okay, so hopefully all of this made sense. All right, everyone, in this part of the tutorial, I'm going to teach you all how to use Express Validator to validate incoming data for our Express API. The reason why this is important is because sometimes the data that you expect is not the data that you receive. Let's say you want to create a user and save it to a database. So you obviously need a post request to a user's endpoint to create that user. So that post request will expect a request body, and we want to make sure that the username is not over 32 characters of length. Now we are expecting that, but that doesn't mean that the client will send a username that matches our constraints. So you want to make sure that you check to see if the username is 32 characters or less. Now, some of you might be wondering, well, if I'm validating on the client side, let's say if I have a React or Angular project and that project has a form, and when I click on the form button, it will send a post request to my server. Well, if I'm validating that form before I click that button, before I submit that API request, why do I still need to validate on the server side? The reason why is because the API, your Express application, does not know where that data is coming from. You can literally go into the web app, open up the network tab, and inspect where that post request is being sent to, which endpoint it's being sent to. Take that URL and throw it in something like Postman or even the Thunder client that we've been using to make API calls, and send whatever you want and bypass the client-side validation. So you don't know where the data is coming from. So you always need to make sure you are validating it on the server side. In my opinion, I think the server-side validation is the most important, more important than the client side, because the server side is where you're actually going to process that data, save it to a database, submit it to another external API, or do whatever you want with it. Okay, so you must always validate on the server side no matter what. So let's go ahead and install Express Validator. So I'm going to type npm I express-validator, just like this. And then I'll run my Express server. Let's go into our code, and we're going to go ahead and import a function from the Express Validator package, just like this. Whoops. So import and then a pair of curly braces. So I'll import the query function, and this is used for validating query parameters. Okay, so there are a bunch of different middleware functions that you can import from Express Validator. And in case if I didn't mention earlier, yes, these functions that you are importing, you are using them as middleware. So what that means is that we're going to be calling them by passing it as an argument to our request methods, such as app.get, for example. And then we want to make sure we're calling them right before our final request handler, which is also a middleware as well. In case if you didn't see the middleware section of this tutorial, definitely check that part out, either in the previous video if you're watching just this Express Validation tutorial, or if you're watching the entire thing, just go a few minutes back to where we talked about middleware. Okay, but what I want to do is I want to pass this query function call as if it was a middleware. So we're going to pass as an argument right before I pass this request handler function. So it's pretty easy. We're just going to go ahead and call query and then comma. So we now have 3 arguments for this app.get endpoint right over here. And now what I want to do is I want to specify the query parameter that I want to validate. So I'll just do a simple one. We'll do filter. Okay. And when you call these functions, okay, in this case, we're calling query, it creates a validation chain. So basically, it just basically means that when you call this function, it returns an instance of validation chain. And from here on, you have access to a bunch of methods that you can use to determine what you want to validate. So if you want to validate that filter is a string, you can call this isString method, and this returns an instance of validation chain. So you can call literally the same method as many times as you want. Obviously, you don't want to do that. But the whole point is that you can use this validation chain to perform more validations in order, or it doesn't really matter in this point. But the point is that you can use this validation chain to keep on calling more methods to validate on that single filter field. So let's say you want to validate that filter is a string, and then you also want to make sure, let's see, that it is not empty. Okay, so this will ensure that it is a string and it is also not empty. Now I will mention that with query parameters in Express.js, they are always parsed as strings. So even if you pass in a numeric value in the address bar, as the query parameter for our filter, or really any query parameter, it's going to be parsed as a string, and you'll see in just a second. So what I'll do right now is this. So I'll make a request. So let me go into my Thunder client right over here, and let's make a GET request to the user's endpoint. And for now, we're not going to pass in the query parameter for filter. I'll click send. And you'll see right over here that nothing happens, although we are expecting an error to occur. Why is that the case? Well, here's the thing. These functions don't actually throw an error. They don't reject the request. You actually have to handle that yourself. So how do we handle that? Well, remember, middlewares are called in sequential order. So this query function that I'm calling, this is going to be the first middleware that we're calling, and then it's going to call the next middleware. So it will call this request handler, which remember it is also a middleware as well. So inside our request handler, in the function body, we need to take care of the error handling part, because the query function won't throw any errors for you. It will validate the fields, but it just won't throw any errors. So you as a developer needs to handle that yourself. So just very quickly, I want to console log this request object because I want to show you what happens underneath the hood. I know some of you might not be concerned about it, but I want you to also get full context with what is going on instead of just telling you to call all these functions. So what I'll do is I'll make a GET request to this endpoint, and I'm logging that request object, but I want to show you that you can see right over here in the request object, we have this new property that is attached to that request object, and Express Validator attached that themselves, okay? And it's attached when we call this query function middleware, and then now we can actually see that it's right over here, okay? And I'll go even further. Let me just copy this part over here and access that direct field and show you even further what that looks like. So you can see we have this context array, or this array of context, and it's an object, and it has a bunch of metadata about the validation. You can see we have fields, locations, errors, okay, a bunch of different stuff. Obviously, you don't have to worry about this, but underneath the hood, what happens is when we call this query middleware function, it's going to go ahead and validate the field for you, and then it will attach the data to this request object. Okay, and from here, what you want to do is you want to call this validation result function. So let me import that from Express Validator. So validation result, that's a function, and you want to call that function, and let's assign the return value to a variable called result. So we're going to call this validation result function, and we want to pass in the request object, okay, just like that. And what this will do is it'll grab that field and it will extract pretty much the validation errors, and you can handle that yourself. So instead of having to manually do that yourself, you can use this validation result to do it for you. That's why they provide this function. So let's go ahead and send a request again, and now you can see that when I log that result object, I now have everything in a proper format. You can see that we have this errors property, which is an array of errors, and you can see that we have two errors. One, we have an invalid value, which I guess makes sense because we are trying to validate if it is a string. And then we're also trying to validate if it is not empty. So we have two different things we're trying to validate. So we have two errors total. So invalid value and an invalid value as well. But if I go ahead and pass in that filter query parameter, and then let's just give it a random value. Let's just do Anson. And now you can see that that errors array is no longer populated with errors because we don't have any errors anymore, because we just pass in that filter value right over here. Of course, if I don't pass in a value, we still will get an error. It says invalid value because we have this not empty call right over here. And you can also take a look at the documentation or in your VS Code. If you just use the dot operator after this not empty call, you can look at all the other methods that you can use to validate your fields. So let's do a validation on the length of the value for filter. So let's use isLength, and then this will take in options. So let's do min character length. We will go ahead and do 3 characters, and then for max we'll do 10 characters. So now I'm going to go back to my code or my vendor client. So if I pass in, let's just leave it empty like this. Let's see, we should get 2 errors, okay? If I remove the entire query parameter, we should get 3, because now we're calling 3 functions. We're chaining 3 functions. Let's go ahead and pass in the filter, and let's do an. So an. If I click send, you'll see that we get this error. And now if you actually look at these errors, you're probably starting to feel confused on what is what, you know? So we can actually use this method after we call isLength, called with_message. You can actually pass in a custom error message, and you can see over here it says it sets the error message for the previous validator. So this with_message call is going to the message itself that you pass in here will relate for this validator. Okay, so we'll do must be at least 3 to 10 characters, and let's add a custom with_message call for not empty. So must not be empty. Okay, let's try it out. So if I click send and look at the console, you can see now we have that custom error message. Okay, hopefully that makes sense. And if I leave this empty, you can see that we have both of our errors must not be empty and must be at least 3 to 10 characters. So that is good. Okay, so now if I were to pass in just, let's say 5 characters now, we shouldn't get that error anymore, and we don't. But if I exceed 10 characters, it now gives me this error, must be at least 3 to 10 characters. So hopefully this makes sense. So this is how you can validate query parameters. Now let me go ahead and show you how we can validate request bodies, because that's also very important as well. So similar to query parameter, we have this query function for query parameters, but we also have a function to validate request bodies, and that is the body function. And you import that from Express Validator just like this. And it is used the same exact way. So if you understand how to validate the query parameter, you then can validate very easily the request body. So here's what we'll do. We'll go down to our post request for the API/users endpoint, and right before our final request handler, we'll go ahead and call the body function and pass that as an argument into app.post. So it's going to go ahead and call this body middleware function first, and then perform the validation, and then it's going to go ahead and call that next middleware, that final request handler function right over here. And then similar to what we did with the query parameter, in that request handler function, we want to actually use that validation result function to see if there were any errors at all. Okay, so here's what we'll do. So now we'll go ahead and specify what field that we want to validate on the request body. So for the request body, I want to validate the username. And then I also want to verify that it is not empty by calling the not empty function. And I'll use with_message username cannot be empty. And then I want to make sure that the max is, let's do 32 characters. So isLength. We'll do a min of 5 characters and max of 32. And then with_message username must be at least 5 characters with a max of 32 characters. And then let's see. Oh, let's also make sure it's a string. username must be a string. All right, and let's go ahead and try to make a request, a post request to this endpoint. Whoops. Let me see. Oh, let me go ahead and do this. Before we do the post request, I forgot that we need to go ahead and call that validation result function. So let's do that. Validation result. Okay. So const result equals validation result. And then let's console log result and see what happens. So I'll send this request. Oh, whoops. I'm sorry. I was supposed to pass in request, not result for the validation result. Sorry about that. Okay, there we go. That works. Okay, so let's see what the problem is. Okay, so now we can see that username cannot be empty. Username must be at least 5 characters with a max of 32 characters. So we do have our errors, so that's good. Okay, now here's the thing though. I want to validate not just one field, but I want to validate multiple fields as well. I don't want to just validate the username field. Okay, so what we can do is we can actually pass an array of body function calls. So instead of having to pass it in like this, and then pass in another middleware function. Let's say if I wanted to just very quickly validate display name and do not empty like this. Okay. Let me make a request. And you can see now, let me zoom out a little bit. You can see now I have 4 errors all like this. Instead of just passing it individually, like different arguments, we can actually just pass it as an array like this. So we pass in one array, and then it'll call all of these. Not that it will matter all that much, because in the end, it will still validate everything for you. So let's go back to Thunder Client, and we'll send some requests now with some valid data. So let's go to localhost port 2000/API/users, username, Anson, display name, Anson the dev. And if I look at my console, you can see that we have no errors. The moment that I omit any one of these values, I'm going to get an error in that errors array right over there. So if I omit username, you can see that, yep, we get the errors for username. Okay, that's good. So let's go ahead and customize our logic now, because we obviously don't want to do anything at all when there are errors. In our case, we don't. So we want to make sure that we can actually check to see if there are errors or not on this result object. And to do that, there's actually this isEmpty function, and this returns true or false, and it returns true if there are no errors, and if there are errors, it will return false. So what I can do is I can use an if statement, and I'll just do if there are no errors. So if result is not empty, then I'm going to go ahead and return response. I'm going to set the status to 400, the status code to 400, and I want to send back the errors. So I'll just send an object, an object with the errors property. And to actually get the errors, you can reference result, and then you can just call this array method, and this will just give you all the validation errors as an array, as it says right over here. It gets the validation errors as an array. You can map it if you want to alter what is sent back based on that errors array. You can do that if you want. Let's go ahead and try this out. Okay, so let's omit the display name, and you can see now I get that 400 status code, which means bad request. And that's typical whenever you send an invalid payload. So in this case, we're sending a payload with no display name. And you can see I get the error, invalid value, path, display name, location, body. Now, of course, ideally, you would want to clean this up because you want to have something that is more understanding to the client so that they understand it very easily. But I'll let you all take care of that. And if I omit the username, you can see now all of the errors Let me zoom out a little bit. Whoops. You can see now all of the errors appear right over here. Okay, so hopefully that makes sense. So we're not quite done yet because we still need to actually save the valid data to our quote-unquote database, or our array in this case, of users. Right now we're still using this body object that comes from the request object, and this data can be either valid or invalid, we don't know. Okay, but since we are using Express Validator, we want to make sure that we are using the validated data. Of course, there are different ways that you can handle this. Since at this point we are throwing an error or returning a status code of 400, we can safely assume that the data is valid by just referencing body dot and then whatever field name we want. But instead, what we can do is we can actually use this function called matched data. So let me import that up there. So matched data is imported from Express Validator. And then I'm going to go back down here. And what I can do is I can simply just call, let's do this, const data equals matched data. Okay, and just pass in the request object like this. And then what this will do is it'll grab you all of that data that has been validated. So I'll console log this so you all can see. So let's get the username and let's pass in a display name. So now I can see that I have username and display name right over here. Okay, and this object that is being logged is the matched data return value, which is pretty much the validated data. So I would recommend you to use this data object instead of the request body. So let's just fix that real quick. So let's remove these two lines. And then let's see, we're going to replace this reference of body with data. And I think that's all we need to do. All right, and that is pretty much it. That is how you can validate request bodies for your post requests. And you can do the same thing for put request, for patch request, and really any request method that takes a request body. And since you know how to validate request bodies and also validate query parameters, you should now know how to validate other things too, such as headers, cookies, route parameters. It's all the same thing. Now, very quickly, I wanted to show you all how you can use a schema in Express Validator to make your code look a lot more cleaner, because right now, if I look at this part right over here, I have a bunch of validation going on, and this is just for only 2 fields. And you can imagine if you have a lot of different fields that is being sent to the server, this can start to look more and more cluttered. So we can use a schema to make things look a lot more cleaner. And a schema really just is an object that has all of your validators defined. So instead of having to have all of this being chained after calling each function, all you do is you use this check schema function and you pass in the schema, which is just an object. And then what that function will do is it'll create a list of validation chains. So that way it can just save you a couple lines of code and make it look a lot more readable. So what I'll do is I'll create a new folder called utils, and I'll create a new folder inside this folder, or not inside. I'll create not a folder. I'll create a new file called validation schemas, because I want to keep everything separate. And then what I'll do is I'll create a variable called create user validation schema. I always like to be verbose with my variable names, but it's up to you. And then now what I want to do is I want to define the field that I want to validate. So in this case, I want to validate the username field. So I'm going to use that as a field inside this object, create user validation schema. And then for username, this will be an object. And inside this object is where you will specify what you want to validate. So if I wanted to validate the length, so what you would do is you would just take the name of this method. It's gonna be the same exact thing. So whatever the name of the method is, is going to be the name of the field that you're going to configure inside this object. So for example, isLength, I'm going to go ahead and type isLength just like this. And so this is going to be an object. And you want to pass in these options. So options, and then it's going to be the same exact thing. You can pass in min and max for options. So min of 5, so this will be a minimum of 5 characters, max of 32 characters. So this is how you can validate the username and its length. Let's do the same thing for the not empty validator. So again, you take the same method name, not empty. You can even just copy and paste it. Whoops, not there, right over here. Now, since not empty does not have any options, we can just set this to true. But of course, if we did provide options, we could just map this to an object and do the same thing like this, options, like that. Same thing for the isString validator. We don't have any options configured for that. So I can just take the same exact method name and then set its value to true. However, if you did have an error message, like a custom error message like we have over here, we can also specify that as well. So for isLength, inside the isLength object right over here, I can go ahead and specify this error message field like this. And I'll just go ahead and copy this whole string and paste this right over here like that. Now, since not empty does have a custom error message, instead of setting this true, what I'll do is I will provide an object like this, error message, and then that. Okay? And then what we'll also do, same thing for isString. Let's copy that and do this. And of course, since you have this object over here, it pretty much implies that you are going to obviously check for these two validators, so you don't need to worry about the Boolean value anymore. And let's see what else. Okay, yeah, that's pretty much all we need for this. So now to actually use the schema, what we'll do is let's remove all of this. Let me just make sure we have everything. Username. Oh, whoops. That was only for username. Let's do display name. I forgot about that. Display name. And I think the only validation we had was not empty. So let's do not empty. And then we'll just do true for now. Okay. Let me go ahead and remove this whole array. And then now we're just going to call this check schema function. So let me go up top over here and import check schema just like this. And let me go back to the post request. So right over here, we're going to go ahead and call check schema. And then now you're going to pass in that schema definition, which is just this object that we created. So let's import that. So up top over here, we'll import from utils validation schemas, create user validation schema, just like that. And I'll pass that object in here. And let's actually see what happens. So if I go into Thunder Client, let's make a new request to localhost port 3000. Okay, so I am getting an error in the console, and I think it's complaining about the import. I think it's because I'm missing the extension at the end, the .js, but I realized that I am supposed to use .mjs, so let me just quickly fix this and add that .mjs extension at the end, because if I don't have that extension, it's going to throw this error, but if I add that extension at the end, the error will be fixed. Okay, so I just wanted to mention that very quickly. But now, if I were to go back into the Thunder client, and let's try to make a post request now, you can see that now I get the errors right over here. It's complaining about the display name, the username, and all of the different errors that's going on with it. If I pass in, let's say, username, and let's do it. Let's say if I pass in just 2 characters for the username. You can see that it's going to complain about username must be at least 5 characters with a max of 32 characters. And the other 2 validator errors are not there because we actually provided a value and it is not undefined. So yeah, it's a string and it's not empty. Okay, and then you can see that since we don't have display name, that is not, since we didn't provide that in the request body, the error appears right over here. Okay, so hopefully that makes sense, and hopefully you can start to understand how using schemas to validate your request bodies is a lot more easier than just having all of your validators in the same file and just chaining them after each call. Okay, so I would encourage you to do the same thing for this query validation that we did earlier for this GET request. I'll let you all take care of that yourself just for extra practice. So hopefully this all made sense. So now what I want to do is I want to show you all how we can organize all of our requests using an express router. The problem right now is even though we only have a few routes defined, as our application grows, we could have 50 routes, 100 routes, a whole bunch. And you obviously don't want all of it to be in one single file. You want to group together your API endpoints based on what is known as a domain. So what I mean by that is, for example, we have a bunch of user endpoints, and all of this handles different operations. So that is known as the user domain. The user domain is everything related to the user itself. So when you create a user, when you grab all the users from the database, when you update a user, that is all part of the user domain. If you see right over here, I have another products endpoint that doesn't really have any other endpoints to do much with, such as creating a product. And this would be the products domain. So anything related to operating with the product domain would be things such as creating a new product, updating a product, deleting a product, things like that. Okay, that's what I mean by domain. And what I want to do is I want to be able to group together all of my users' endpoints separate from the products endpoint, because it doesn't make sense to keep everything all together. Okay, the products endpoint should be grouped with everything related to products. Users endpoint should be grouped together with everything related to users. If you have endpoints that handle payment processing, maybe you're talking to, let's say, the Stripe API or some other payment processing API, then you would have a payments domain and you want to group all of your payments endpoints together. So we can use an express router to do this. And what I'll do is I'll create a new folder inside the source folder, and I'll call this routes. And then I'm going to go ahead and create a new file and call it users.mjs. And then inside users.mjs, we're going to import the router from Express. Okay, and this is a function that we can call to create an instance of an Express router. It's the same way of how we imported Express like this, and then we called the Express function. The router import is also a function. So I'm going to declare a variable, and we'll assign the return value of the router function call to this router variable, which has a lowercase r. Okay, so these two are different, obviously. So now we have our router, and the nice thing about this router is it has pretty much almost all the same exact methods and properties that the Express app instance has. So you can see that I can reference the get method, the post method, delete, all that kind of stuff. Okay, the router itself is pretty much like a mini application in your entire Express app that can group together all of your requests. So you can register requests on the router, but then you also need to register that router to Express. Okay, so hopefully that makes sense. So the same way that I am registering, let's say, this GET request right over here for /API/users, I can do it on the router. So let me go ahead and copy, let's say, this right over here. It takes the same exact method arguments. You can see it takes a path. So let me paste the path right over there. So /API/users, and then it takes as many handlers as you want to pass or middleware functions. So we can literally pass these exact same arguments right over here like this. Okay, let's just import that query function from Express Validator. And this is something that we did in the previous section where we talked about validation in Express. Okay, so next thing we need to do is export this router, and then we need to import it into our main index.mjs file where we have the Express app instance, because we need to register our router with the main Express app in order for the main Express app to actually have these routes mapped out so users can actually visit it, or clients can actually visit it. So I'll actually export this as a default. So export default router, just like that. And then the next thing that we'll do is we'll go into our index.mjs file, and we want to import that router, that user router. So import users router from, and then the folder is routes, and then users.mjs. Let's make sure we don't have any errors in the console. Okay, everything's good with the import. So we can register this router now, so that way we can actually access the endpoint defined at the router level over here by simply just using app.use, just like this. And then you pass the user router like that. And since we have the same endpoint defined at the router level, we want to make sure we remove this endpoint definition over here. So let's just remove that. Okay, so now let's go ahead and try to access that endpoint using the Thunder client. So we're going to try and make a GET request to /API/users. So let's do that. And it says validation result is not defined. Oh, whoops. I need to also import validation result as well. And let's try to make a request. Mock users is not defined. Oh, that's right. Because, yeah, we were using mock users. Okay, let me quickly do this. I need to move this mock users array into a separate file so I can export it from that file and import it everywhere else that I need it. So I'll just create a new file. I'll call this constants. Whoops, .mjs. And I'll export this mock users constant. And I'm going to remove this right over here. And let me just quickly do this. Let me import it inside the index.mjs file because we are using it here. So up top, I'll import, and this is a named export. So mock users from utils constants.mjs. And we'll do the same thing inside the users.mjs file. So import mock users from, and then the path right over here. Okay, so no more errors, so that's good. Let's just try to call this endpoint. Okay, so you can see that it works, and that's good. So we know that it is working. And if I were to remove this app.use call and passing in the user's router and save, now if I try to make a GET request, it's going to say 4 not found because we did not register that router. So hopefully this makes sense. So now what I can do is I can take all of my endpoints that are relevant to users and place it inside this users.mjs file and then register those endpoints at the router level. So let's do that. So let's go ahead and do the same thing for app.post/API/users. So I'm going to go down here and I'm going to reference router.post, and I'm going to pass in those same exact arguments that I had passed in to app.post. So you can see right over here, we pass in for the first argument the path, and then all of our middleware functions. Let's just make sure we have all of our imports. So we need to import check schema from Express Validator. We need to import the create user validation schema as well. So let me import that, create user validation schema. Okay, and then let's also, we already have validation result imported. We are using the matched data function that comes from Express Validator. So let's import that, and this should work. So now let me just go back to the index.mjs file, remove this app.post because it's redundant. And let's go ahead and try to make a post request. And you can see that it's working just fine. Let me pass in a request body. And then let's see the result. And you can see that we get a response back. And of course, if I were to just remove this, it would say 4 not found. Okay. And like I said, you could do the same thing for all of our endpoints for the user's domain. So what I'll do is I'll move the get user by ID in there. So let me just copy all of this and let me just delete this. So let's go up here. I'll put this right underneath here. Okay, and then we do need the resolve index by user ID middleware function. And since that is defined inside the index.mjs file, we need to, of course, export it. Oh, whoops, not this one. This one right over here. Let me do this. Let me create a new file inside utils. I'll call this middlewares.mjs. And let me export this. And let me make sure I am importing mock users from constants.mjs. Okay, this is good. So now we can import. Well, first let me remove this. And I'll import that middleware first from utils middlewares. Resolve index user by ID, because this index file is still using it. And then what I'll do is I'm going to go ahead and import this inside the users.mjs file. So that gets imported right up top over here. As you can see, resolve index by user ID for this middleware. And I think we are good for this endpoint right over here. And I did remove it, so that's good. So now let me go ahead and just make sure my other endpoints work. Okay, let's do 3. Okay, so our endpoints are working, so that's good. What else? Let's go ahead and move these 3 endpoints into users.mjs as well. So I'm just going to paste them all over here and just change app to router. Just like that. And we're using the same resolve index by user ID, which, like I said, we imported up top over here from that new middlewares.mjs file that I just created. Okay. And there's nothing else that we need to import because it's using mock users, which we already imported already. And the request and response object comes from this callback function. So we're good to go with the rest of our endpoints. So look at our main file now. Look at all this. Now we have cleaned up our index.mjs file. And anything relevant to users, I can just go into the routes users.mjs file and look for the corresponding endpoint that I need to look for. Okay, let's just make sure our other endpoints work. Okay, that's good. Okay, and if I take a look at this, I have successfully updated the data, and patch should work just fine as well. Okay, patch is working just fine. I was able to update my data using put and patch, and let's try delete. So I just deleted the user of ID 3. So if I try to get that user, it's going to say 4 not found. And if I call users, it's not going to show that user in the array. Okay, so that's good. So hopefully this all makes sense. So now I can easily just clean up my index.mjs code. So let me remove all of the imports that we're not using anymore. So all of this stuff we're not using anymore. All of this stuff over here. I'm going to delete logging middleware because we're not using that anymore. Let me remove these comments down here. Okay, let's go ahead and create another router for products. So I'm going to create a new file and I'll call this products.mjs. And it's going to follow the same structure that we did for our users router. We're going to import the router from Express. We're going to go ahead and create the router instance by calling the router function and assigning that return value to the router variable. And then we want to also make sure we export the router as a default export. And since products we only had one endpoint for products, I'm just going to go ahead and copy all of this. Let me remove that. And we'll call router.get, paste this there. And since we're not using any other imports, or we're not referencing anything else aside from just this response argument in the function, we don't need to worry about importing anything. Okay, and the last thing that we need to do is import the products router like this. So import products router from, and then the path to that products.mjs file. And then we need to call app.use and pass in products router like this. So now if I try to make a request to products, I can get the list of products. And of course, if I were to remove this app.use with the products router being passed as an argument, we're not registering that products endpoint or that products router, so we can't access that products endpoint. So hopefully this makes sense. Now, one more thing that I will do, and I'm only going to do this because I want to structure this entire project in a way for future videos, for future tutorial videos. What I'm going to do is I'm going to actually create a new file called index.mjs. And what I'm going to do is I'm going to import the router as well. And I'm going to create an instance of this. And you don't have to do this if you don't want to. But personally for me, I prefer organizing everything like this because it makes it so much easier. I'm going to also export this router as a default export. And what I'll do is instead of having all of my routers being imported in the index.mjs file, because you might have a lot, what I'll do is inside this index.mjs file in the routes folder, I will import all of my routers in here. So you can kind of think of this like a barrel file, if you've ever heard of that before. So let me import users router from users.mjs, and then we'll do the same thing for products router. Import that from products.mjs. And then what you can do here is you can use router and then call .use. And in case if I didn't mention it earlier, you can also register middlewares the same way that you would register middlewares on the Express app on the router itself. And that would, of course, register middleware at the router layer. So not for all of your routes, but for all of the routes for your router specifically. Okay, so you can register middleware only for your users' routes, and it won't have anything to do with the products route at all. Okay, but I'm going to go ahead and pass in the users router like this, and I'll do the same thing, but for products router like that. And then I export the router as a default export from this index.mjs file. And then I can now go into my index.mjs file in the root source folder right over here, remove these two imports, import, let's do this, import routes from, and we're going to import this from index.mjs. So we're importing this root router that we're using to register all the other routers. Okay, and then I can go ahead and pass routes into app.use. So I only need to do this one time because I already have all of my routers registered with this root router right over here, and I'm registering that root router with the main Express app. So it's still going to work the same exact way. It doesn't matter whichever one you prefer to do, but I just prefer doing it this way because I think it makes it a lot more cleaner for the index file itself. Okay? And one more thing that I will do though is you can also set a prefix for all of your routes, because notice how right now I need to prefix everything with /API. Okay? /API/products, /API/users, etc. So hopefully all of this makes sense, and you can now see how much more organized your entire application looks. So you can go ahead and add more endpoints for products. You can add more endpoints for users, and you will know where every single thing is without having to scroll through one file trying to look for it. All right, everyone. So the next topic that we're going to talk about are HTTP cookies. So cookies are pretty much a simple concept, but a lot of people tend to get confused about it. They get confused on what it is, how to use it, how it's used in real applications. But most importantly, they kind of don't quite understand what's the purpose of it. So I'll do my best to explain it to you all in a simple way. So cookies, or HTTP cookies, they're literally just small pieces of data that your web server sends to the browser. In our case, since we're using Thunder Client, you can pretend that this is our web browser. So whenever I make a request to this URL, it will send me back a cookie. But currently, our server is not sending any cookies. But you can see over here, whenever I make a request, I can go ahead and click on this response section over here and then select cookies and see if there were any cookies sent back from the server. So the server sends a cookie to the user's web browser or the client or whatever. And then the web browser, or in this case, our Thunder client, can store the cookie. If you actually go into your browser right now, and if you were to open up the dev tools, so let me actually do this. Let me go to localhost port 3000, and let me zoom in a little bit. And let me open up my dev tools. So right over here. And if you actually were to go to this chevron, this double chevron arrow, and click on application, you can see this section where it says cookies. Now, currently, I don't have any cookies stored on this domain, but we can change that. We can make our web server send the cookie back to the web browser. The web browser can store that cookie. And then what happens next is the web browser can actually send that cookie back to the server on any request you need to make. Now, you're probably wondering, well, why is this important? Well, it's important because by default, HTTP is stateless. And what that means is that whenever you make a request, the server doesn't know who that request is coming from. It doesn't know who the user is. It knows nothing. So if you wanted to build, let's say, an e-commerce website, and you wanted to implement some kind of cart system where you can add items to a cart and delete them from a cart, and you wanted to make it functional where when the user adds items to the cart and they close the website and go back on the website, that those items are still in the cart after they leave and come back, you need to use something like cookies. Because the server doesn't know who the user is, it doesn't know what items they added, but when you use cookies, you can send the cookie back to the server, and the server will then know who that user is. And so the next time the user comes back, the user can have all of their items on the cart displayed so they don't have to re-add everything all over again. Now, most of the time in realistic large applications where you have authentication, you use cookies alongside with sessions, but we're not going to get into sessions just yet. We're primarily only going to focus on cookies right now. Okay, but hopefully that explanation makes sense. Just remember that HTTP is stateless, and using cookies enables the server to send a cookie to the web browser, and that cookie typically is going to be some unique value. So that way the server, when they receive it, they can distinguish whose cookie this belongs to, and then they can send dynamic data based on the cookie's value. So I'll show you an example. So let's go into our code, and what I'll do is inside the base URL, I'm going to go ahead and set the cookie whenever the user visits this endpoint. To do that, we have to modify the response object by calling this cookie method on the response object. And this takes in a total of 3 arguments. Options is optional, but you can pass in a name for the cookie. So I'm going to call this hello, and then I'm going to set the value of this cookie to be world. And then you can pass in options. So let's say if you want to have the cookie expire after a minute, then you have to specify that in milliseconds. So 60,000 milliseconds is 1 minute. And let's go ahead and test this out. So I'm going to go into the browser, and if I refresh, you can see that I now have this cookie, and I can see that every time I refresh, you can see the number just jumps up to 49, 50, well now 51, 53, 54. So it's going to expire after 1 minute. Okay, I can have it expire after an hour. So let's do 1 minute times 60. So that's 1 hour right there. So notice if I refresh, you're going to see that, let me kind of zoom in a little bit right over here. So you'll notice if I refresh, it goes from a I guess the 14th hour to the 15th hour. This is in 24-hour time clock. And I think it's in UTC time. Currently it's 7:24. So I think plus 7 hours gets you, I think 15 is what? 3 o'clock, I think. So plus 7 hours. Yeah, yep, that's right. Plus 7 hours. Yep. Okay, and if I were to multiply this by 2, so it expires in 2 hours, if I refresh, you'll see now it expires at the 16th hour, which is 4 o'clock p.m., 4 p.m. So hopefully this makes sense. Okay, and let me just also go into my Thunder client, and if I click send, let's see. I'm visiting the wrong endpoint. Let me visit the / endpoint and see how now I can see that I have a cookie right over here. And you can see that it shows you the domain, the cookie name, the value, all the stuff. Okay? So hopefully this shows you how the browser and how your clients can store cookies. But now let's actually see how it's being used. Like, how do we actually make sure that we are sending the cookie back to the server? Because right now we're only receiving the cookie that is stored in the browser, but we're not really doing anything to actually reuse that cookie. So the next thing that we're going to do is this. What I'm going to do is I will go into any endpoint. So let's just use the products endpoint because we haven't really done much with this. And what I'll do is I want to go ahead and grab the cookie from the request object. Okay, so I'll console log this right now, and I'm going to visit /API/products. So let's go to the browser. And since our cookie expires in 2 hours, we're going to be fine. So we'll still have the cookie. If it expires, though, and your browser doesn't have the cookie, then, of course, that cookie is not going to be sent. But let me go ahead and close this. And let's go to... Whoops, didn't mean to open that. Let's go to /API/products. And let's look at the console. And you can see right now, whenever I visit that endpoint, it says undefined. Now you're probably wondering, well, why is that the case? Are there really no cookies? Well, let me show you this. Okay. If I were to log it from the headers, and if I refresh that page, you can see now we actually have the cookies, and this is accessed through the headers, but the problem here is that it's not parsed. Okay, we have it in this string format, so we have two options. We would have to parse it ourselves manually, or we can actually use a third-party package called Cookie Parser to parse the cookies for us. So just to confirm with you all, the cookies are in fact being sent to the server. It's just that they are not being parsed the way that we expected it to. So let's go into, let's see, our terminal. We're going to install Cookie Parser. So cookie-parser. And you can see that it has literally like almost 3 million downloads. So it is a very popular package in the Node.js ecosystem. And let's install cookie-parser. And then what we'll do is we'll run our server again. And now we need to actually enable Cookie Parser. Remember that a lot of things that you're going to be installing as third-party packages in Express is going to be middleware. Okay, so in this case, Cookie Parser is also a middleware as well. So we'll import that middleware. So import Cookie Parser from Cookie Parser. And then this is a default export. So what we'll do next is we'll simply just enable it, but we want to make sure we enable it before all of our routes are being registered. So you see how over here where I have app.use, and then I pass in that router from this file over here, and this is what registers all of our routes. We want to make sure that we register it before, otherwise it won't parse the cookies for those routes, and then we won't be able to use it. So right before, we'll do app.use and then cookie parser. It's a function. And you can also pass in additional arguments into the cookie parser function call if you need them. So for example, let's say if you needed to parse a signed cookie, which is really just a cookie that has a signature. Then you can pass in a secret, and this secret is used to actually parse the signed cookie. So that would just be like a regular string like this, or whatever the secret is. But we'll leave it alone for now because we don't have any signed cookies. Okay, so now that we've enabled the middleware, let's go back to products.mjs inside our routes folder. And I'll go ahead and console log both request.headers.cookies and request.cookies like this. And you can see there's also a signed cookies property as well for signed cookies. So let's go into Postman, or not Postman, what I'm talking about, Thunder Client, and let's go to API/products. So we still have that cookie because it has not expired. I wonder if there's a way to actually see the expiration date of these cookies on the Thunder Client. Perhaps not, I don't know. But it's okay. We know that it is not expired though. So I'm going to go ahead and do this. I'm going to send the request. Okay. And let's look at the server or let's look at the console. And you can see that we log both the header cookies and the parsed cookies right over here. And you can see that it was correctly parsed. Hello is the field name, and then world is the value. So that is how we can use cookie parser to parse the cookie. Let's say, for example, I wanted to check the value. I want to check the field and the value of a cookie. And based on that field and the value of that field, I can determine the response that I want to give back to the user. So let's just very quickly pretend like this hello world cookie is required in order to actually retrieve all the products. So what you would do is something like this. You would check to see if request.cookies and then the field name, which would be hello. And then you want to make sure this is defined, and then you would want to make sure that hello is equal to some certain value. In our case, since we set the cookie on the server side and the value that we set was world, we can have it check to see if it's equal to world. And if it is, then we'll send back the response of all of the products. And if it's not, then what we'll do, let me actually use the return keyword. And if it's not, I'll just return a response that says, message, sorry, you need the correct cookie. And this is just to show you how you can use cookies, okay? Or how you can use cookies to determine the output of your server response. So if I click send right now, okay, nothing special. But now watch this. I'm going to go ahead and let's see. I'm going to remove this cookie right over here. And I'm going to go ahead and click send and watch what happens. You see how now, since I don't have that cookie, it says, sorry, you need the correct cookie. Now, if I go back to the browser is a different client, okay? So right now we're using two different clients. We're using the web browser and we're using our Thunder client. So since the browser still has a valid cookie, I can still get this data. But let me go back into my browser's dev tools and let me clear the cookie by simply just deleting it. And watch this. If I refresh the page, you see how now it says, sorry, you need the correct cookie. So this is how you can start to understand how authentication begins to work. The server sends a cookie back to the client. So that's basically saying, hey, when I send this cookie back to you, you need to send this back to me in order for you to make future requests to access any data or any endpoint at all. The browser stores that cookie, and then any future requests that you want to make from the browser or the client, from Thunder client, you need to pass the cookies from the browser or the client or wherever. When you send the cookies, the server will check for the cookies. If you have the cookies and it's a valid value, then you'll send the data back to the user. If the request does not have the cookie, or if they do, but it's not a valid value, then you're going to send them a different response. So hopefully you can start to see how cookies can change the output of your application and how you can use it for, authentication and authorization. So one more thing that I will show you is this. I'm going to go ahead and set the max age of the cookie to 10 seconds. And so what I'll do is this. So since this route is the route that actually sets the cookie itself, you can pretend like this is the route that you must visit first in order for you to kind of like authenticate, have the cookies set on the server side and sent back to the browser, and then be able to access the quote unquote protected route. Hopefully that makes sense. Okay, so right now, if I try to go to /API/products, I cannot access the resource over here. And you know what? Let me do one more thing. I'll also send a 403, which means unauthorized, or you can send a 401 back. So you see 403 forbidden. Okay. So now let's do this. Let's go back to the base route and kind of like quote unquote authenticate, because this is what gives us the cookie. We can see that the cookie is sent back. And now watch this. If I try to go to /API/products, I can get this response back. But notice how after that 10 seconds pass, it says, sorry, you need the correct cookie. So the cookie expires after 10 seconds. And you can see that we don't even have any cookies anymore because it automatically clears it for us. So I can go back to the base route, re-authenticate, call the API/products route, and I can make as many requests as I want to this endpoint until once the cookie has expired. And once it expires, it gives me the alternate response. Okay, so hopefully this makes sense. Now, since we are already talking about cookie parser and using cookies, I might as well just talk about this as well. If you ever need to set signed cookies, which, like I said earlier, it has a signature, you can go ahead right over here and set signed to true whenever you set the cookie. But in order for you to actually parse cookies that are signed, you must provide a secret. Like right now, if I try to refresh, or if I try to go to the base URL, you'll see that it says cookie parser secret required for signed cookies. So let's go ahead and pass a secret right over here. Let's just do hello world. Literally, it can just be any string value you want that is just going to be used for signing cookies. Okay, so now watch this. Okay, before we added this signed property in the options when we set the cookie, we were just able to see the value world. So let me just show you this real quick. Let me just kind of delete this and delete that and just show you very quickly. See how the value is just world. Okay, now let me go back and set sign to true and put in that secret. So now watch this. Let me just delete this. And if I refresh the page, you see how now the value isn't just world. You can actually see the value is here, but because now it's signed, it has the signature. And in order for you to actually use the signed cookie, well, because we already are enabling the middleware already, it will just parse the cookies for us. But remember how earlier we took a look at the request object and there were two properties related to cookies. There was cookies and then signed cookies right over here. So we want to reference signed cookies. So watch this. Let me just refresh on this page. Let me change the max age of the cookie to 30 seconds. So 30,000 milliseconds. And let me go back here. So now let me go to /API/products. You see how now it says, sorry, you need the correct cookie? This is because we are checking just the cookies and not signed cookies. If I look at the console right now, you'll see that this is the raw cookie over here that comes from the headers that is not parsed into an object. So you see you have the key and then the value right over here, exactly what you saw in the browser. Then you have this object, an empty object, which is the request.cookies property, so an unsigned cookie. But because now we have signed cookies, all of those parsed signed cookies will go into that signed cookies object in the request object. So you have this object right over here. Okay, so you can actually just reference hello on the signed cookie like that. So if I refresh this page, well, we don't have a cookie, so we need to go back to the base URL, quote unquote, re-authenticate, get the cookie set, and then now let's go back to the API products route. And if you look at the logs, you can see that whenever I reference the signed cookies object and reference hello, it gives me this value of world. So we can just very easily modify this part over here. If request.cookies, instead of that, we can just do if request.signedCookies.hello. And of course, you would need to keep track of what cookies are signed and what cookies are not signed. So that will indicate which property, whether cookies or signed cookies, that you would reference. So if request.signedCookies.hello and request.signCookies.hello is equal to world, then we'll send back this response. So let's save, and now our cookie likely expired by now. So let's go back to the base URL, get that cookie again, go back to API/products, and now we have access to the resource. So hopefully this all makes sense. In this part of our tutorial, we are going to talk about sessions and implement them in our Express server. Sessions represent the duration of a user on a website. By default, HTTP is stateless. We don't know who is making requests to our server, so we need to be able to track requests and know where they are coming from. One common usage of sessions is to manage user authentication. Sessions are created on the server by generating an object with a session ID. When an HTTP request is sent to the server from the web browser, the response can return with instructions to set a cookie with the session ID so that it can be saved in the browser. This allows the browser to send the cookie on subsequent requests to the server. The server can then parse the cookies from text to JSON, then verify the session ID was sent from the client and determine who the request was sent from. Whenever the browser sends the cookies on each request, the server can look up which user pertains to the session, as the server maintains a mapping of each session ID to the user. We'll get started in implementing sessions using the Express Session library. So the first thing that we're going to do is install the Express Session package. So in my project terminal, I'm going to type npm I express-session. And then we need to go into our index.mjs file, or whatever root file you have where you create the app instance or the Express instance. And then you're going to import session, and then from express-session like that. So this session import is a middleware function, and we can register it by simply just using app.use. So app.use, and then session, just like this. And you want to make sure that you are calling app.use right before you are registering any endpoints in your application. So remember that I'm using this router that is imported from routes right over here. And this file over here has all of my individual routers for products and users. Okay, so what I'm making sure is I'm calling the session middleware function before my routes are being registered. So now the next thing that we want to do is configure some options for Express Session. So the first thing that we will do is set a secret. So I'm going to pass in an object, and so for the secret, this is going to be a string. Now, ideally, you'd want this to be something that is sophisticated because it is used to actually sign the cookie. And if you have it something guessable, someone can easily use that value to decode signed cookies. For now, just for development purposes, I'm just going to use Anson the dev, but just keep in mind you would want this to be something more complicated and not guessable, kind of like a password. I'm going to set this property called save uninitialized. Now, this property alongside with the next property I'm going to set called resave, both of these have to do with session stores. We currently don't have any session stores configured. By default, Express Session does use an in-memory store, but you want save uninitialized set to false when you don't want to save unmodified session data to the session store. So what that means is, by default, if you have every single user visiting your website and they're not doing anything, they're just visiting it, if you have save uninitialized set to true, it will actually save a session object to the store, even if the session object has nothing at all. And that can actually take up memory, and you probably won't want to have a bunch of random session objects living in your session store. So ideally, you'd want this to be set to false. And it's recommended if you're building something like user authentication, managing user sessions, things like that. The other property that we want to set is resave. Okay, and this really has to do with forcing a session to be saved back to the session store, even if the session itself was never modified at all. You'll better understand what I mean by modifying the session once I show you how to actually do it and what it affects, how it affects the actual session itself. But for now, don't worry about these two properties, just set it to false. The other property that I want to set is this cookie property. And this is where we can actually configure how long we want the cookie to live, because in case if you didn't know, cookies can actually expire. So this is good if you have a user login system where, let's say, you want the user to be logged in to your website a max of 24 hours. So you can set this max age property, and the value is a number and it's measured in milliseconds. So for example, 60,000 milliseconds, that is 60 seconds. Times, let's see, 60, so that's 1 hour. So let's say if I only wanted the user to be logged in for exactly 1 hour, then the cookie will expire after 1 hour, and that cookie will no longer be valid. And so whenever they send it back to the server will see that the cookie is not a valid one at all. And remember that the cookie that is sent from the browser to the server is what is being used by the server to identify who the user is. So I'll keep everything simple and use my base URL endpoint. And what I want to do is inside the request handler, and you can use any endpoint you want. I'm just going to go ahead and console log request.session. And I want to console log the session ID as well. So you can either reference session ID or you can reference session.id. And I'm going to go and make one API request to this endpoint. And you'll see that when I make a request, I can see the session object as well as the session ID being logged. And you can see that the session object has this cookie property, which is an object. And you can see that the expiration date is over here. So it's in UTC time. Currently, it's 2:44 a.m. So I think I'm 7 hours behind that time zone. So that would be 9:44 and then expires in 1 hour. So the expiration date time is correct. But let's focus on this session ID right over here, okay? So I'm going to make another request, and notice how when I make another request, you can actually see that not only does the expiration date update, but also this session ID is regenerated. I can create another one and another one. So every single time I click send, it's going to pretty much like create a new cookie and also create a new session. And this is actually not necessarily good because we never can actually track who the user is that's using our application. So this is where you need to modify the session data object. When you modify the session data object, express session will create a cookie, or it will set the cookie, and then that cookie will be sent to the browser or the client side. The client side will store that cookie, and then on subsequent requests or future requests, that cookie will be sent to the server, assuming it has not been expired. Okay. The server, of course, will go through the express session middleware, because remember, express session is a middleware, so it'll go through this whole session middleware, and then it'll validate that cookie, make sure it's not an invalid cookie. So if the cookie is not expired or if it's not invalid, then express session actually won't generate a new session or session ID at all. Okay, so hopefully that part makes sense, because by modifying the session data object, we can begin tracking users that are using our website, our API. If we don't, then we'll just always have generated sessions all the time, brand new sessions all the time. Okay, and remember, if you had save uninitialized set to true, it would save all of these sessions, even if it's not modified, to the session store. So that would use up a lot of memory for no good reason whatsoever. So what I'll do right now is I'm going to modify the session object by just simply referencing request.session, and I can attach dynamic properties onto this session object. So let's do a simple one. I'm going to go ahead and reference visited, and I'll set this to true. And I'm just going to remove the session. Oh, I'll leave everything alone for now. And now watch this. Okay, let me go into my Thunder client, and I want you to take a look at what happens now when I make my first request. So the server just restarted because we're using NodeMon. So whenever I make changes, it'll restart the server. But I just made one request, and you can see this is my cookie, and this is my session ID. Notice how now when I make a new request every single time, you see how now the session ID is the same every single time. Okay, every single time I make a request, session ID is the same. And the reason why this is good is because now I can actually track the user. You can see that we have this visited property on the session object. And since the ID is not going to be generated every single time, the server itself knows what the session ID is. They can look up the session ID and attach the correct session data to the incoming request object. So we'll know who which user is. So let me show you an example, okay? So what I'll do is I'm going to go ahead into any endpoint right now. I can go into any endpoint. And what I want to show you is if I go into, let's do /API/users. So this endpoint gets a list of all the users. And I'll just console log request.session and request.session ID. And I'm going to go back into my Thunder client. So remember, the server just restarted. So because we are not using a persistent data store for our sessions, everything gets wiped out because everything is currently in memory. So I'm going to go ahead and click send for our base URL. I'm going to make a request to the base URL first because that is the endpoint that will actually set the cookie for us. Okay, it'll modify the session data, which will set the cookie and then send it back to the client. So if I click send, okay, you can see that I have my cookie generated right over here. And also, if I click on cookies on Thunder client, and if you're using the browser or if you're using Postman, you can also look at the cookies yourself. But you see how I have this cookie right over here. And you'll notice how everything after these, let me see if I can zoom in a little bit. You'll see that everything after these first 4 characters, all the way up until this dot, so this whole thing right over here is actually our session ID. You can see that they match. If I put them side by side, you can see that they match right over here. And then, of course, everything over here is the signature of the cookie because it's signed. All right, so now that we have our cookie from the server, now I want to show you what happens when I visit a completely different endpoint. So let's go to API/users because that's where we're also logging the session data as well. Okay, so right now we have a cookie. We're sending that cookie to the server. The server is going to make sure that cookie is a valid cookie. And if there's any data for that session ID that was retrieved from the cookie that was sent to the server, if there's any data in the session store, it's going to map it to that incoming request object. Okay, so basically this session object comes from the session store essentially. It kind of gets restored. But let me make a request. So I just made a request just now. And notice how when I made that request, okay, I get the same exact cookie right over here. Okay, you see how I have the same session ID in a completely different endpoint. You see how this object now logs visited true, whereas before the previous one didn't, obviously, because we didn't have a cookie set properly when we visited this base URL. Okay, but when I visit this base URL, we modify the session object. So then that will set the cookie and send it to the browser. We make another request to the user's API. So when we do make that request, request.session now has that visited true property set, and it has the same exact session ID. So it's important to understand this because now we can actually build out some kind of authentication system and know who each user is. One more thing that I do want to show you is I want to show you the session store currently. So remember that by default, the session store is in memory, so it saves everything in some data structure and it lives on the server. And of course, this is not good because one, it's volatile. So if the server goes down, and you may have seen this already, we have to visit the website again and have a new session created for us. So I just want to show you this real quick. So let me reference console.log request.session store. And I'm going to call this get method, and I can pass in any session ID. Okay. And then let's see, we have to pass in a callback function. So that's okay. Let me actually do this instead. So I'm going to pass in request.session.id and a callback function. So let's see, error and session data. And I'll just do if error, throw error, and then I want to console log the session data, just so you all can see what this looks like. All right, so now let me do this in my browser. Okay, so I have these cookies set, which are not going to be valid anymore because we just restarted the database. So now if I go to the base URL first, we have the cookie set. And let me just kind of go to my console and scroll down. Okay, so this is our session ID. Now if I'll go to the user's endpoint, okay, same cookies. But notice how this is coming from this part right over here, line 29. So notice how when I call request.sessionStore.get, I can pass in any session ID. And of course, if it exists, then it will give it to us, which I'm logging it right over here on line 29. So that's where it's coming from. Okay, so that is how the session store stores these session object data. So I hope that makes sense because I really want you all to see this visually, because just by saying it, it kind of doesn't really help you understand how things are being saved underneath the hood. But at least it helps you better understand that now we can see that this session data is stored in some data structure on the server in memory. But in later parts of this tutorial, I'm going to show you how to use an actual database to store the session data. So that way, when your server goes down, the session data gets restored. So I did want to provide another example with how to use sessions in Express. So what I'm going to do is show you all how to set up this fake authentication system. It's not like a real authentication mechanism, but the goal of this is to help you understand how we can map a single session ID to a realistic user in our application. So I'm going to go into my main index file and I'll just set up the route inside here instead of having to create like a new router and such, because I want to keep this simple. So I'm going to reference app and whoops, sorry about that. I'm going to reference app and I'm going to call the post method to set up a post request. And the endpoint for this will be /API/auth. And then we will need a request handler. I'm not going to do any validation on the request body, just because, like I said, I want to keep it simple. We'll just assume that the payload that we're sending, the request body that we're sending to this endpoint is correct. All right, so let's go ahead and grab the request body. And then what we want to do next is let's go into our constants.mjs file. If you don't have a list of mock users, then you could just simply create one. Or like I said, you can just pull the code from GitHub. But I did actually do this earlier. I provided a bunch of passwords for each user object. So that way we can actually use this example. So go ahead and make sure you have a username and a password. These two are important. Okay. So what I'm going to do is whenever we make a request to this endpoint, we're going to go ahead and look up the user by the username. And we can assume that the username will be unique, which is pretty standard in applications. So I'm going to go ahead and destructure from the request body, and I'll do this all on this one single line. I'll destructure username and password, and of course, we are assuming that these fields do exist, okay? Again, I would recommend you yourself validate your actual request bodies. And if you don't know how to do that, check out the section where we talked about validating post requests or validation in general, and you'll learn about that. So what I'm going to do is now I'm going to reference mock users, but I do need to import that into this index.mjs file. So let me go up top here and import mock users from utils constants.mjs. And then I'll simply just do a search on the user. So const find user equals mock users find. and then we're going to pass in the predicate. So we want to search for the user by username. So I'm going to pass in this predicate function, and the argument for that function is going to be the user object. So I'm going to reference user.username and compare it to the username that we're sending to this post request. So this will search for the user by the username, and if it does not return a user, find user will be undefined. So from here, let's set this up. So what we'll do is we'll check to see if find user is undefined. So if not find user, okay, then what will happen is we'll return a 401, return response, status 401, which just stands for unauthenticated. So let's just do send message. You can also just send the message as bad credentials, like that. So of course, if the user is found, then this whole if statement will not be executed. But if it is not found, then it would return a 401. Next check that we want to perform is checking the passwords, making sure that they match. And like I said, we are checking raw passwords. That's okay for now. Later on, you'll learn how to actually hash the passwords and save it to the database, and then also be able to compare hashed passwords. So I'm going to go ahead and write another if. So if find user.username, oops, sorry, not using password. I'm going to do if it's not equal to password, then I'm going to return the same exact response right over here. Okay, let's see. Okay, that's fine. And then I could probably also just, you know what, I could probably just combine this into one single statement. So if there's no user, or if the passwords don't match, then we'll just send this back. I guess that can work fine. Now remember, the main purpose of this endpoint is to modify the session object, because we want to stop generating new session IDs every single time. We want to be able to allow Express session to generate that session ID once, set the cookie, and then send that cookie back to the browser or the client. So that way, when the client sends another request, we can use that session ID and look up the session data. And from the session data, we can see which user actually belongs to this session ID. So what I'll do here is, I'm going to reference request.session, and then I'm going to attach this dynamic property called user, and I'm going to attach the find user value to this user property. So remember, we can attach dynamic properties to objects in JavaScript. So I'm going to do that right over here. And then this should modify the session object, and that will have Express session set a cookie and send it back to the browser or the client as a response. Okay, and then the browser will have that cookie, and now they can use that cookie to send it to the server, and the server will know who that user is. So watch this. Let me go ahead and return response.status. I guess 200 would be fine for logging in. And then let's send back the user that was authenticated. Okay, so this endpoint should work. Let's just test it out. So let me go ahead and make a new request. Post request, localhost, port 3000/API/auth. And we'll pass in a username. So let's actually, let me go into my mock users array. So I'll do Anson, and then the password for Anson is hello123. So Anson, and then password. Okay, so now you can see that right over here, I have logged in. Okay, obviously you wouldn't want to return the password back, but like I said, just a simple example. If I look at the cookies, I can see that I have my cookie right over here. Okay, this is my session ID right over here. So now that I have logged in and I have a cookie set on this client side right over here, I can now make requests to the server. And the server will receive that cookie. It's going to parse it, and it's going to take that session ID that it got from the cookie and then map the session data object to that session ID itself. So what I'm going to do now is this. I'm going to go ahead and set up one more endpoint, app.get/API/auth status. And this is just going to show the authenticated status of the user. So whether the user is authenticated or not. In this context, we can tell if the user is authenticated by checking to see if request.session.user is defined. Because remember, this right over here is what actually indicates that the user is quote unquote logged in. The moment that we modify the session, and we're only doing it when we find the user and the passwords match. Okay, so what I can do is I can just simply check. Let's do this. I can use a ternary operator, so return request.session. If user is defined at all, then what I'll do is I'll return a response status code of 200, and I'll just send back request.session.user. And then if the user is not defined on the session object, then I'll just send back a 401. So I'm just gonna copy what I have up here, but I'll just simply say not authenticated. Okay, hopefully this GET request that I'm setting up makes sense. So we have one endpoint that actually does the quote-unquote authentication. The other endpoint gets the authentication status. Hence why I call this endpoint /API/auth/status. So our server just restarted. So again, everything is in memory, so it gets cleared. So we do need to re-authenticate again. So I'll just show you real quick. Let me delete all the cookies. Okay, let me just... Okay, so let's click send to the same endpoint for /API/auth. We're going to send this username and password payload. Okay, so I just got back a cookie right over here. And now watch this. If I were to now visit the status endpoint /API/auth/status endpoint and make a GET request to it, you're going to see that the response is going to be the actual auth user. Okay, the response is the actual auth user. Watch what happens if I clear my cookie. Okay, so if I clear my cookie right now, and if I try to access this endpoint, you see how it gives me a 401 unauthorized error? See, not authenticated right over here. And remember that I cleared the cookie from my client, so the server received the request, it received this GET request without any valid cookie. Okay, and since there was no valid cookie, there was no mapping between that session ID from the cookie to a user that's in the session store. So hopefully that makes sense. And additionally, what I'll do is let me just quickly reference request.session_store get, and let me call the get method, and let me pass in that session ID, and then error session. I'm just going to log the session just to show you all how everything, again, is stored in memory. So let's go ahead and do this. Let's make a post request to /API/auth. Of course, if I pass in an invalid password, it'll say bad credentials. If the user is not found, same thing. So let's log in. Okay. I have my cookie right over here. And now let's visit the status endpoint for /API/status. Okay, we're good to go with that. And if we look at the console, I want to show you that right over here, we are logging the user in the session store. Okay, right over here. So if I go back and click send, you'll see that it gets logged every single time. We're grabbing the session data from the session store, and the session data object that we retrieve by that session ID has this cookie property that gives us information about the cookie, and then it has this user property, which is the user object itself. So that is how the session ID maps to a user on the server side. So I really hope this makes sense, because if you understand this, then you can understand really anything with sessions. And I really hope that all of this makes sense, because I can understand sessions are kind of a little bit difficult to understand, but by seeing how the data is saved on the server side and how we can actually retrieve it so easily like this and map it to the session ID, that can help you understand sessions a lot better. Now what I'll do is I will authenticate on Thunder client with this set of credentials, and then I'm also going to authenticate on Postman with a different set of credentials, just so that you can see how with different clients we can authenticate with different credentials, and we can see the status of our authentication, and then you'll actually see how the server manages multiple different sessions. So let's just very quickly, let's see. Okay, so we're not authenticated, so let's make a post request to /API/auth with username Anson and the password hello123. Okay, so we're authenticated here. Let me grab another set of credentials. So Jack and hello124. So let me go into Postman, make a post request, HTTP localhost port 3000 /API/auth. Let's click on the body tab and then select raw and then make sure it's set to JSON. Whoops. And then so now let's set username to Jack and the password was hello124. Okay, and remember, we're in a completely different client right now. Postman is its own environment, obviously. And just to show you this, we don't have any cookies set right now. So the moment that I click send right over here, so I just made a request and you can see it's right over here. If I click cookies now, you'll notice how on my Postman client, I now have this cookie. And of course, this cookie is different than the cookie that we have on Thunder client because we're two different users now. That's the thing that I'm trying to show you. We're two different users. You can see that the cookies are different. Okay. So if I were to visit this API/auth/status endpoint with a GET request, you can see that it tells me, let me see. There we go. I don't know why that was formatted like that. Okay, so you can see that on Postman, I am logged in as Jack. And then on the Thunder client, I am logged in as Anson. See? Whoops. Right over here, look at the response. I'm logged in as Anson. So now we have two users that are quote-unquote logged in. And you can see that the session store contains both users. They contain Jack and Anson. So hopefully this also helps you understand how the server can manage not only one, but many sessions and map each session to different users. Now I'll show you even one more example where we can set up a virtual cart system for authenticated users. So to keep things simple, I'll set up a simple post request, and then the endpoint will be /API/cart, pass in our request handler. And then we only want the user to be able to add items to a cart if they are authenticated. So if, let's say, if there's no request.session.user, return response, I'll just send status of 401. Okay. However, if the user is authenticated, the next thing that we want to do is, of course, check to see if the cart already exists on the session object, because if it doesn't, we need to add it. If it does, we can just simply add the item to the session cart. Now, of course, the request body itself will just pretty much be data relating to an item that we're adding to the cart. So just to keep things simple, the request body for this endpoint will just have a name for the item and the price for the item. That's it. So let me just destructure the request body from the request object. And I'm going to rename this to item. And we're going to assume that the field and all the values for our request body are valid. But I encourage you to practice and actually validate your request bodies. So first thing we need to do is check to see if the cart exists on the session object. And that's pretty easy to do. I'm going to go ahead and destructure the cart property from the session object. So const cart, and then inside these curly braces where the cart variable goes, equals request.session. So if cart is already defined, I could just simply do cart.push item, and this should be able to just modify the cart. And then if the cart doesn't exist, then what I can do is I can reference request.session.cart equals an array and then pass in that item as the first element in this cart array, just like that. And then once we're done, we can just return a response status of 201, and I'll just send back the original request body. So let's test out this logic. Let me go into Postman. So I'm currently not authenticated. That's okay. If I try to make a post request to API/cart, it's going to give me unauthorized. That's perfectly fine. So let's first authorize. So make a post request with our credentials to /API/auth. So we are authenticated. And now let's go ahead and add items to our cart. So name, orange, and then price. Let's do, whoops, that should be a number. Let's do $1.99. Click send. Okay, so that's our cart. Okay, so now I can see that this was the item that was returned, so that's good. So what I want to do now is I want to actually see the cart. So what we can do is make a GET request to auth/status, and this should return, I guess, only the user, but we want to get the cart. So let me do this. Let me set up a quick app.get route for the cart itself. So I'm just simply setting up a GET request for /API/cart. And then I'm going to do the same thing up top over here. If there's no user defined in the session object, then they are unauthorized. So we're going to return a 401. And then I'm just simply going to return response.send request.session.cart. And if cart is undefined, we'll just return an empty array like this using this double question mark operator. Okay, so if cart is undefined, we'll return an empty array. So let's test this out again. So we need to re-authenticate. So let me do this. Okay, so make a post request to the auth endpoint. So now we are logged in. And now I can verify I am logged in, so that's good. So if I try to get my cart, you can see that I have this empty array. But if I try to add items to the cart, and if I make a GET request, you can see that I actually have items in the cart. So pretend like this is the API that your front end is calling, and then as you want to add items to the cart for the user, you would just pretty much add it to the session data. And then whenever you want to get all the user's items in the cart, you could just grab it from the backend like this. And I can add more items. Let's do Gatorade and $2.99. And let's make a GET request. And you can see now I have 2 items in my cart. And let's go back to Postman and authenticate as Jack. So currently on Postman, we are unauthenticated. I'm going to make a post request to the /API/auth endpoint and pass my credentials. So now we are authenticated, so that's good. And if I try to get my cart for Jack, you can see it's just an empty array because we don't have any items in our cart. So let's fix that. Let's add some items to the cart. So let's do name, broccoli, and then $4.99. Okay, so now I added broccoli to my cart as Jack. When I make a GET request, this is my virtual cart that comes from the backend. And then on the Thunder client, where I am authenticated as Anson, this is my own virtual cart. So each user, each session has their own data, okay? Each session maps to its own user, and then it maps to its own virtual cart for that user. And whatever other session data that we need to add, we can just very easily attach it to the session object itself. So I hope all this makes sense. And like I said, I wanted to give you all multiple examples because I understand sessions can be a little bit tricky to understand sometimes. But what we're going to do is move on to actually learning how to set up authentication with a library such as Passport.js. In this part of our tutorial, I'm going to teach you how to use Passport.js to integrate authentication for your Express application. We're going to be using a local strategy for Passport, which just means that instead of using a third-party provider like Google, Facebook, Twitter, we're actually going to be using credentials that are saved on the actual application's database. In our case, we don't have a database, so it'll be saved in an array. But the idea is for local authentication, the application saves that information compared to using just a third-party provider to log into their application. I'll show you how to use local authentication, and then in later parts of the tutorial, I'll show you how to use OAuth 2 so that you can learn how to integrate third-party providers to log into your application using something like Discord or GitHub or Twitter. So let's go ahead and get started. The first thing that we're going to do is install Passport. So I'll type npm i passport. And since we're using a local strategy, we need to make sure we install the correct strategy package. So aside from Passport, we need to also install passport-local. Again, if you were using, let's say, Facebook as the way to authenticate users to your platform, then you would have to install passport-facebook as the strategy. And all it is just a package that you install with Passport. So let's go ahead and hit enter, and this will install the packages for us. And let me just go ahead and run my server. And now we'll go ahead and configure everything in our application. So what I need to do is I first need to import Passport. So import Passport from Passport. Now, Passport integrates really well with Express Session, and many times you will actually use Express Session with Passport or vice versa, Passport with Express Session. You don't need Express Session with Passport, but it is highly recommended, and many people do in fact use both of them together because Passport will take care of mapping that user that was just logging in with the session ID. If you need to recap on sessions, check out the previous section of this tutorial where I actually showed you multiple examples of how to use Express Session. So what I'm going to do after importing Passport is I'm going to enable it. So where I am registering the session middleware, which is right over here, I want to make sure I am registering Passport after I enable the session middleware because that needs to be done before. And then we also need to make sure we enable Passport before we register our routes. So in between the session middleware being registered and where we are registering our routes, I'm going to go ahead and call app.use, and I'm going to reference Passport and call the initialize method just like that. Okay. And then since we are using sessions, I'm going to call app.use again and pass passport.session. Primarily, this will take care of actually attaching a dynamic user property to the request object called user. And then you can actually access that user object by simply just referencing it from the user or from the request object. And then you can know who the actual user is that is making the request. I'll show you how that works later on. So that's all we need to do inside our index.mjs file. So next thing I will do is I'm going to go into my source folder. I'll create a new folder and I'll call it strategies. So this is where I will have all of my strategies. So right now we currently will only have a local strategy. So I'll create a file called localstrategy.mjs. And what I'm going to do is import Passport. Let me zoom in a little bit. So import Passport from Passport. And then we want to import this strategy class, and it comes from the Passport local package. Now, all of the strategies will have this strategy class. So if you installed the Passport Facebook package, it would have its own strategy class. I just wanted to mention that. And then what I'm going to do is I'm going to call passport.use. And this is where we tell Passport to actually use our strategy. Okay, so we need to pass in an instance of this local strategy right over here, of this strategy class. So I just need to simply create a new instance. So new strategy like this. Now the strategy constructor can take in actually two arguments. I don't know if you saw right over here. You can pass in options or you can pass in this verify function. For now, I'm going to just ignore the options because you won't really need this. And later on in the video, I'll explain when you'll actually need this options. But I'm just going to specify this verify function. So that's just going to be this callback function right over here. And this callback function takes in three arguments. It takes in the username, password, and then it takes in this done function. Now, since my application takes in a username and a password, this works perfectly. The way that these arguments get passed to this callback function is whenever you make a post request to your endpoint that takes care of handling authentication, Passport will look for the username and the password inside the request body that was sent to that post request endpoint. And then it will pass it in as arguments to this callback function. So this is assuming that we do in fact use a username to authenticate. Now, sometimes you might not use a username. You might use something like an email, or maybe the username might be named differently. So that is where you actually need to pass in this options right over here, because you need to tell Passport that we're actually not using a username field, but we're using, let's say, the email address field. So what you would do is you would specify this username field, and then you'll tell Passport, okay, the actual username field is the email field, like that. Then Passport will look for the email field in the request body and then send that as the argument for username. So I just wanted to mention that. I'm going to leave this out for now, and then once we finish implementing this strategy, I'll show you how it actually works. So what we'll do is inside here, this verify function, think of it like this. This is the function that is responsible for doing a couple things, but the main thing is to validate the user. So you need to make sure that the user actually exists, and then you need to check to see if the passwords are the same, the password that we sent to the server, and then the password that was attached to the user object itself from the database, or in our case, an array. So those are the two main checks. Of course, there might be additional checks that you would want to perform, but generally those are the two major ones. So again, the first thing that we need to do is search for the actual user. Right now, I don't have a database set up, but if for some reason you might have one already configured, then what you need to do is just use whatever database module you're using to interact with the database, search for the user by the username in this case, find the user, and then once you find the user, check the passwords. So let's do that. So I'll go ahead and declare a variable called find user, and I'm going to import that mock users array. So this array just has a bunch of users right over here with a username, ID, display name, and password. And I'm going to use the find method to search for the user by the username. So user.username is equal to username. Okay. So this will search for the user by the username. If the user is not found, then we actually want to throw an error. But before we throw any errors, let me actually wrap all of this inside a try catch. Just like this. So that way, now when I throw my error right over here, and I'll say for the message user not found, that error will be caught inside this catch right over here. Okay? Now let me go ahead and do this. If the user is not found, we'll throw an error. I'll handle the error case in just a bit, but I want to move on. So let's say if the user is found, we want to check the password. So if find user.password is not equal to the password that was sent to the server, then we're going to throw another error. We'll just say user or password, I'll say invalid credentials. Okay? Okay, so now let's handle the errors that could be thrown. So we're going to catch those errors inside this catch block right over here. And what we want to do is we want to go ahead and call this done function when we handle the error. So notice how this done function, it takes in two arguments. It takes in an error, and it also takes in a user, which could be a falsy value. So of course, when an error happens, that means the user itself was not validated correctly. Okay, so that could be either the user was not found or the passwords did not match. So in this case, we want to make sure we do pass in that error object. And for the user, we can just pass in null like that. And then this will just pretty much move on from this verify function into the next step, which we will get into. Okay, so that's what we have to do for the catch. Of course, when we are done validating the user, if both of these cases are false, so if the user actually is found and the passwords are actually correct, they do actually match, then we want to make sure we also call the done function. But this time, there are no errors, so we'll pass in null. And then for the user, we'll pass in the user that we found, like this. And that's it for the verify function. Okay? So, like I said, for the database, you would query the database, find the user, check the password, if the user exists, of course. And then any errors that could be thrown would be caught inside this catch block right over here. Hence why we're using try and catch. And then if everything is good, you'll call the done function, pass in null for the error because there were no errors, and then pass in that user instance. Any errors would be caught with this catch block, and then you would call done, pass in that error instance, and then Passport would take care of handling that error for us. Okay, so the next thing that we need to do is we need to actually register our middleware, our Passport middleware, because right now all this does is it validates the user, but there's still a whole bunch of things that we have to do, especially since we are using Passport with Express Session. Okay, so we need to import this local strategy file into our index file, but first let's actually export this passport.use call. So I'm going to do export default passport.use, and I'll import it right over here like this. So import and then the path to the file. So this will literally import this whole thing right over here into our index file. Okay. And then now we need to set up an endpoint that we can actually use as our authentication endpoint, where users will make a request to, or the HTTP client will make a request to. It will pass in the username and password in the request body. And then that endpoint will take care of invoking our Passport middleware. So it'll actually invoke this verify function. Let me just quickly log out the username and password. Let me just do this. Username. And let me do the same thing for password, so that you all can actually see what's happening underneath the hood. Okay. So let's go ahead and set up our endpoint. I'll just do this inside the index.mjs file, just to keep everything simple. If you've been following along the entire series, I recommend you put everything in its own router. But let's go inside our index file and let's set up, let's do this app.post. So the path will be /API/auth. And then we need to pass in passport.authenticate like this. And we're going to call the function like that. And then we want to also pass in our final request handler. So let's do that, request and response. And then let's go ahead inside this authenticate function call. We need to specify what strategy we want to use. And it's literally just going to be the name of our strategy. In our case, the strategy for local is just local. So we're just going to pass in local like this. Okay, that's literally all we have to do. Of course, if you're using Discord strategy, you would pass in Discord. For GitHub, you would pass in GitHub. For Google, you would pass in Google like that, and vice versa. So hopefully that makes sense. Okay, so now what I'm going to do is I'm going to go ahead and make a request to /API/auth, making a post request to it. And you'll see how it's going to go ahead and invoke this passport.authenticate middleware function. And then it'll call this verify function. So let's do that. Let me go to Thunder Client. Let's do this. Okay, so post request to our API/auth endpoint that we just set up. Click send. Okay, so ignore this error for now. I'll address that in just a bit. But let's take a look at the console and let's see what's going on. You can see right over here, username and password are being logged. So that verifies that we are actually inside this callback function. So Passport actually called this callback function right over here. And then all of this logic is being performed. Okay, so it's going to go ahead and search for the user. If the user is not found, it'll throw a user not found error. So let me type in a username that doesn't exist in our array. So when I pass in this username Anson, you see how it says user not found. That's the error that I manually thrown over here. And then it gets caught right over here, and then it calls the done function. Okay. Notice how if I actually don't even pass in, if I pass in a null value for error, we actually won't even get an error. This is a completely different error. I'm not sure why it says 4.1 unauthorized. But yeah, see, it doesn't throw that error, but it gives us that instead. Okay. But of course, let me pass the error back. Click send and pass in the invalid username. It will say user not found. Let's say if the user is found, but the credentials are invalid. And so I'm going to pass in the wrong password. It'll say invalid credentials. So before I move on, let me just show you real quick about the username field that I mentioned earlier. So let's say, for example, you are expecting the user to provide the email address as their username. So let's say that we have email. Let's just do anson@gmail.com as an example. So watch this. What we need to do is we need to pass in that options right over here. And then we need to pass in this username field and just specify the field that's going to be our username, which in this case is going to be email. And if I click send, you'll see now I can actually use the email field as my username. And if you look at the logs, let's show you right over here. Okay, right over here, username anson@gmail.com. Okay, you can of course change up the arguments, so change the email like that if you want to. So hopefully that makes sense, and that shows you how you can use the username field. If let's say the username field was something else, let's say if it was something like user_name for whatever reason, then you could just specify that. Okay, and of course if I try to send this will no longer work. If I try to use username like this, that will not work. I have to explicitly say user_name, so that way Passport knows which field to look for. So I hope that part makes sense. Okay, let me just remove this part. Okay, so now the other thing that I wanted to talk about was this error that I just encountered. So you see how it says failed to serialize user into session? So here's the thing. We actually successfully were able to authenticate by checking all these credentials and verifying that it was correct. But because Passport needs to actually serialize the user into the session, we need to actually implement two functions, okay? Because right now we don't have those functions implemented. That is why we are getting this error. So what we need to do is inside our strategy file, I'm going to go ahead and reference Passport, and I'm going to go ahead and look for this serialize user function. So I'm going to call that, and this function takes in an argument, which is a callback function like this, and this callback function takes in two arguments. This first argument is going to be the actual user that we are trying to serialize, okay? So first of all, what exactly does this function do? Well, this function is responsible for actually taking that user object that we just validated and then storing it in the session, okay? And that's the reason why I mentioned earlier that Passport integrates very well with Express Session. So it takes that user that we just found from this verify function, and it'll take care of storing it in the session data, okay? The second argument is going to be this done function. So inside this serialize user function, you don't really need to do anything, but just call this done function. And it takes in two arguments. It takes in an error. In this case, we're not really doing anything, so we just pass a null for the error. And you'll notice that right over here, the suggested name for the field, it says ID. You can actually pass in whatever you want for this second argument that relates to the user. So for example, I can just pass in user like this. Okay, now depending on what you pass in to this second argument actually ends up being the argument that will be passed into a callback function for this deserialize user function. Don't worry about that right now. I'm going to implement it in just a second. But what I want to do instead of passing just the user object, I want to pass in the ID of the user like this. You want to pass in something that is unique. Okay, so either the ID or a username, something that is unique that can be used to search for the user either in our array or a database. Okay, so now let's move on to the next function that we need to implement. So deserialize user is the next function. And this also takes in a callback function. And this callback function takes in two arguments. It takes in whatever it was that you passed in to the done function for serialize user. So notice how I pass in the ID. So this actually gets passed into this callback function for deserialize user. Okay, and let me actually show you this Stack Overflow post, because I think this post is very helpful for a lot of people. So I want to show it to you all. So right over here, they kind of give you like an explanation to how all this stuff works. But I want you to pay attention over here. The user was able to provide a visual flow. So you can see over here, we have both our serialize and deserialize user functions. So whatever they pass into that done function for serialize user, that pretty much gets saved to the session. Okay, and I'll show you later how that looks like as an object. But it gets saved and it gets passed right over here. Okay, well, it doesn't really get passed per se. It's just that the deserialized user will use the ID to actually search for the user inside that function that we're going to implement. Okay, if we were to pass in the username, then it would look up the username in the session data, and it would use that to search for the user in the database. Okay, but I just wanted to show you this very quickly because I think this is extremely helpful for a lot of people, instead of just not mentioning it at all. So the second argument for the callback function for deserialized user will be the done function as well. But this time, inside deserialized user, we actually need to search for the user itself. Now, again, serialized user is to tell Passport how to serialize that user data into the session. So in other words, it's going to store that user ID into the session data. Okay? And that's really all you need. Deserialized user is how we can take that ID and kind of like unpack, reveal who the actual user is. And then what happens is it takes that user object that we were able to retrieve via the ID, and it stores that user object into the request object itself. Okay, so later on, you'll see how we can reference request.user when we make requests. But what we need to do inside deserialized user is search for the user either in our database or in our array. So what I'll do is let me use a try catch. And first I'll search for the user. So const find user equals mock users. And I'm going to search by the ID this time. So user ID is equal to ID. If the user is not found, I'll throw an error. And we'll catch the error inside this catch block right over here. And then we'll call the done function and we'll pass in an error. We'll pass in the error that we caught. And then we'll pass in null for the user because the user was not found. And then if the user is found, we will call done, pass in null for the error, and then pass in the user instance like this. Okay, so again, we're searching for the user. If it's found, then we will call done, and then Passport will take care of taking this user object and attaching it to the request object itself. If the user is not found, then it will just call the done function inside this catch block with the error, and then Passport will handle the error for us. Okay, so now let me go ahead and write some logs real quick. Because I really want to show you all how this all works, and I want to show you the order of operations. Okay, because it's very important. It's one thing to actually write the code, but it's another thing to actually understand how this all works. Because when I first was trying to understand all this, I didn't know anything about this at all until I really dug deep into researching how all this stuff works. Okay, so let me write some logs. Okay. Okay. So let's go ahead and do this. Let's make a post request to /API/auth. So notice how right now it's still processing the request. It's not going to send a response back. Don't worry about that yet. But let me just show you what happens right over here. Let me go down over here. Restart. Whoops, let me just restart my server. You kind of saw the logs up there, but let me just resend the request. Okay. So you can see right over here. First, we're inside the verify function because that's where we are logging the username and password. And then after everything is successful, okay, because we did pass in the correct credentials, you can see how we're inside serialized user and it logs that user object right over here. Okay, so then you'll notice that nothing else happens. Don't worry. The reason why nothing happens currently is because after we call serialized user, what happens is it's going to go ahead and call this next middleware function, which is going to be our request handler function. So we aren't doing anything inside here. So why don't we actually just send a response back? Okay, and let's try this again. Okay, so we're good. And everything is good. Whoops, let me do send status. Sorry about that. Send status. Okay. Okay, so everything is good. What's going on here? User is not defined. Seems like we got an error. Okay, don't worry about that. I will have to address that. Oh, whoops, I'm sorry. Let me fix this real quick. I passed in user instead of find user. Let me fix that. I apologize. Hopefully you all caught the error yourself very quickly. Okay, so let me do this again. So first, I'm going to click send. Good. And that error just happened earlier because when I made a second request, it actually tried to call the deserialized user function. So I'll explain that. So the first thing that happens is when we first log in, we call serialize user once. That's all we need to do is call it once. This function, this callback function, needs to be called when we log in. And we're only going to log in one time, obviously, until we log out and then re-log back in. Okay? Once we have logged in, any request that we make later on, what happens is Passport will then call the callback function for deserialize user. So this callback function is going to get called if I make another request. Okay, so let's see what happens. I'm going to click send. See how now, let's see. Okay, yeah, right over here. See how right now it's going to go ahead and call deserialize user inside deserializer. And it says deserializing user ID of 1. Okay. And again, it's calling serialize user because we're actually trying to call the login endpoint. But you'll notice that if I try to call another endpoint, it's not going to call serialize user. Okay, but you can see the order of how things are working. Let me go ahead and implement another endpoint. Let me do this. Let me implement app.get/API/auth. Let's implement a status endpoint, and this endpoint is responsible for checking to see if the user is authenticated or not. Okay, so remember how earlier I said that the user object will be attached to the request object? So if I were to console log request.user, and let me just go ahead and write inside, because we have a bunch of logs everywhere, so I want to label everything. And then what I'll do is this. So I'm not going to send a response back. I'll just log this right now. Okay. So let's redo everything. Let's log in. So let's go ahead and call this endpoint. So it goes ahead and we log in. It calls serialize user. And then inside serialize user, we log the user. That's fine. Now let's make a get request. So let me hit new request. Okay. I'm going to make a get request to that new endpoint /auth/status. And now inside this status endpoint, we want to make sure that we are only sending a response back, the user response back, if the user object actually exists on the request object. And that's a good indicator to let you know if the user is authenticated or not. So if request.user, I'll return a response with the user object. And of course, if the user is not defined, if this property is not defined, and there's no value, then we'll just simply return response. Let's do send status 401. And let me actually just quickly use it. I'm going to use a ternary operator instead. Return request.user. So let me just copy that. And then response send status 401. So now I can remove this. Okay, hopefully that makes sense. Oh, whoops, sorry about that. Okay. Should have been colon. So this is a ternary operator right over here. All right, so let's go ahead and do this. Let's log in right now. So I'm going to make a post request to my authentication endpoint. Click send. Okay, we're good. Now let's go ahead and make a get request to the status endpoint. Let's see, user is not defined. I might have an error somewhere else. What's going on over here? Oh, whoops, I forgot. It's not user, it's request.user. Okay, let's relog in. So you'll see that when I log in, we are inside serialize user, so that gets called, that's fine. So now we don't need to log in anymore because we've already logged in one time. So we should be logged in. So if I click this right over here, you can see that I can access my user reference because I'm logged in as Anson. And notice how when I make a request to this endpoint, it's going to go ahead and call the deserialize user function. You can see the logs are right over here. And again, what happens is the deserialize user function will use that ID from the session store. Okay, because that's where the data is really being saved inside the session store and also the session object itself. And then it will use that to search for the user. In this case, we're only saving the ID. Let me also show you one more thing that was also mentioned in that Stack Overflow post as well. Let me console log rec.session. And let me just do this. Oh, whoops, it's whoops, sorry about that. It's request.session. Yep. Okay. All right, so let me do this again. And let me go down here. Okay, you notice how right over here, and the reason why I'm showing this, because again, I want you to understand how all this works. Notice how now the session object has this passport property. And if you saw the part where we talked about express sessions, you'll remember that as soon as you modify the session object, it sets the cookie and sends it to the front end or the client. So if you see right over here, if I look at cookies, I actually have this cookie right over here, and this is my session ID on the server. Okay. So as soon as we modify that session, which Passport is modifying the session for us, so it attaches this Passport object to it, and then notice how it takes this ID and then maps it to the user like that, and that's assigned to the Passport object. And now watch this. If I were to go back to serialize user, and if I were to change this to, let's say, username. So let me do that real quick. So let me change it to username. I'll just remove this log right over here. So let's search by the username. Okay. And now I want you to see what happens. So I'm going to log in right now. Okay. So I've just logged in, and I'm going to make a request to that auth/status endpoint. And now if you look at the logs, you can see that we serialized the user by using that username field. Now, some of you might wonder, well, why can't we just pass in the whole user object? So let's say, for example, instead of just passing in the ID or just the username, I pass in the entire user object right over here. So since we have the user object, I probably don't even need to search for it. So you know what? Let me just comment all this out, and I'll just replace all this for now. I wouldn't recommend this, but I'll just show you what happens. So let's re-log in. And you can see how now passport.user has the entire user record populated. Okay, so let me explain to you why you probably don't want to do this. Because your session data, you don't want it to have a bunch of information that could possibly go stale. Okay, because think of it like this, right? Something like the ID is never going to change. Okay, the username might change every once in a while, but the ID is never going to change. If, let's say, the display name changes and then you deserialize the user by simply grabbing that user from the session data, and then you grab everything, including that stale display name, that's going to be returned back to the client if they request it. Okay, so if you make changes to the database, it's not going to be synced up with your session data. You'll have to manually update that yourself, and that is going to be an additional scope of work that you'll have to take care of. And you also don't want to just store a bunch of properties inside the session data that you don't really need, because it's just going to take up a lot of memory, and you're going to clog up your entire database with all of the stuff that you don't need. All you really need is just some unique identifier such as the ID or the username, and then you're good. You don't need anything else aside from that. Okay, the deserialize user function is responsible for finding that user and then attaching it to that request.user object. That's all it is. Okay, so again, you could do it, but should you? Probably not. All right, so I'm just going to change everything back to using the ID. And then let's go ahead and take a look at this. So I'm going to log in. I'm good here. I can log in as any other user I want. So watch this. Oh, and one more thing I'm going to show you. Notice how if I delete my cookies, and if I try to call this endpoint again, it's going to give me a 401 unauthorized because I don't have that cookie anymore. Okay, which of course makes sense. But let's try to log in as a different user. So let's log in as Adam. So the password is hello, hello. So I am logged in as Adam. Okay, so now if I make a GET request to the status endpoint, my credentials will be Adam Adams. So now you'll see in the logs that this is what we have. Okay, so I hope all this makes sense, and I hope you better understand how to use Passport now. And what I'll do in the next part of our tutorial is we're going to go ahead and actually set up a database, and then you're going to learn how to use the database to create the user and also save the user to the database, and then we have a full-on login logout mechanism. Before I end this part of the tutorial though, I do want to show you one more thing. on how to log the user out. In other words, just destroy the session. Okay, so what I'll do is right over here. So I'm going to set up an endpoint. It'll be a post request. So app.post/API/auth/logout. And let's pass in our callback function. And then first, let's just check to see if there is no user defined, which means the user is not actually logged in. Then I'll return a response and I'll send a status of 401, which means not authenticated. And then if they are logged in, we'll just reference the request object, and then we can just call this logout function. And then we do need to pass in a callback function for this. Okay. And then all I'll do is this. If there's any error, I'll just return response, send status 400, I guess. And I think that's really all we need to do. But if there's no errors, I'll just send a response back of 200. Okay, let's test this out now. So let's log in. And then let's see our status. So we are logged in. Let me go ahead and make a new request. So it's a post request. So /API/auth/logout. And you can see now we are logged out. And okay, so our cookies are still going to be present on our client. But if I try to make a request to the status endpoint, it's going to say 401 unauthorized, because even though we are sending cookies to the server knows that that cookie is not valid. Okay. So even if I try to, well, now if I actually try to send a post request to here, you can see that it gives us a 401 unauthorized because we are not logged in. Okay. So it doesn't matter if we have the cookie, this cookie is no longer valid. So it's going to give us a 401. Okay. So hopefully this makes sense. And in the next part of this whole tutorial series, I'm going to actually set up a database, and then we'll actually convert everything over. And then you'll learn how to actually encrypt the password as well, instead of just comparing raw passwords right now, which is what you don't want to do. So I'll see you in the next part of this tutorial. All right, so now in this part of our tutorial, I'm going to show you how we can actually connect to a MongoDB database using MongoDB as well as Mongoose. So what we're going to do is first, obviously make sure you have MongoDB installed on your local system. I do already. And I'm going to go ahead and install Mongoose, which is a node module. So let me go into my terminal. And let's do npm I mongoose, mongoose, like this. Okay, so we're good with that. So now what we want to do is let's just go ahead into our code, and we want to actually connect to our database. So it's pretty easy. So all we have to do is first import Mongoose. So let's do import Mongoose from Mongoose, and I'm inside my index file right over here. Okay. And then what I'll do is write down over, I guess right over here. I'll go ahead and do mongoose.connect, and I'm going to pass in the URI. So MongoDB is the protocol, and then the host name, so localhost, and then port 27017. You don't have to provide the port if this is the port that you use, because by default, it will use port 27017. But let's say if your MongoDB is running on a different port, then you must specify that port, because the package uses this port by default. Okay. So I'm going to omit that, but then I'm going to specify the database name. So I'll just call this Express tutorial. And then what I'll do is this connect function actually returns a promise. So I'll just use .then, and I'll console log connected to database. And then I'll also use a catch. If there are any errors, I'll just simply, write a log error, and then I'll log the error. So let's start up our server. Let's make sure everything is working fine. Okay, so you can see right over here, it says connected to database. All right, cool. So let me go ahead and open up my MongoDB GUI, my graphical user interface. Let me just zoom in a little bit. So this is MongoDB Compass. You can use whatever you want. I'm just going to use this for now. So I'm going to connect to my MongoDB database. I'll click connect. Okay, so we are successfully connected to the database, so that's great. So now let's go ahead and set up our very first schema. Now, some people might wonder, well, why are we using Mongoose and not using like the regular MongoDB package? For example, let me just show you this one over here. Some people might wonder why we're not using this Node.js driver to interact with our MongoDB database. The reason why is because realistically in projects, you're not actually going to be writing actual Mongo queries like they do over here. You're going to be using an ORM for many realistic projects because they are very safe to use for your code base. It's the same reason why many people use ORMs for SQL, because it just takes care of a lot of things for you, and it also takes care of structuring your data. It makes it a lot more easier. Okay, so I just wanted to mention that in case some of you might wonder why we're not using the regular MongoDB driver, but instead we're using Mongoose. Okay, and Mongoose is very popular. Many people use Mongoose. If you look at the Node module on the website, you see there's 2 million downloads, so it's not going anywhere anytime soon. Okay, anyways, let's go ahead and create our schema. So we're going to create a new folder, and I'll call this, I guess, Mongoose. And really what a schema is it's just a way for you to define your database collection. You want to actually shape how your data is going to look like. And we do that using a schema. So I'm going to create a folder called Mongoose, and I have my folder called schemas, and inside that schemas folder, I'm going to create a new file, and I'm going to call this user.js. Okay? And this is where I'm going to create my user schema. Because what I'm going to do is I'm going to replace my endpoint where I create a user. So right over here, I'm going to replace this. So instead of actually saving it to the array, we're going to just fix this to actually save it to the database. Okay? And then I'm going to show you how we can actually use our database to perform the authentication validation instead of using the array. So the first thing that we need to do is we need to go ahead and, of course, create our schema. So I'm going to go ahead and import schema from Mongoose like this. And then I'm going to go ahead and create a variable. I'll call this user schema equals new schema, just like that. And over here, we can define our fields. So what does our user look like? So we have a username, a display name, and a password. So let's set up the username field. And we need to specify the data type. Okay, now obviously we're using JavaScript, so there's no data types in JavaScript, or there's no explicit typings in JavaScript is what I meant to say, not data types. There's no explicit typings that we can set to this username field. So there's one thing that we can use. So let me actually do this import Mongoose. Let me actually do this instead. Let me import Mongoose and do mongoose.schema instead. And then to set the field for username, so to basically tell Mongoose what data type this is, we're going to use mongoose.schema.types. And here we can reference which data type we want to define our username as. So our username is going to be a string, so I'm going to define it as a string like this. And then we're going to set the display name, same exact thing. Oh, whoops, this should be comma, sorry about that. And then the last thing was password. Okay, let's do that, password. Okay, great. Now, additionally, let's say some of your fields might be required. So what you can do is instead of assigning this type to your field, you can actually assign an object to that field, and then you can specify type, the field type on that object, and set it to that mongoose.schema.types.string. And then you can set this field called required, like this, and set it true, like that. So I'll do the same thing for our password as well. Let me just go ahead and I'll just copy and paste this. Okay. another thing that we can do is for our username, we can mark this field as unique by simply just using this unique field and set this to true. So that way, if there is already an existing user document in the user collection that has this username, let's say Anson, and if we try to save another document to the user's collection with username set to Anson, it's going to throw an error. Okay, so that's hopefully that makes sense. Okay, so we're pretty much done with our schema. This is a pretty simple schema. So now what we need to actually do after we create this schema instance is we need to actually compile it into a model. And that's actually pretty easy. So what I can do is I can create a variable. I'll call this user. And then we just need to reference mongoose. And then we just call model. And then we need to give a name. So I'm going to call this user. And you pass in the schema. So user schema like this. Okay. And you use this model to actually perform operations for that user collection for the database. So if you want to search for a user, you would reference this user model and you would call this find one method like that. Okay, but let's go ahead and just export this model. So we're pretty much done with our schema and our model. All right, so now we can go ahead and save data to a database, save a user to a database, and we'll go ahead into our user endpoint. So I already have one set up right over here already. And you can see I'm inside my user router. Right over here. So I'm going to just reuse this endpoint. But I would encourage you, if you are not using routers, I would encourage you to do so. But if you don't have it set up, just create your own /API/user endpoint or whatever endpoint you want to create the user. I'm going to remove all of this stuff right over here. And I'm also going to just remove this validation check because I don't want to combine too much stuff, because I know some of you may have not watched the previous parts of this tutorial, and I want to make sure you at least understand the purpose of what we're trying to do instead of just adding all of these dependencies on top of it. But if you have been following along, then I encourage you to perform the validation check yourself, so that way it's better practice for you. Okay? But we're going to pretty much start as if we're doing it from scratch, so don't worry. So what we want to do is we're going to send a post request to this endpoint, and we're going to send the username, password, and the display name. Okay? So const body, we're going to destructure the request body from the request object. And since we're not doing validation right now, I'm just going to assume that the validation has happened. So that means that I'm going to assume that the request body is correct. But of course, like I said, you want to always make sure you are validating everything. Okay? But we'll assume, just for tutorial purposes, we'll assume that the request body is valid. And then what I'll do is I'll just go ahead and do this. I need to first import that. Let me remove that. I need to first import that user model. So import user. Import user from mongoose schemas user. Okay. So I just imported the user model. And then what I need to do is I need to create an instance of that user model. It's very easy. All we do is first declare a variable. I'll call this new user equals new user like this. And then this constructor, the user constructor, I can pass in the object, the body object, which contains all of the fields that we want to save to the database for the user. So once I do that, I need to then actually save that user to the database. So what I'll do is I will do this declare variable called saved user. Now to save the user to the database, we just simply call the save method on this new user variable because that's the user instance. But this method is asynchronous, so we need to make sure we are using await behind this new user.save call. But of course, to do that, we need to add the async keyword in front of our callback function. Okay, and then let's also make sure we are handling errors accordingly. So what I'll do is this. I'm going to go ahead and since this function can likely throw an error, I'm going to wrap it inside the try catch like this. Because this is just creating the instance, it's not going to throw an error. I don't think the constructor will actually error out. It's only when you try to save, then MongoDB could fail to save the user, maybe because the username that we're trying to save for that new user already exists in the entire user collection. So it could error out. So first, if there are no errors at all and we're good, then I'll just return a response. So let's set the status code to be 201. Whoops, it's response.status 201, and then send back the new user like this. And if an error does happen, I'll just log the error, and I'll just send back a status code of 400, which just means bad request. Oh, whoops, should be return. Misspelled that. Okay, let's test this out. Let's go into Thunder Client. Let's make a post request to our user's endpoint. Okay. And let's pass in the username, Anson, password. Let's do hello123, and then display name. Click send. Is our server up? Oh, well, I forgot to name this user.mjs, not user.js. So let me rename that. And I guess I will click yes to update the import. So inside my routes file, yep. Yeah, so the problem was that I needed to actually add user.mjs here as well. Okay. All right, so now our server should be up and running. Click send. Okay, and now you can see the data was saved to the database. Let's go into MongoDB Compass. Let's refresh. See how the Express tutorial database appears over here, and we have our users collection. And I can now see my user in the users collection. So that's wonderful. And watch what happens if I try to click send again. It's going to say bad request, and the reason why is because you can see over here it complains about a duplicate key error, and that's because I marked the username as a unique field. Okay, so if we try to save that same username to the database, again, it's going to throw an error. So hopefully that makes sense. Now, additionally, what I'm going to do, and this is really just for the people who are, in fact, wanting to validate their schemas, I will add the schema check right now. So what I'll do is right before we call this request handler function, I'm going to call that check schema function, and I'm going to pass in the create user validation schema. And like I said, all the code is going to be in the description. So if you do want to do some of the things that you may have missed from earlier, just go to the GitHub link and grab the code, and you can see everything from there. But I'm just using this validation schema, and I have this password that I didn't have this before, but I just added this just now. So I have this password field right over here. And then I am making sure that password is not empty. And you can see that I'm making sure that the username has all these validators that are applied to that username field. Same thing for the display name. Okay. So by calling this, this will make sure it checks the request body and performs the necessary validation on it. This middleware does not actually throw an error. We need to go inside the request handler and actually check if there are any errors. So the way we do that is we just simply declare a variable called result, and we call this validation result function. I think that is imported. Yep, it's imported right up top over here from Express Validator. And we pass in the request object into validation result. And what this will do is it will actually grab that this dynamic property that was attached to the request object that Express Validator does for us, and it'll give us the information about what the status is of the request body. It'll tell us if there are any errors. It'll tell us if everything is good, if there are no errors. So what we can do is I can just simply say if result dot, let's see, is empty. So this just basically means if there are no errors, then we can proceed. But I'll make sure I do this if there are errors. So if the result is not empty, that means there are errors. I'll return a response, and I'll just simply do this return response dot send, and I'm going to go ahead and send results dot array, and this actually gives me all the errors. So it'll tell us, okay, what fields are missing or what fields are invalid. Okay, so just very quickly, I'll show you how this works. So notice how if I omit display name, it's going to complain about display name not being there. If I omit password, it's going to complain about the password. And if I omit username, username will not, it'll complain about the username over here. So hopefully that makes sense with how this works. So now, of course, if there are no errors at all, then we can proceed with the rest of our logic. But ideally, though, you don't want to use the actual request body object from the request object itself, like we're doing over here. You want to actually use this function. So let me first declare a variable. I'll call this data equals, and then we're going to call this matched data function, which is imported up top over here from Express Validator. And then I'm going to pass in the request object. And so what this match data function will do is it'll grab all the validated fields for you. So it'll grab username, password, and display name for us. Okay, so let me remove this and let me replace this with data instead. And I'll also just console log data as well. And let's try this again. So this time, let's make a post request. For the username, I'll do Anson1. And that was created. And if you look at the console, you can see that that object is being logged right over there. And of course, if we did omit any data at all, then it would just return that response right over here. Let me set the status to 400. Okay, there we go. Perfect. So like I said, just wanted to show you how to perform validation if that was something that you also additionally want to do. But I also wanted to show you a very easy way just to save records to the database. Okay, and everything is going to be similar to how we just did this. Okay, so we have one user schema. If you wanted to save products to your database, because we have an endpoint for products, then you would have to make sure you create a product schema, compile that schema into a model by using this model function right over here, or this model method on the Mongoose import. And then now you can just easily create products in your database. That's literally all you have to do. All right, so now in the previous parts of the tutorial where we covered authentication with Passport, I was actually using users that were in an array. And what I want to do is I want to go back to the authentication part, and I want to show you how we can replace all this stuff with using the actual database itself. Because I know many of you want to actually see an example of how to do that. And that's what I'm going to do. And then after we finish this, I'm going to show you how we can encrypt or hash out our passwords, because you obviously never want to save raw passwords, raw text passwords like this in your database. Because if someone hacks into your database, they can see everything. They can see the username, the password, and that's not good. You want to actually hash it. So I'll show you that after we just replace all this stuff over here. Okay, so first let's go ahead and do this. I'm going to go ahead and go into my verify function right here. So this is where we are searching for the user in a database, and then we're going to compare the passwords, okay? So I'm going to pretty much just remove this mock users.find, and let me just remove all this. Okay, remove all this. So we need to first import the user model from our user.mjs file inside the schemas folder. And then we need to search for the user. So I will show you how to do that. So const find user equals. So first we need to make sure we reference the user model, and we're going to call this find one method. And this is where we need to actually specify a filter. So you're going to pass in an object, and you're going to specify what you want to search the user by. So in this case, we're searching the user by the username. So I'm going to set username like this. Okay, since the username argument is the same as the username field, I don't have to do this like username colon username. I can just do username like that. Now this find one method is asynchronous, so we do need to make sure that we await this call. And then we also need to make sure we add the async keyword in front of our verify function. Okay, and of course, if there are any errors at all, it will just be thrown by, let's say, the find one method, and then we're catching it, so that will be handled accordingly. So that's already set up just fine. So now let's first check to see if find user is actually defined, because this find one method could return null, which means that the user was not found. So if there's no find user, then I'll throw a new error, And I'll just say user not found. And then the error will be caught right down over here in this catch block, which we'll call the done function with the error instance. Now the user is found, and we can verify that the user is defined. So now we want to check to see if the passwords are valid. So if find user.password, so I can reference the property directly on this instance that I just searched for. If it's not equal to password, then we're going to throw an error as well. And we'll just say bad credentials. Literally the same exact thing, only difference is that we are replacing the array with referencing the actual user model and calling the find one method. Okay, same exact thing. Let me just remove these two console logs. And we need to go into our deserialize user method. And then we need to make sure we remove this mock user.find. And instead, let me remove all this. Instead, we're going to go ahead and call user.find1. But this time, we're going to actually search by the ID. But the nice thing is, though, there's actually this method called find by ID. And I think this should return just one user record. Let me just double check. Yep, finds a single document, so it doesn't return an array. Just wanted to double check. So this is good because, remember, our MongoDB database, it auto-generates these object IDs right over here. So we can use that to search in a database. Okay, so I'll just pass in ID like that. And let's just make sure we add the async keyword in front of our callback function for deserialize user. And the rest of the logic stays the same. If the user is not found, throw an error. If the user is found, then it's going to ignore this part, and then we're going to call the done function. Okay, and I think that should be it. Let me just make sure that everything else is good. We can ignore the other parts of our application that are still using the mock users. That's fine. Okay, so let's test out our login and logout feature using the actual database to search for the user and see what happens. So we have two users. We have Anson, and we have our password set to hello123 for that. So let's go into, let me see. Okay, let's go into Postman. So I'm going to pass in Anson, and then I'm going to pass in the password hello123. Oh, whoops, I made the post request to the wrong endpoint. Okay, so it's still processing. I wonder what's going on. Let's see. Let me restart my server. Let's try again. Okay, so for some reason it's still processing. I think I may have forgotten something. Let's see. Find by ID. Oh yeah, that's right. I forgot to call the done function down here. Silly me. So let's just pass in null for the error and pass in the user. My apologies. Click send. Okay, so we are logged in. Let's verify that we're logged in by making a call to the status endpoint. So we're making a GET request. So I am logged in, and you can see now my actual ID that's in the database is right there. Okay, and I have my username, my display name, my password, all that stuff that's from the database. Okay, so we are able to log in using records that are in the database. So hopefully that makes sense. Okay, so now I'm going to show you how to hash passwords for your users when you're creating them before you actually save it to the database. Because right now, if you were to look right over here in the database, you can see all the users and their passwords, and that's obviously not good. And that's obviously a huge red flag for any application that saves the passwords raw like this. Because if a hacker gets access to your database, they can literally see all your users and all of their passwords, and that's not good. So you want to make sure you always hash your passwords before you save it to the database. And then once we hash the passwords, I'll show you how, when we log in, how we can actually compare the hash passwords. So that way we can validate that the user is actually passing in the correct password. So first, let's go ahead and install bcrypt. So let me go into my terminal, npm I. So I'm going to type npm I bcrypt like this. And once we're done, let's just rerun our server again. And now what I'm going to do is let's go into our utils folder. I'll create a new file called helpers.js because I want to keep this logic separate from the rest of our code base. So inside here, I'm going to go ahead and import bcrypt from bcrypt like this. And what I want to do is I simply just want to create a function that will take care of hashing the password. So I'll create a function and I'll export it. I'll call this function hash password. And this function is going to take in the actual password itself. So password. And the way that we actually begin hashing the password in bcrypt is very simple. The first thing that we need is obviously the plain text password. And then the other thing that we need is what is called a salt round. Okay. And basically the salt round just pretty much means, how much time is needed to calculate the hash for bcrypt. So of course, the more rounds you want, it's going to increase complexity. The documentation recommends 10. So I'll create a variable. I'll call this salt rounds equals 10 like that. And then what we can do is we first want to actually generate a salt. So this is the rounds, but we want to still generate the salt. So I'm going to go ahead and call bcrypt. And then I'm going to go ahead and call this gen salt method like this. And then you can just simply pass in the rounds. So salt rounds like that. And then this is asynchronous, but there's also a gen salt sync function that is synchronous. So if you don't want to use async await, then you could just use this function. So it really doesn't matter all that much because we're going to be doing everything in order anyways. So first we want to generate the salt. So let me store this in a variable. So bcrypt.gen salt sync and then pass in salt rounds. Next, what you're going to do is you're going to go ahead and call bcrypt and then you're going to call hash. So again, this is asynchronous as well. So this will return a promise with the data, in this case, our password hashed. Now, there's also hash sync, which is the same function. It just does it synchronously. So it doesn't return a promise, but it will call this function and then it will return a string. So I'll just use hash sync since I'm using gen salt sync as well. So you call this function and you pass in the text password that you want to hash, and then you want to pass in the salt. Okay. So I'll just pass in this salt right over here, just like that. And then I'm done. And then I can just return this. So whenever I call hash password, this will hash the password for me. So let me actually console log salt as well, because I want to actually show you what this value looks like. So now what we want to do is before we actually create our user, we want to make sure we hash the password. So I'm going to go into my users.mjs file in the routes folder. So I'm going to go back to my users endpoint where I'm creating an actual user. So this one right over here. And you can see right over here on line 61, I'm creating a new instance of my user, and then I'm saving it right inside this try catch or inside this try block. So before I actually pass the data into the user constructor, what I want to do is I want to reference data.password, because remember this data is the request body that is being sent to this endpoint, and we expect there to be a password field. And since we are doing validation after this point, the password field will be there. So I want to basically reassign a new value or assign a new value to the password field to the data object itself. Okay. So when I pass the data object to the constructor of user, it will contain the hashed password, not the raw password. So what I'm going to do is I'm going to call hash password, and that's going to be imported up top over here from our helpers file that we just created from the utils folder. Where am I? Okay, right over here. Now remember, the hash password function is synchronous because we're not using any async await in here, and we're not returning any promises. We're just returning the string. So we don't need to use async await. But if you did use the asynchronous methods like gensalt and then hash, then of course you would need to first await this, and then you would need to add async like that, and then you would need to add async in front of this hash password call. So I just wanted to mention that for those of you who choose to use the asynchronous versions of the functions. So I'm going to call hash password, and I'll pass in data.password. So this will take the raw password, hash it, and then store it back to the password field for data. So I'll console log, I'm already console logging data up here, but I'll console log it after we assign the new value for password. So let's go ahead and see how this all works. So let's go into Thunder Client. Let's make a post request to API/users. And we need to send a username, password, and display name. Let's change it. Let's do John. And username will be John because we already have Anson as username already in the database. Gonna click send. Is our server up and running? Whoops, I forgot one more thing. I forgot to name helpers.js to MJS. Let me rename that. And then inside the users.mjs file, we need to make sure we are adding that .mjs extension. That was the main problem over there. I keep forgetting. So I apologize for that, but let's test this out again. So our server's up and running. If I go back to Thunder Client, click send. Let's see, password. Oh, username must be at least 5 characters. Let's do Johnny. Okay, click send. Okay, and now you can see that the password is hashed. Let's go into my database, and I can see Johnny is saved in the database, and it has the hash password. Okay, wonderful. We now know how to hash passwords and save it to the database. Now, the next problem that we have, since we have authentication, is we need to be able to actually compare the hashed password with a value that we're sending to the server. Because right now, let's say if I try to log in as Johnny, let's do this. With our current logic right now, if I try to log in as Johnny, and I provide my password like this, it's going to throw an error. It's going to say bad credentials. Okay, that's because we're trying to compare this password, hello123, with the hashed text. And obviously, hello123 is not equal to this entire thing. So here's what we need to do. We need to go back into our strategy file. Right over here, inside our verify function, okay, right over here, what we need to do right before we compare the password, instead of just comparing the raw password that is sent from the client side with the hashed password now, we need to actually hash that password that was sent from the client. So what I'm saying is, when I send hello123 as a password to the server, I need to hash hello123, and then we're going to compare that hash to the hashed value that's in the database. Hopefully that makes sense. Okay. And actually there's a built-in function that we can use to compare hash passwords, and I'll show you what that field is. So let me go back into helpers.mjs. So there's this function called bcrypt.compare or compare sync. I'll use compare sync. And what you do is you pass in the plain text password, and then you pass in the encrypted, which is the hashed password. So this will be the actual hashed password that is saved to the user in the database. So first, let me just actually create a helper function. So I'll do compare password equals password. Let me do this plain hashed like this. Okay, and then this bcrypt.compareSync function will return a boolean. So I'll just return that boolean. So let me pass in plain. And then the second argument for compare sync will be encrypted, which is just going to be the hashed password. And so this will return a boolean value. So if these two values are equal to each other, then it will return true. If it's not, then it will return false. So we don't actually need to rehash anything because this compare sync function will take care of it for us. Okay. So let's go over to here. And then all I need to do is just simply, instead of doing this check like this, I can just call it compare sync, or I'm sorry, not compare sync, compare password. and then just pass in the plain password. So that's password right over here. So this is the value sent from the client, the raw text password. And then we're going to pass in the hashed password. So find user.password like that. Okay. And then of course, if this returns, we want to negate the value, because if it returns true, that means the passwords do match. But if the password does not match, it would return false. So if not false, then we'll throw a new error. So let's go ahead and try and re-authenticate. And now you see we're good to go. And notice how if I try to log in as Anson, because currently Anson has the raw text password saved in the database, it should actually error out, because now we're trying to compare the plain text to a hashed value, which obviously is not going to work. So yeah, that is how you can save the hashed password instead of the text-based password to the database. And then that's how you can compare them as well. So I hope this part of hashing passwords and how you can save the hashed password to the database and compare it makes sense. So in the next section of the tutorial, we're going to go ahead and talk about session stores, something that will help us tremendously, because right now, whenever we keep on restarting our server, our sessions keep getting dropped from the memory store because it's volatile. So I'll show you how we can actually use session stores to save the session data to the database. So that way, when we drop the server and then restart it, our session will be restored and you'll see that we remain logged in. Okay, so now let's go ahead and move on to session stores. So this is something that you very likely will need, especially when you want to persist session data for the user, because sometimes your server may go down for unknown reasons and they might restart. And when that happens, all of your session data will be gone, because by default, Express Session stores it in memory. So what you want to do is you want to store this in a database so that way it can be persisted whenever your server goes down. And if it goes back up, the session store will have that session data there, and Express Session will look in that session store in the database to grab the session data and restore it for the user. So earlier, I actually did show you how the in-memory session store looks like and how it stores data. I'll show you again. So inside my API/users endpoint is where I have this being logged. So what this does is it looks for the session ID, and if there are any errors, I'll just throw an error. But then we pretty much just log the session data right over here. So right now, I'm not logged into the application at all. I'm not authenticated, so I don't have a cookie or anything. But if I make a request to API/users, and if I show the logs, you can see that right over here, inside session store get, that's where I'm logging this right over here. You can see that the session data is undefined. Okay, that's fine. Let me go ahead and log in first, because we haven't actually modified the session data at all. We haven't actually logged in yet. So let me go ahead and log in. So let's do this. API/auth. I'm gonna log in. Oh, whoops, did I forget? Yep, sorry about that. Bad credentials. Oh, wait, you know what it is? It's because I'm still comparing the raw text password in the database. Let me use Johnny instead. And then the password is, I think it was hello123 as well. Okay, so I just successfully logged in. Let's verify. Let's go to the status endpoint, and you can see that I'm logged in. Obviously, you don't want to return the password, but that's something for a separate part of this tutorial. But now, watch this. When I go to /API/users, you can see that in the console, so we're inside session store get, so we're logging it right over here. And then you can see that this is the session data, and you see how the session data, I have the cookie, and then I have the passport, and then I have the user. Okay, so every single time we make a request to the server, Express Session will take care of looking for the session data in the in-memory store, and then it will know who the user is. Okay, and then right over here, we have the user ID inside Passport. Okay, and then Passport will take care of calling deserialized user with the ID, and then it will search for the user in the database, and then that's how it will grab that user from the database and attach it to the request object. Okay, so if the server goes down, so let's say right now, if I restart the server, and if I try to visit, let's say if I visit the previous endpoint, let's do auth/status, You see how it says unauthorized? So we're not even logged in anymore. Okay, all of our session data is gone. If I were to go back to /API/users, you can see that now the session store does not have our data. It says undefined. So obviously that's a problem. So what we can do is we can use a session store to save the session data. And it's actually not that difficult to use, because all we really need to do is just have a database connection, which we already do already. So in earlier parts of the tutorial, I showed you how to connect to a MongoDB database using Mongoose. So that's this right over here. And then what we can do is we can reuse that Mongo connection to connect our session store to that database. So we're going to use this package called Connect Mongo, and pretty much this is just a MongoDB session store for Express. Now, let's say, for example, if you're using some other database, there are a bunch of different session stores right over here. So this is the Express session documentation. If you just scroll all the way down and you scroll down to compatible session stores, you can see that, let's see, there is one for Couchbase DB, there's one for Memcached, Mongo, yep, Connect Mongo right over here. There's one for SQL. Oh, this is the Microsoft SQL Server, Neo4j, Redis, Firebase. There are a bunch. Okay, so you just have to look in this list and find the one that you want to use. We're just going to use Connect Mongo for now. So let's just first install Connect Mongo. So inside my terminal, I'll type npm I connect Mongo. And of course, you must make sure you have already a database connection. So in this case, since we're using Mongoose, I can actually just reuse this database connection. So now that we've installed Connect Mongo, we can import that into our index file. So I'll import Mongo store from Connect Mongo just like that. And then we need to go down into our session middleware, and we need to set this store property. So where you're pretty much calling this session function. And then you want to reference Mongo store.create. And since we are using Mongoose, we can actually reuse that connection. So there's this property called client in the Connect Mongo options, like this. And then you can reference Mongoose, which we have imported up top over here. And then you can reference connection, and then you can call this getClient method just like that. Okay, and this says returns the MongoDB driver Mongo client instance that this connection uses to talk to MongoDB. Okay, so let's go ahead and start up the server again, and let's just make sure everything is good. Okay, so we're connected to the database, and let's actually try to authenticate now, because that's what actually modifies the session. So let's go ahead and make an API request to API/auth. Let's send the username, Johnny, and then password, hello123. So we are logged in successfully, no errors in the console. Okay, that's good. Now let's go into our database and let's see what happens. Okay, so I'm going to refresh, and you notice how now there is this sessions collection. Okay, notice how now there's this sessions collection. Let me expand this real quick. And you can kind of see how we have, let me see if I can kind of do this so you can see it better. Okay, so you see how we have this sessions collection right over here. So now we're actually storing the session data in MongoDB in our database. So then what happens is now I'm logged in. Okay, I just logged in. I'm going to make a GET request to the auth/status endpoint to verify that I am logged in, which I am. Okay, so we're good. Now watch this. The problem that I mentioned earlier was that if I were to close the server, so I'm going to exit the server, and if I restart it, it would log us out because all of the session data was saved in memory. But because now that we actually have a session store that is a database, it will use the database to restore the session data. So watch this. Okay, so I have my session data stored in the database, and notice how if I make a GET request to the auth/status endpoint, notice how I am still logged in. Okay, if I remove this store completely, it's going to use the memory store by default. Okay, And let's go ahead and restart the server. Click send. Notice how now I am unauthorized because my session data is not found in memory because it's using the in-memory store by default. So I really hope this makes sense, and I hope this showcases how important a session store is, because now instead of having your session data stored in memory, it stores it in a database, which is great for persistence. Okay, so you can restart your server how many times as you want. The session data will always be restored. So notice how now, if I just call this endpoint again, after just uncommenting out this part, the store options, now we see our data. So what happens underneath the hood is by configuring that session store, it will basically look inside the sessions document or inside the sessions collection, and it'll search for this session ID right over here. So if you look right over here, WRGK, if I kind of show you the cookies right over here, let me see if I can find it. You see how this is my session ID right over here, and I can even log it too. I think I may be logging it already. Nope. Let me log it right over. Let's see. Let me go back to the status endpoint, and let me just log request the session ID. Okay, and if I make a request again, you're going to see that that's our session ID right there. And notice how that session ID is this same ID that's in our document right over here. So what happens underneath the hood is when we send the request to the server, remember we're sending the cookie back to the server, right? Our cookie is right over here. So that gets parsed from the server. And then what happens is instead of looking for the session data in the memory store, it'll look in our MongoDB database, which is persistent. And that's how it will take care of looking for the session data. So sorry about clicking all this stuff. Let me click over here and show you the MongoDB Compass client. So it'll look for the ID, okay, and then it looks for the session property, and it will basically take this whole stringified object, parse it into JSON, and then attach this object to that request.session object, which is what you see right over here. Okay, and notice how we have the passport data right over here. That's right over here. And notice how this is right over here as well, the user ID. So everything is in the database now, which is great. So now since we're on the topic of session stores, I want to revisit these two properties, save uninitialized and resave, for the session configuration, because I mentioned this and I told you all not to worry about it so much until we got to session stores. So right now we have this set to false. Okay, so what this means is only when you modify that session data object, then it will actually save this to the session store. Okay, so in our case right now, when we authenticate using Passport, Passport will modify the session data object for us, which means that it will also save it to the session store, which is actually what you see happening right over here. Okay, so when you set save uninitialized to true, it's going to save every single session object to your session store, even if you didn't modify the session at all. So I'll show you an example, okay? So right now what I'll do, let me just delete this session from the database. So that means I'm no longer authenticated. You can see right now if I try to make a GET request, it's going to say I'm unauthorized, okay? Because I don't have that session data stored on the server side now. But what I'm going to do is I'm going to go ahead and set save uninitialized to true. And I'll just visit any random endpoint. So I can visit, let's see, I'll visit /API/auth/status. And let me also clear my cookies as well before I do this, just so that we are at a clean state. So I'm going to make a request to API/auth/status. Okay. And notice how it gives us back a cookie. And notice how now in the session store, you see how it's saving this session data to the database, to the session store, even though we never modified the session data at all. And you can tell because, let me show you the logs. Okay, you can see that we have the session data and we have this cookie. So it's going to send us that cookie back, but we don't have anything related to the user at all. So if I try to revisit this endpoint again, if I refresh, I'm still going to use this. But notice how if I clear the cookies now, if I send a request again, it's going to create another session data in the database. And then I can go ahead and just clear the cookie again. And it's going to create one again. So even though I'm not doing anything but just trying to visit an endpoint, it creates a session record for us. Okay, and this really depends on how you want to implement your application. Sometimes this might be useful, but you can start to see that this is not necessarily a good thing because it's just going to save a bunch of unmodified session data to your database, and that could use up a lot of storage. So it's better to only save the session data when it's been modified. So in cases where the user logs in, Passport will actually modify that session data, and then it will save the session data to the database. So let's take a look at the resave option now. So currently it's set to false. So I'm going to set it to true. And currently I have dropped all of my sessions in the database. But what I'll do is I'll make a request, a GET request to this status endpoint. Okay, that's fine. We do get back a cookie though, which is fine as well. If I refresh, I can see that my session data is over here. So what resave really does is it pretty much just forces this cookie to be resaved every single time. So you notice how right now, let's pay attention to this date right over here, this date string. Okay, notice how every time I make a request, it's going to go ahead and update this time right over here. Okay, so if I keep refreshing, it's basically just going to keep updating that expiration date. Okay, so it resaves it every single time. If I set it back to false, and let's go ahead and let me just refresh real quick. So pay attention to this time. So 14:43:39. So you'll notice how if I click send again, and if I refresh, notice how the date does not actually get modified because we're not forcing that cookie to be updated, to be resaved every single time, even though there's no changes happening at all. Now, if I actually try to log in, so watch this, I'm going to go ahead and try to log in now. So I am logged in, and I think I am using the same cookie as well. Let's see, maybe not. Let me refresh. Oh, okay, so here's what happened, okay? So it actually replaced that session ID that we previously had with this one. So notice how when I refreshed, we now have this session ID. And you'll notice that now everything got updated and it modified the session. So typically, when you do modify the session, it will actually update the cookie as well, which is what you see over here. You can see that I don't have the same cookie anymore as before. Okay. Let me see. Yep, that's fine. So yeah, hopefully the resave part makes sense. Now, typically, ideally, you would want this set to false, and you would also want save uninitialized set to false as well. But it also could depend on when it's useful. Like, for example, if you have it set to true, that could mean that someone just visited your website. They're performing some kind of operations. Maybe they're adding products to a cart. But then once they log in, you want to persist that session data as well. So that way it's not gone. So once they log in, they have their cart all set up already, even though they did that when they were a guest on the application. So hopefully that makes sense. Alright, so in this part of the Express.js tutorial, I'm going to show you how to set up OAuth 2 using Passport.js. So this will allow you to use third-party providers such as Discord or Facebook to log into your application rather than logging in using just local username and password. So I will be using Discord as my third-party provider to allow myself to log into my application using Discord. But as long as you understand what I am doing throughout this tutorial, and I will be explaining everything that is going on, you should have no problem following along using whatever third-party provider you want. So even though I'm using Discord, you can use literally any other provider such as GitHub or Facebook. The only difference is that you just need to make sure you figure out where to create the actual OAuth application. And you can easily find that out by just going to the developer documentation. They typically provide links where you can read up on how to create an actual OAuth app. But like I said, as long as you understand what is going on with setting up our Discord OAuth application and grabbing the required values, then everything should be fine and you should be able to integrate this with any third-party provider. So the first thing that I am going to do is go to my third-party provider's website, so discord.com. And I'm going to go ahead and scroll down to the developer documentation section. So if you're using Twitter, for example, you would go to twitter.com and search for the developer section. Okay, I'm going to click on Get Started Now. And so now I want to look for the section where it says Applications. So right over here, Applications. You want to make sure you create a new application. So I'm going to go ahead and call this, let's do OAuth to Discord. Oh, whoops, OAuth. I guess let's do Anson OAuth 2. So I've just created my application, and whatever provider you're using will prompt you to do the same. So now what I'll do is I'm going to go to the OAuth 2 section, and there's a couple of fields that we need to get. We need the client ID, and then we also need the client secret. And let me just enter my 2FA code real quick and get back to you all. All right, so I was just able to get my client secret. You want to make sure that you keep this client secret private. You do not want anyone to know what this secret is. So I'm going to copy that, and just for now, I'm going to just paste this right over here. Now, just for tutorial purposes, it's okay that you are seeing this client secret because I'm going to reset it anyways. And let me just go ahead and copy the client ID. Now, this client ID is not something that you need to worry about. Anyone can have it. It doesn't really do anything other than just identify the actual application's ID. So it's okay if someone else sees the client ID. Now, the other thing that we need is we need to add a redirect. So this redirect is important because the way that the flow is going to work is we need to make a request to an endpoint that's going to take care of redirecting us to the third-party provider we're trying to authenticate with. In our case, we need to set up an endpoint later on that will take care of calling Passport to redirect us to the Discord platform. And then once the Discord platform shows up that authorization page and it shows us all the different permissions and the scopes that we want to allow, we click authorize, and then Discord needs to redirect us to this redirect URL. So hopefully that makes sense. So that's why we need this redirect URL, because we need to tell Discord, hey, once we're done authorizing, send us back to this URL. So I'm going to go ahead and just pass in localhost port 3000 because that's what my server's running on, /API/auth. Let's do Discord and then redirect. Now keep in mind this endpoint has not been implemented yet, but we will implement it later on. Now you can add another redirect URL if you want. This is useful if you want to use the same app in different environments, such as, let's say, right now we're currently in development mode, but let's say you want to use this for production as well. Then you can add your production URL, which is your domain name, and then same endpoint. I'm going to go ahead and just click Save Changes. And let me also copy this redirect URL because we will need this as well. So we just finished setting up the OAuth 2 app for Discord. So the next thing that we can do is install our strategy package. So since I'm using Discord, I want to make sure that I install the correct strategy module for my project. So remember that there are plenty of strategies to choose from, depending on which third-party provider you want to use. So if you're using Facebook, there's a Passport Facebook library that you can install. If you want to use Twitter, there's Passport Twitter. There's a bunch. You just have to go on this website, passport.js.org, and just search for these strategies. So obviously I'm using Discord, so I'm going to install Passport Discord. So I'm going to go into my Windows PowerShell, and I'll type npm i passport-discord. Now make sure that if you don't have Passport, the base Passport package, you install Passport because you need Passport itself as well. I already have it already because I did a tutorial earlier with this Passport itself with the local strategy, so I'm not going to reinstall it. Well, I'm going to go ahead and hit enter and install Passport Discord. Okay, we're good to go with that. Now let me just run my server again. Okay, there we go. So now what we're going to do is this. So in earlier parts of the tutorial, I did set up Passport with a local strategy. However, I don't want to make this tutorial super complex. So what I'm going to do is just temporarily, I'm going to kind of like disable the local strategy because we really don't want to have these two conflict with each other. And that's kind of like something that is for a different video to solve. And I don't want to make this whole section super complicated. I'm just going to go ahead and comment out the local strategy file import up top here. And I'm going to leave the rest of these routes alone for now. Now, so what I mentioned earlier is if you didn't see the part where we set a passport, you need to make sure you first import Passport like this from the Passport package. And then right down over here, you want to make sure you initialize Passport by calling app.use and then passing in passport.initialize like this. And then you also want to configure Passport to work with Express session. So we just call app.use and pass in passport.session. And that's literally all you need to do. The rest of the things that we'll do for our Discord strategy will be pretty straightforward and doesn't depend on anything else. Okay, so now that we got that out of the way, let's go ahead and create our Discord strategy, much similar to how we created our local strategy. So I'm going to go ahead and create a new file, and I'll call this discord-strategy.mjs. And I'm going to import inside this file Passport from Passport, and I'm going to import this strategy class, and this strategy class actually comes from Passport Discord. Now, of course, if you're using a different Passport strategy, all of the Passport strategies have this strategy class. So if you're using Passport Facebook, you can still import this strategy class. It's going to be in every single strategy module. It's standard. So now what we need to do, we need to go ahead and call passport.use and pass in an instance of this strategy class like this. And now we need to pass in options for strategy, and we also need to pass in the verify function. So I'll handle the strategy options first. So since we are using OAuth 2, we need to make sure we configure the OAuth 2 to have it point to our Discord application that we just created. So remember how earlier I grabbed the client secret, the client ID, and the redirect URL? Well, all of that is going to be passed into this object right over here for the strategy options. So first we'll set up the client ID. So you can see there's this property that I can assign a value. And I'm going to go ahead and assign it the value of my client ID. And of course, like I said, if you're using Facebook or Twitter or whatever, the OAuth app that you create on those platforms will have a client ID. It's standard across any platform that implements OAuth 2. Okay? And then it'll also have the client secret. So I'm going to grab my client secret and paste it over here. Keep in mind that just for tutorial purposes, I am hard coding all of this. Ideally, you would want to place these values in an environment variable, so I'll recommend doing that, but just for tutorial purposes, it's okay. I'm going to go ahead and now copy the redirect URL because we will need that, and the field name is actually callback URL. So when I say callback URL or redirect URL, I use those terms synonymously, okay? So we're going to paste that URL. This is the callback URL that Discord or whatever provider will make a request to upon success, upon authorization success. Now, there's one more field that we need to configure, and that's the scope field. And this is important because we need to actually state what permissions that we want to have, what fields, what type of information that we want to access, and that's defined all in the scope. So by default, if you don't leave the scope at all, then you won't have really any access at all to the user's information. But if you wanted the user's, let's say, username or their Discord ID, then you would need to use this identify scope. Now, the scopes are defined differently on each platform. So for example, Discord has this identify scope. Let me see if I can kind of show you all through the documentation. Let me see right over here. Okay, you see how over here at OAuth 2 scopes, and you can see that we have this identity scope, and it tells you that what it allows you to access is it allows you to make a request to this. Let me zoom in a little bit. It allows you to access this users at me endpoint. So if I click on that, it pretty much gives you the user itself, okay, the user that authenticated. So we need the identify scope to get at least the basic stuff like the username, the ID of the user, stuff like that. Now, it also does mention that it does not give you the email. So in order to grab the email, you need to use the email scope. So notice how over here, there is this, let me scroll up here. There's an email scope, and it tells you right over here in the description, it enables the same endpoint at users at me to return an email. So if you want an email, then you would provide that in the scope over here. If you wanted to grab all the users' servers, all their guilds that they are in, then you can use the guild scope. Okay, so I'll just do identify, and I'll do guilds for now. So we're done with our configuration for the strategy options. This verify function is responsible for performing validation on the user that's trying to authenticate. Now, since we're using OAuth 2 and there's no need to worry about a password because they're using a third-party platform, they're not going to be logging in with a password. What you would need to do is actually check to see if the user exists in the database, and if they don't you can save that record to the database. Okay, so the reason why you would want to save a third-party user account to your database is sometimes you might have certain types of data that you want to relate to that user. So sometimes you might have like a one-to-one or one-to-many relationship that you need to associate with the user on your platform. So it's definitely a good idea to save that user to a database, so that way the next time they log in, they can see all of their relations with other types of data. For example, the user can see all of their posts, all of their messages, all of their current activity, things like that. Okay, so it's always a good idea to save the user. Now, this verify function takes in 4 arguments. The first 2 arguments are both tokens, so access token and refresh token. The third argument is the profile. So the profile itself is going to be pretty much the user object, and it's going to also have the email if you have the email scope enabled, and it's also going to have all the guilds, the servers that the user's in. So that's what the profile is. And like I said, if you're using Google or Twitter, then the profile would contain Google details of the user. Same thing with Twitter. And that would contain stuff like the username, email address, ID, stuff like that. And the last argument is the done function, which we're going to go ahead and call when we're done performing the logic that we need. So that way Passport can then move on and then take care of the serialization part, which I will explain how that works. So the access token and the refresh token, these are just tokens that you're going to be using primarily for making requests to the API on behalf of the user. So the access token is what you would actually use to make API calls. So for example, for Discord, in order for you to actually even call these endpoints, such as users at me, users / at me / guilds, you need an authentication token. So that's kind of like some type of, think of it like an API key, but it's not an API key, it's an access token, and you use that access token to be able to access the data that you want to retrieve on behalf of the authenticated user. So, for example, if let's say you wanted to fetch, I don't know, all of the guilds, then you would need that access token. In our case, Passport actually takes care of that for us, the Passport Discord strategy, so we wouldn't need to manually do it ourselves, but if there comes a time where you do need to do it, you need that access token. The refresh token is just used for literally refreshing the access token. So your access token is actually short-lived. Usually it lasts for about, I don't remember the exact time, but it is a lot shorter than the refresh token. And the refresh token is usually it lasts a lot longer. I think usually about 6 months. It really depends. But what you would do is you would store these tokens in your database somewhere, and then you would pretty much use the access token to make requests on behalf of the user. And then when it's time to get a new token, you would use the refresh token to kind of like refresh the access token. So that way you would not need to require the user to relog in. You just use the refresh token to get a new access token, and then that new access token can be used to retrieve data from the API on behalf of the user. So hopefully that makes sense. We're not going to be using these 2 tokens though, but I just wanted to mention it just so that if you're using whatever third-party provider you are, and then you need to actually make API calls, then you know what value you need to be using, which is primarily the access token. I'm just going to go ahead right now and console log the profile object because I want you to see what this looks like after we actually get redirected to Discord and click authorize. But let's go ahead and actually export our passport.use call like this, export default. And I'm going to go ahead into my index.mjs file, and I'm going to go ahead and import that strategy like this. So import strategies, Discord strategy.mjs. Okay, so that will load up the strategy into our entire application. And now we need to set up an endpoint that the user is going to be visiting in order for them to actually get redirected to the Discord platform so they can authorize themselves with our application using Discord. So ignore all of this stuff right now. Don't worry about any of this. We're just going to go down over here, and I'm going to set up a simple app.getRequest. And then we're going to name this endpoint API/auth/Discord. And then we need to pass in that Passport.authenticate call. And then we need to specify the strategy name, which in this case we're using Discord. So I'm going to pass in Discord like that. Okay. Now, let me show you what's going to happen once I go to this endpoint. So let me go to my browser, move this over here. Okay. So let me go to /API/auth/Discord. Notice how now when I visit that URL, it redirects us to the Discord platform. And we can see right over here, it tells us, okay, this is the external application, wants to access your Discord account, and this is what the application wants to access. And again, all of this is based on the scope. So if I go into my strategy, you can see that I currently have identify and guilds. And it says, okay, identify relates to the username, avatar, and banner. And guilds is know what servers you're in. If I were to add email, and let's kind of like go back here. I guess I have to revisit the actual endpoint. Notice how now it says access your email address. Okay, so hopefully that makes sense. For now, I'll just do identify, which will just give me the basics. But like I said, if you wanted to get the guilds or email address, just add those in the scope and then you'll be good. So let me go back and let's go ahead and make a call to that endpoint. And now it only asks for the username, avatar, and banner. And then we'll click on authorize. And now we get this cannot get. And notice how the endpoint is our redirect URL. So we don't have this endpoint set up yet, so we need to set that up. So I'm going to go back to the index.mjs file, and I'll set it up right here. So it'll also be a GET request as well. So it'll be /API/auth/Discord redirect, and then you're going to call Passport.authenticate and pass in Discord strategy like this. And then you can pass in the request handler at the end. So after Passport is finished logging the user in, it's going to go ahead and call this next middleware function, which is the request handler, and then we can just send back a response of a status code of 200. Okay, now I actually forgot to show you the console real quick, so that way you can see what happened when we try to authenticate. So let me just re-authenticate again and show you what happens. Okay, so let's go to the endpoint, click authorize, and now watch this. Okay, so now you can see that when I make a request, so what happened is this. Okay, I made an API request to /API/auth/Discord. We invoked the Passport.authenticate function the first time. When that happens, it redirects us to the Discord platform. Okay, when you click on the authorize button on the Discord platform, what happens is it actually redirects you back to this redirect URL that we set up just now. And you'll notice how, I don't know if you can see this now, but before, when it tried to redirect us, there was actually this query parameter up there. Let me comment this out and show you again. Okay, so you see right over here how we have this query parameter called code. Okay, and then it has this code over here. So we actually use that code to exchange it with the Discord API to get the access token and the refresh token. Okay, that's what the code is used for. In order to actually grab the access token and refresh token, we must implement this redirect URL. So the flow works like this. It goes to the first endpoint, so /API/auth/Discord, and then we use Passport.authenticate, pass in that Discord strategy name. That'll redirect us to the third-party platform. Once we click on authorize, it's going to redirect us back to the callback URL, which is this redirect URL over here. When you do this, when you call Passport.authenticate the second time, so it's calling this Passport.authenticate middleware the second time, it's going to take that code query parameter and it's going to exchange it for an access token and a refresh token. And then what happens in the end is it goes ahead and calls verify function after it calls this Passport.authenticate function the second time. Now, the reason why I didn't return a response back was simply because we need to continue implementing the rest of this verify function. So here's what we're going to do. I'm going to go ahead and create a Discord user schema for our MongoDB database. And we're going to go ahead and save the user to our database. So I'll create a new file inside the mongoose schemas folder. And I'll call this file discord user.mjs. And I'm pretty much just going to do the same thing that I'm doing here. I'll just copy this and paste it here. And I'm just going to rename this to Discord user schema. And we're going to have, of course, we're going to have a username. We don't need display name. We don't need password. I'll also just store the Discord ID, I guess. So that'll be a string. and then we want it to be required and also unique. And then what I'll do is I'll take this Discord user schema, I'll pass it into this mongoose.model call as a second argument, and I'll change this from user to Discord user, and same thing for this model name right over here. So this is my Discord user schema, and then this is my Discord user model. And now I'm going to go ahead and inside the verify function in our Discord strategy, this is where I am going to search for the user in the database. So we want to search by a unique value that will never change. The Discord ID will never change at all. So we can use the Discord ID to search for the user safely. Because of course, if you search by the username, that could potentially change. So not a good idea, but better to search with the Discord ID. So let's go ahead and create a variable. Let's call this find user. And then we need to use async and await. So I'm going to add async in front of this callback function inside this, or in front of this verify function. And inside the verify function, I'm going to use the await keyword, and then I'm going to import the Discord user model. Let me do that real quick. I'm going to import that from Mongoose schemas Discord user, like that, .mjs. So we're going to go ahead and do await Discord user find one. And then for the filter, I'm just going to pass in the field that I want to search by. So I want to search by the Discord ID, like that. And then I need to pass in the actual Discord ID as a value. So to grab the Discord ID from the profile object, you just reference profile.id like this. That'll give you the Discord ID, or if you're using a different platform like Twitter or Google, it'll give you their respective IDs. Okay? So what we'll do is if the user is not found, we'll create it. So if no find user, we'll create the user and save it to the database. So this is a two-step process. We first need to create an instance of the new user. So const new user. And all we need to do is use the new keyword to create an instance of Discord user like this. And then you just want to pass in an object that contains the fields that you want to set for this new user that's going to be saved to the database. So we only have two fields to worry about. That's username and the Discord ID. So I'll do this. Username, profile.username, Discord ID, profile ID. So this is the first step with creating the actual user instance, and then we have to save it to the database. So I'm going to go ahead and call this variable new saved user equals await, and then new user. So reference that instance and call the save method. And the save method is asynchronous. It returns a promise, so we need to await it. And once we are done with this, we're going to go ahead and call the done function and pass in null for the error, and then pass in the new saved user. So once you call this done function, it's then going to need to call the serialize user function for Passport, which I'll show you how to do that as well, so don't worry. So I definitely want to add some error handling inside this logic, because our find one method could throw an error, and so can this .save method. And we want to make sure we're also handling these method calls and their errors separate, because if I just wrap everything inside a try catch block like this, and then I catch the error down here, it would kind of be like difficult to figure out which method call is the problem. Is it the find one or the save? So here's what I recommend is first we can declare a variable called find user like this. And then let me just remove this const find user declaration. Let me copy this whole line over here where we're calling await Discord user.find one. And I'll try catch and wrap this method called the find one method call inside the try. And then I'm going to assign the return value to find user. And if this find one method call errors out for whatever reason, then we'll catch that error down inside this catch block. And so here what I'll do is I'll return done, pass in the error, and then null for the user. However, if there is no error, then it'll just go down to here, and then I'll have another try catch. So try catch. And then right down over here, we are still checking to see if find user is undefined. So if it's not undefined, then we will go ahead and create an instance of the user. And then we're going to go ahead and call this save method, which could throw an error. And we want to make sure we're handling it. So that error will be caught inside this, will be caught by this catch block right here. And then now we have handled errors for both possible methods that could throw an error. Okay, so I wanted to just mention that real quick because it's not good to just write code that doesn't have any error handling. So let me go ahead and return done. If there is an error, we'll pass error and then null for the user. Okay, and if everything is successful, then we'll just call done right over here. So we're not done yet. We still need to handle a case where find user is defined. So that means the user already exists in the database. So that means they've already logged in at least once. First, let me just add this return keyword in front of this done function call. And then right outside over here, if find user is in fact defined, then we'll just return done and then pass a null for the error and then pass in that find user object as a second argument. So let's go ahead and try to hit the API. So let me just go into my database right now. You can see I have this Discord users collection. There's no data in here currently. When I go to this Discord endpoint, it's going to go ahead and prompt me to click authorize. Don't worry about this error. The reason why this error is out right now is because we don't have the serialized user and deserialized user methods implemented yet. But what I want to do is I want to show you in the database. If I refresh, you can see that my Discord user was created right over here in the database. And you can see I have the username and the Discord ID right over here. All right, so now let's go ahead and fix this failed to serialize user into session issue. So as I mentioned earlier already, we went over a lot of these basic stuff such as serialized user and deserialized user with the local strategy. I highly recommend you rewatch that section or watch it if you missed that part. But what I'll do is I'll copy all this stuff from the local strategy file. And don't worry, I'll explain what I'm doing and I'll explain everything that's going on. So I'm going to copy all of this and I'm going to paste this inside my Discord strategy file. So let me explain one by one what's going on. And you know what? Let me remove this deserialized user and let's just focus on serialized user first. So inside this verify function, whenever we call the done function, and assume that there's no errors. So we pass a null for the error, and then we pass in this user object. Okay, so what really happens when we call this done function is we're passing in this user object and we're telling Passport that we want to serialize this user object into the session data. Okay, remember Passport works well with express session. So this user object right over here is going to be passed into this callback function as an argument right here. So whenever we first log in, and once that done function is called in the verify function, it will call this callback function that is passed to serialize user. So whatever you pass in right over here as the second argument to the done function, while error is set to null, will be passed over to this user argument over here. Okay, so watch this. I'm going to leave the console logs alone and I'm going to re-authenticate and you're going to see what's going to happen. Okay, so let's go ahead and click authorize. Okay, now you see how the error goes away, the failed to serialize user into session error goes away. That's because we were able to successfully serialize the user into the session object because we implemented this function right over here. And all you really need to do is just call the done function that is the second argument to this callback. When you call the done function, you pass in null as the error, and then you pass in some unique ID that can be used to identify the user. So you can use either an ID or if you want to use the username, though even though that is unique, it can be changed. So you would have to just be responsible for updating the session data because the session data could go stale. But what we're doing is we are saying, okay, I want to serialize this ID of the user into the session object. Now remember, when we went over sessions, I explained how all that stuff works. So I'll show you right now what will happen if right over, let's see, right over here inside the redirect endpoint, I'm going to go inside this request handler and I will log console.log request.session, and then you'll also see that we now have this request.user object. So let me go ahead and show you what happens. Okay, so let's re-authenticate. Whoops. Okay, this is the reason why we're having this error is because we are already logged in and it's trying to deserialize the user because we already have a cookie. So what I can do is very quickly, I'll go ahead and just clear the cookie and let me refresh. Click authorize. Now I want to show you the logs. You see how now the session object, so this session object is being logged right over here inside the request handler for our redirect endpoint. So when Discord redirects us to the endpoint, it's going to go ahead and eventually call this request handler function. And you can see now the session object has that passport property, which is an object. And notice how we have this user property inside this passport object. And that is the user's ID. Okay, and then we also have the request.user object being logged. And then you can see that this is the actual user object ID. Okay, that's the object ID of the user document. We have the username, and then we have the Discord ID. This is the user object itself. So that's the responsibility of the serialize user function. It pretty much allows us to say, okay, how do we want to serialize our user data into the session? If I pass in something else, let's just say if I passed in just the entire user object, then what you'll see is this user property will map to the entire user object, okay? So let me just go ahead and clear my cookies once again, because it'll throw an error because we are passing a valid cookie. But when we do that, we actually need the deserialize user function, and I'll explain a little bit about that in just a second. But let me try to re-authenticate now. And now, if you look at the logs, you'll see how that user object is now in the session data. Like I said, all this stuff I've went over in early parts of the tutorial when we went over Passport and session. So if you need a recap with a full in-depth coverage of everything of how it works, I definitely recommend you to revisit that section, okay? And it'll clear up a lot of confusion. But let's go ahead and change this back to passing the user ID. And this is the actual document object ID, not the Discord ID, okay? So now let's go ahead and implement the deserialize user method. So we're going to go ahead and call passport.deserialize user, pass in a callback function as well. Now, this function is important because when we first log in, we call serialize user because we're basically taking the user object, we are storing it in the session store, and then we're setting a cookie and sending it to the browser. When the browser has that cookie stored, it's then going to send the cookie upon subsequent requests. Now that cookie is sent to the server, and our middlewares such as Express Session, Passport will take care of everything for us. So what it does underneath the hood is it'll grab that session ID from the cookie, and it'll look inside the session store for that session ID and the data that it maps to. Okay, so I actually already have the session store implemented. So if I go into sessions, you can see that we have a bunch of session data right over here. So what happens is it goes inside the session store, looks for the session ID. So for example, these are session IDs. And then it references this session property right over here. And currently this is a string, but what it does is it parses this into a JSON object. And then it attaches it to the request.session property. Okay. Hence why when I showed you when I logged request.session, you saw how we had that cookie property. And then you also saw that we had that password property and we had the user property, all that kind of stuff. What deserialize user takes care of is it pretty much takes that serialized data. So in our case, it's just the session data that's all parsed into a string. And then it kind of like undoes it. It converts it back from a string to a JSON object and restores it by attaching it to the request object so we can access it very easily. So we know who the user is and we can get the user's session data. Okay, so the first argument for deserialize user is going to be the ID, which is really whatever it is that you passed in right over here. So if it's user ID right over here, then this argument is going to be that user ID. If you passed in user.username like this, then this argument is going to be the username. If you passed in the user object itself, then this argument would be the user itself. Okay, let's keep it as user.id. And the second argument for this callback function is done, similar to serialize users callback function. Now inside the serialize user, we actually need to search for the user by the ID. So the first thing that we're going to do is I'm going to use a try catch. Always handle your errors. And what I'll do is I'll search for the user. So const find user equals, and since we're searching for the Discord user, I'm going to import the Discord user model. I think I already had that up top over here. Yep, I had it up top over here. So Discord user dot find one, and we're going to actually search not by the Discord ID, but by the object ID. So the object ID are this ID right over here, not the Discord ID. It's the auto-generated ID that MongoDB generates for each document in the collection. So I can actually just use this find one or this find by ID method and pass in that object ID. So this will search for that user by the ID, and I need to make sure I await this call because it is asynchronous. So let me add the async keyword in front of our callback function. Okay, so now if the user is found, So I'm going to use a ternary operator. So if the user is found, I'm going to call done, pass null for the error, and pass find user. However, if the user is, oh, whoops, sorry about this, find user, question mark. Okay, so if find user is defined, it's going to go ahead and call done. And then if find user is undefined, we'll call done, but pass in null for the error and null for the user. Okay, so there's no error, but there's also no user. So now inside the catch, we will just simply call done, pass in the error and null for the user. Okay, so now you'll see that the deserialized user function error will go away. Now to test everything out, we're going to go ahead and make that request to the auth/discord endpoint, which will eventually redirect us back to this endpoint over here. And then what I'll do is I'll visit this API/auth/status endpoint that I had implemented already from previous parts of the tutorial, but it still works just fine because the responsibility of this endpoint is just return the user object that's on the request object itself. And we already configured Passport to do that for us, okay, specifically for the Discord user. So let's go ahead and go back to the browser. Let's go ahead and let me clear my cookies first because we're still technically logged in. So I want to do a completely new login. So let's do that. Okay, so I'm going to click authorize. So I've successfully logged in. And now notice how if I go to the console, you can see that all of my session data is right over here. And then if I go to API/auth/status, you see how now it returns to me the Discord user that I am logged in as. If I were logging in as a different Discord user, it would go through that verify function logic, and then it would end up serializing that other user into the session. And then when we visit this endpoint, we can see our record that's saved in the database. So I hope all of this makes sense. Alright everyone, so in this part of our Express.js tutorial, I'm going to show you how to set up Jest and use Jest to write unit tests and run them for your Express application. So Jest is a testing framework for JavaScript. It's very popular. It's made by Facebook, or now known as Meta, and it's been around for a very long time. And you can use Jest to write tests and run them for really any JavaScript application. Many people use it to test Node.js server-side apps. You can use it also to test React apps or Angular apps. It's very versatile. So let's go ahead and get started. So inside my project, one thing that I do want to mention is that remember that we are using ES modules. So if you recall, inside our package.json file, you can see that I have the type set to module and all of my file extensions are ending with .mjs. Now, there's nothing wrong with using ES modules, and it is the way to go in the future with developing server-side with Node.js. However, as of right now, they currently do support ES modules. However, it requires experimental flags, so you need to enable an environment variable. And while that might work out of the box, there are some things that don't necessarily work. And after doing some research on Stack Overflow and some of the GitHub issues, I've came to the conclusion that some of the things that I was trying to get to work just wasn't simply working, to say the least. So the options that we have are, we can either revert our entire project to common.js. So what that means is we remove this type, it'll set everything back to common.js because that's what the default system is. And then we would have to remove all of our import statements and replace them with require statements. So instead of import express from express, we would have to do const express equals require express like this. And then we would have to change all of our export statements as well. So instead of export const mock users, I would have to do module.export and then pass in mock users like this. And obviously that's not something that is possible for many projects because you might have already written so much code and you can't just go through every single file and change all those lines. It just doesn't really make sense. So I figured out a solution where we can actually configure Babel, which is a transpiler, and we can use Babel to actually take all of our MJS files and kind of like transform them from ES modules into common.js so that way Jest can actually execute them correctly. So we're going to leave our type set to module. We're going to leave all of our code the way it is. We're not going to change anything at all. We're not going to modify the import statements, nothing. And I'm going to show you how this is going to work. Now, if you're someone that is just trying to learn how to write unit tests and you might already have Babel or TypeScript set up, then Jest actually has documentation on how to configure Jest with the right environment. If you go to their docs, they actually show you right over here if you're using Babel, Webpack, TypeScript, all this stuff. So for example, if you're using TypeScript, you can use Jest right over here. It even mentions over here. And it's basically just a preprocessor. So you can actually use Jest to test your project written in TypeScript. So to get started, we need to install a couple of dependencies. So I'm going to type npm I -D because I'm going to install these as dev dependencies. So the packages are @babel/core, @babel/node, @babel/preset env. So that's it for Babel. We then need to install Jest as well. And then let's go ahead and hit enter. So while this is happening, I'm going to go ahead and go into my project folder. And I'm going to go ahead and just set up the Babel RC configuration file. So you're going to go ahead and create a new file. I'm going to call it .babelrc, like this. And then I'm going to go ahead and pass an object like that. And then we need this presets field. And this is going to be an array. And inside this array, we're actually going to pass an array, and then inside this inner array we're going to pass a string, and we're going to type @babel/preset -env, and then we're going to pass a second argument or second element inside this inner array. So we have this object right over here, and this object is going to have this targets property, which is going to map to an object, and in that object we're going to have node set to current. Okay, so we're just configuring the preset env for Babel. Okay, so that's pretty much it for the Babel stuff. Now let's go ahead and close that. So our packages have finished installing, and let's go ahead and type npm init jest @latest. So we want to configure Jest, and what this will do is set up a Jest config file for us. So I'm going to hit enter. And then it's going to ask us some questions. So it's going to say, would you like to use Jest when running tests? So this will just create a test script for us. So I'm going to hit yes. Would you like to use TypeScript? If you're using TypeScript, then press yes, but I'm going to press no. Choose the test environment. So we are testing a server-sided Node.js application. So we're going to hit enter for Node. But if you're testing like a front-end application for React, then you'd want to hit JS DOM. Do you want just to add coverage reports? We'll hit no for that. We'll just select it as V8. And then for this one, you want to hit yes. Automatically clear mock calls, instances, context, and result before every test. This will ensure that whenever you run your next test, there won't be any leftover mock calls or mock data from the previous test. And that's actually very important. So you can see that it modified the package JSON file, and then we created this jest.config.mjs file. Okay, so we're not done yet because there's one more thing that we need to do inside our jest.config.mjs file. So right over here, we need to go to this transform property. Currently, it is commented out, but we want to uncomment this part, and we want to set this to be an object. And now what this transform property will take care of is it will look for those source files that match a regular expression and transform the source code into something that Jest can actually run, which is pretty much plain JavaScript. So what I'm going to do inside this object is I'm going to use this regular expression right over here. I'm going to copy it, and you all can just copy this as well. So this will just look for our MJS files inside a directory. And what I'm going to do is map this value to Babel Jest. So this is going to be the tool that it's going to use to deal with the transformation. And now we actually didn't install Babel Jest, but when you install Jest, it actually does install Babel Jest for you as of right now. If you look at your node modules, you can see that there should be this Babel Jest package right over here. So that's how we can verify that that package was installed for us. Okay, so we're done with this part, and let's just also go into right over. Let me go over here. Module file extensions. So we'll just uncomment that, and you can remove the ones that you don't need. So I'm not going to be using TSX or JSX or TS. So I'm just going to remove all that, and I'm just going to close this out. So we should be done with our setup. We do need to actually go into our package JSON file, and for some reason, when we ran the Jest configuration, it did not override this test script. So let's go ahead and do that real quick. Whoops, let's go ahead and do that. So all we have to do is just have this test script and then have it execute this Jest binary. So this will look inside your node modules inside this bin folder, and it will look for this Jest binary right over here, and it'll just run that command. And that's what will actually run your test for you when you are ready. So let's go ahead and write a very, very simple test and kind of like explore the Jest API. So what we're going to do inside our source folder, we're going to create a new folder, and I'm going to name it __tests __. And this is industry standard. And this is where you're going to place all of your tests. So you need to create a file, and then you want to name the file of your test, ideally something that resembles the actual file name. So for example, if I were testing, let's say, something inside my users.mjs file inside the routes folder, then I would want to name the test file something like users. And then the extension here is where you want to name it either .spec or .test, and then end it with JS like this. So if you were using TypeScript, it would be .spec.ts or .test.ts. Since we're just using JavaScript, I'm going to name it .spec.js or .test.js. Doesn't matter which extension, either test or spec, that you want to use. I personally like to use spec, so I'm just going to go ahead and do that. And now it's going to go ahead and create this file for me. Okay, let's just explore the Jest API very quickly, and then I'll get to actually testing some of our Express route handlers. So we have this describe function, and now you'll notice that right now it isn't going to be imported from anywhere. By default, Jest actually... So the very first function that you're going to be using that comes from the Jest API is this describe function right over here. Now, one thing that I do want to mention is that you could actually import this describe function from @jest/globals like this, and then you can just use it accordingly like this. The thing is, though, Jest typically is configured globally, but you can see right now for some reason it is not configured globally. So I'll show you very quickly how we can actually configure Jest to have this describe function and other functions like it, test, before, all, before each, which are hooks. These two are hook functions. I'm going to show you how to configure this so that it's actually global, so we don't have to manually import it in our files. So what you need to do is you need to first create a new file inside your root directory called jsconfig.json. And then you're going to set this object and have this type acquisition property, which is an object. And then you're going to add this include property, which is an array. And then you're going to want to add Jest. Okay, now we don't actually have any types installed, I believe. Let me just double check. Yep, we don't have types for Jest installed is what I meant to say. So we need to actually install those types in order for us to get it to work. So what I'll do, and you can kind of see that now, it actually recognizes jest.describe globally. But just to be safe, make sure you install the @types/jest package like that. Okay, even though we're not using TypeScript, you can still use this package to have types set up globally like this. Okay, so now you can see that right over here, we have the Jest types over here. And it should recognize them globally without any issues. So going back to our users.spec.js file, I'm going to call this Jest describe function like this. And again, no need to import it. And this describe function is used to create test suites. And basically all that means is it allows you to group together your tests into collections so you can better organize and understand what's going on. So typically you want to give your test suite a generic name that represents what you're trying to actually test for. So for example, if I wanted to, if I wanted to test for a basic, I'm trying to look for something that we can actually test. Let's do this endpoint. So let's say, for example, if I wanted to test this endpoint where I wanted to get a user by ID, then I would just first name the test suite something like get users, and then pass in this callback function. So inside this callback function is where you will actually create your test closures. And those are basically just going to be what's actually going to run your test, and you're going to implement the test logic in there. So to create a test closure, you can use either the it function or the test function. They both work the exact same way. So I'm just going to use it, and then you want to give the test name. So I'll just say something like should get user by ID, and then you want to pass in a callback function. And inside the callback function of your test closure, so the second argument for this it function, this is where you're actually going to invoke the function that you want to test, and then you want to actually write assertions and verify that certain things occurred. Okay? So here's the next part though. We need to actually write a test for some of our functions. So for example, let's say I wanted to test this router.get /API/user/ID endpoint. So this is getting a user by ID. And this is actually one common confusion that many developers begin to have when it comes to writing tests. They look at this and they're like, well, how do I actually test this whole endpoint? Because there's so many things that are going on. Do I need to actually make an HTTP post request or GET request to the actual endpoint that I'm trying to test? So first of all, when it comes to unit testing, you want to actually test only a single piece of your code. Look for individual functions that might be calling other functions. Maybe they are calling a database, maybe they are calling an external API, whatever it is. You want to test that single function, and you want to make sure that the function does what it's supposed to do. So ideally, you want to verify that the function is hitting the right if-else statements, the conditions correctly, and then based on those conditions that are being executed, you want to make sure that it is returning the correct response. So to give you a very simple example, let's take a look at this function right here, okay? So you can see that this function is our request handler, and it first takes this find user index property from request. And this comes from our resolve index by user ID middleware. So don't worry so much about that right now, but we grab this property from the request object. And then we try to reference mock user array and index this user so we can grab the user with its index. So if the user is not found in this mock user array, it's going to go ahead and return a response and send a status of 404. If the user is in fact found, then it's going to go ahead and call response.send find user. So what you need to understand is this function is pretty simple. It doesn't really do too much stuff, but the point is that we want to make sure that we understand what are the possible outcomes of our function. In this situation, there are two possible outcomes only two. Either the user is not found and we return a status of 404, or the user is found and then we just send back the user that was found. There's only two outcomes. Sometimes your functions might have many different outcomes. It might output many different types of results based on the condition. And there are some general principles when it comes to writing your code in a way that makes it easily testable, because writing tests also depends on the code quality as well. If you have a bunch of spaghetti code, you're making it really difficult to actually write tests. Okay, the purpose is not to actually write the most complex code, but to separate concerns and make sure that you have each function doing the main responsibility, and anything else, you turn it into a dependency function is what we like to call it. And that basically just means that you're invoking another function and letting that function take care of the work. And then once that function is done, it'll return back the result, and then you can proceed. So we'll start off with a very easy example. We'll use this callback function right over here. But now here's the other problem though, okay? When we actually want to write tests, we want to be able to import the function or class or whatever it is that we're trying to test into our test file. So how do we import this anonymous function? There's no way. So what we need to do is we need to copy this function, and we need to move it into we need to turn it into a named function. So what I'll do is I'm gonna actually create a new folder called handlers, and then I'm gonna create a new file, and I'm gonna call this users.mjs. And then what I'm gonna do is I'm going to paste this function right here, and then right before the parentheses, I'm going to do export const. And since this request handler was trying to get the user by ID, I'm going to go ahead and call the function get user by ID handler. And let's make sure that we are importing the correct value. So we need mock users. So I'm going to import that up here. And I think that's all we need. So let's go ahead and copy this function, and we want to make sure that we pass it as an argument to our router.get method call. So at the end like this, and then we're going to make sure we import that up top over there as well. And then now we have our function being passed as an argument. It's still going to work the same exact way. The only difference now is that we can actually import it wherever we want. So I'm going to go into my users.spec.js, and what I'm going to do is first I'm going to import that function. So get user by ID handler. And so this is going to be our system under test or function under test. And now we want to actually call this function. Okay, but we need to also remember that this function does take in two arguments. It takes in a request and a response. So this is where you start to learn how to actually create fake data or mocks, so that way you can use them for your test subjects. In this case, our get user by ID handler function. So when it comes to creating mocks, there are ways to be smart with it. So what we'll do is we'll create two simple objects. Let's call this mock request and then mock response. And remember this, the request and response object resembles the actual request type in Express.js. Okay, so if you were to actually look at, let me go over to here because we're using JavaScript. Okay, so if I were to actually right click the type definition of this request, you can see that we have this interface, and you can see that there are a lot of properties on the request object itself. Okay, you can see that we have host, cookies, method, params. These were similar methods or properties that we looked at earlier, signed cookies as well. Now you're probably wondering, well, when I create my mock object, like my mock request, do I need to also include all of those fields? And the answer to that question is actually no. So what you can do is you can only define the fields that you need. Okay, and again, this works because we're using JavaScript. If you're using TypeScript, then you can use casting. For example, you can type annotate the request and force it to be an actual request type, even though it is missing all of its fields. But since we're using JavaScript, we can do literally whatever we want. So for our mock request, we want to include the necessary properties that our code is actually referencing on the request object. So this is where you need to actually look at your code, look at the function that's being tested, and you need to see, okay, what is actually being referenced on the request object? So I can see right over here, one property is being destructured from the request object. So we need to make sure that this, whatever this find user index is, we know that it's a number, but whatever it is, we need to make sure we define that in the mock request object. And it seems like that's the only property that we are referencing. So I know that this is a number because in case if you didn't watch the early parts of the tutorial, this resolve index by user ID middleware function, what it does is it will go ahead and grab the ID from the route parameter and it'll take care of parsing it to an actual integer, and then it'll attach it to the request object. So what I'll do is inside my mock request, I'm going to go ahead and define find, or what was it called again? Find user index. Yep. Find user index. And then you can give it literally any number you want. You can give it 1, 2, 3, 100, literally anything you want. But here's the thing though, we want to give it an actual meaningful value that is going to correlate with our code. So if you look at the rest of your code, you can see that find user index is being used to retrieve an element from this mock users array. And this is our mock users array right over here. And if I were, so for example, if I were to just give like just some bizarre number like 100, it's pretty obvious that that number would not actually give us back anything inside mock users because there is no element at subscript 100 that would give us back a user. Okay, So let's just do something simple for now. Let's just do 1. So that way I know that it'll give me back the user Jack. Okay. All right. So we're done with the mock request object. Now let's go into the mock response. So this is going to be our response object. And now we have to do the same thing. We have to look at our code and look at what response is, and we have to also see what is being referenced on response. So right over here, I can see that response is being referenced right over here, and the send status, this is a method on the response object, is being called. Okay, so I know that send status is a method, so that means that inside the mock response object, we should set this send status property and have it mapped to a function. So you might think that it would look something like this, right? Well, no. So it is going to be a function, but it's not going to be a regular function. It's going to be a mock function. So what we can do in Jest is we can use this Jest namespace, and I can reference jest.fn like this. And what this will do is it'll create a mock function for me. So this is where we actually want to call a mocked function of send status on the response object and not the actual send status method itself. Okay, so we use jest.fn to apply this mock function to send status. And then we'll do the same thing for the send method as well. So let's do send, and then this will be just.fn. Okay, all right, so now what we want to do is we want to actually take both of our objects, mock request and mock response, and pass them as arguments to get user by ID handler. So let's do that. So mock request and mock response. Okay, so now if I run my test right now, the test actually should just pass because we're not actually testing for anything. So in our terminal, we'll run npm run test, and this will execute that Jest binary. And you can see that our test runs and it passes. And just very quickly, I want to show you what would happen if I were to go over here and just kind of like remove this part entirely. And you'll see that it's going to go ahead and complain about all this stuff. So that's the reason why we needed this transform part. Okay. And again, we can also run our application completely separate from our tests like this, and it still would work just fine. Okay, so hopefully the setup with Babel and everything else wasn't too complex, and we can still proceed to use ES modules and write tests. Okay, you can see it's currently running without any issues. Well, awesome. So let's go ahead and go back to our test, and let's actually write our first assertion. So again, let's look at our code again, okay? And what we can see is there's two outputs. There are two things that could happen. Either we send a status of 404 or we send the user back. So this is where we need to understand, okay, well, what should happen inside this test is whatever it is that we want it to happen. Okay, so we have to figure out what it is that we're trying to test for. So in my situation, let's say I want to test to ensure that a user was actually sent back. Okay, and so we already set up our mock request to have find user index to be a value of 1. So when the function is called, it's going to use 1 as the index and search for that mock users. So let's actually write our first assertion. So again, we need to understand what it is that we're trying to test. In my situation right now, I want to test to make sure that the user was actually found and sent back with the response. If I look at the code, okay, how can I verify that the user was sent back? Well, what I can do is I can write an assertion that verifies that this response.send method was called and it passed this find user object as an argument. And I can also write another assertion to verify that send status was not called, because send status would only be called if find user is undefined. And since we are setting find user index to be 1, it's going to use that as the index to reference the user at that position. And mock users is just this constant array that we have over here. So we can just reuse this data because it's not like it's coming from a database or some external API. So we can use this as mock data. So let's go back into our test. And here's what we'll do. we're going to use this expect function like this. And we use the expect function to actually test a value. So for example, I want to test that mock response dot send like this. I want to test this specific function. And then at the end of expect, at the end of the parentheses, we can use these Jest matchers. And the one that I want to use is to have been called. So what this means is we are expecting mock response.send. We're expecting this function to have been called. Okay, so that asserts that the function was called when we called this getUserById handler. So let's actually test this out and see what happens. So let's run npm run test. Okay, and you see that it passes. Okay, so again, it takes some time to really, get used to some of these matchers and knowing how to use expect. But as long as you just keep practicing, it's going to come in handy, and you're going to develop an intuition behind it. So you can see that we definitely wrote an assertion on this send function, and we asserted that this function was called. And you'll notice that right now, if I were to try to negate this matcher, so if I actually use .not.to have been called, that basically just asserts the opposite. So it's going to assert that mock response.send was not called. So if I run the test, it should fail because the function itself was actually called. Okay. Hopefully that makes sense. And it's sometimes good to do that because it helps you assure that you're not having your test pass falsely, if that makes sense. So you don't have any false positives, because sometimes your tests may pass when they actually shouldn't. So let's actually be more specific with our test. So what I'll do is I'll duplicate this line, and I'm going to use the matcher to have been called with. And this is what I want to use whenever I want to verify that a function was called with specific parameters. So the send function is called with only one argument, and this argument is a user itself. Now, again, since we are using a mock array, I can very easily just reference the array at the subscript of whatever find user index is, which is 1. So I can just go ahead and import this mock users right over here. So let's import that, and that gets imported up top here. And then I'm just going to access it like this. Okay. Or if you wanted to, you could just literally copy this whole thing and paste it in like this. Either one will work the same way because they're both going to be the same object and the contents are the same. Let's go ahead and run our test now. And you can see that it still passes. And you'll notice that if I tried to, let's say if I tried to pass in this direct object, and let's just say if I tried to change some property values right over here, let's change the username. You're going to see that the test actually fails because the value that was actually passed as an argument to the send function is not the same as what we were asserting it to be. So you can see that the expected value, we expected username of Jack without the K, so JAC. But then the actual received value was username of Jack. So again, this is good to make sure that your tests are actually passing correctly. Okay, so let's run the test again, and it should just pass, just like that. All right, so hopefully this makes sense. And there's also one more assertion that I want to show you. So we can also check to see the amount of times this send function was called. So I can do to have been called times, and I can specify the expected amount. So if I want to verify that this send function was called once, then I can just pass 1. And it should only be called once, especially in Express, because if you try to call it twice, that will actually throw an error. Let's run the test again. And of course, if I try to pass in like 2, it'll throw an error or the test will fail. You can see over here, the actual received number of calls was 1. Okay, so hopefully that makes sense. And one more thing as well that I forgot to mention is that with this to have been called with matcher, you can actually pass in the number of arguments that the function is called with. So we only have 1 over here, but if you had a function that was called with like multiple arguments, you can pass in the exact amount. Okay, so let's go ahead and move on. let's write another test to handle the second scenario of our function. So the other scenario would be where find user is not found, and it sends back a status code of 404. So I'm going to write another test using the it function, and I'm going to go ahead and say it should call send status with 404 when user not found. Okay, you want to keep your test names short and simple. And we're going to go ahead and write our test. So now here's the thing though, okay? If I were to call getUserById handler again, and then if I were to pass in the same mock objects, it's going to actually give us this same response that we have up over here. But the problem is now we want to actually get it so that we can set up our code to ensure that the send status function is called instead of the send function. Okay, if I were to just leave mock request alone, you can see that it's still using the same value for find user index, and in the code it'll actually look for a user and return that user. So it would never hit this part at all, line 6. So we need to actually modify the mock request object. So what we need to do is, there are a couple ways that you can do this. If you prefer to not modify the object directly like this and set it to a value like this, you can always just create like a copy of it. So you can do something like const, and then you can do mock request, or let's just do copy mock request equals, and then you can do something like find user index is equal to 100, and then of course you can also destructure mock request, because there might be some properties that you want to copy over to the copy of the mock request. So you can do something like this and then pass in copy mock request to here. For mock response, we don't really have anything that we need to change because we still have the same functions, so it doesn't really matter. So we can leave that alone. Okay, so we're going to call getUserById handler with a new request object, but we're going to set the find user index property to a value that I know that will not give us back a user. In this case, we'll set it to 100. Okay, so when we call this function, we now want to write some assertions. So what I can do is I can write an assertion to verify that this send status function was called. So let's do expect mock response send status to have been called. And then let's run the test. And you can see our second test passes without any issues. Let's write a few more assertions. So let's do expect mock response send status to have been called with 404. Let's run the test again. Passes. And I can just throw in a value that I know is actually not going to pass. You can see that it fails, so that's good. Because it shouldn't be sending a 400, it should be sending a 404. And I can also do to have been called times. Let's do 1. Let's run the test again. And let's also write an assertion where we verify that mock response.send was not called. So expect mock response send not to have been called. Let's run the test. Wonderful. So all of our assertions are good. Now, one more thing that I do want to do though is if you go inside your Jest config file and if you look for clear mocks, you want to make sure this is set to true. Earlier when we were configuring Jest, we had press yes when it asked us if we wanted to configure our test to clear all mock calls, instances, and contexts and results before every test. Because what happens is if this is false, the next test will actually carry over data from the previous test. So if I actually try to run my test now, you're going to see now our second test actually fails. And it's actually failing because right over here on line 32, where I have this assertion, expect mock response.send not to have been called, you can see that it's failing because it says receive number of calls 1. So it in fact was called. But if you think about it, your code itself says otherwise, because I know for a fact that in my code response.send should not be called because we are returning response.send status. So this code doesn't get executed when find user is not defined. Okay, the reason why it's failing this test right over here and it's treating it as if send was actually called is because in the previous test, the send function was called and it was called one time. Okay, so since it was called one time and we didn't clear the mocks, it carried over to the next test right over here inside this second test over here. So there's several ways they can do this. The first thing that you can do is obviously what we already had was having clear mocks set to true instead of false. The other thing that you can do is you can use this before each hook, and this takes in the callback function, and basically you can execute some logic that happens before each one of your tests. So you can initialize a variable, you can connect to a database, whatever it is that you want. So you can actually use this jest.clearAllMocks function call. And now if I run my test, it passes. Okay, so this is manually clearing all the mocks before each test. Sometimes you might not want to clear all the mocks because you might want to depend on previous function calls from the previous test. So you might want to turn off clear mocks and set it to false. Sometimes you just want to manually clear the mocks, so you can use this before each. It's up to you, but I just wanted to mention that as well. So I'm just going to remove this before each, and I'm going to set clear mocks back to true. So hopefully these two tests that we wrote makes sense. Now I have one more example where we can write a unit test for another one of our endpoints, but this one's going to be a little bit longer, so I just wanted to warn you all, but I'll try my best to keep it as concise as possible. And I want to do this one because there's a lot of stuff going on inside this function, and I think it would be really great for you all to learn how to test different scenarios, okay? So what I'm going to do is for my post endpoint for API/users, this request handler creates the user and saves it to a database. So you're going to learn how to mock functions that come from modules. You're going to learn how to mock classes, ES6 classes. You're going to learn how to mock the database call, so that way we don't actually hit the actual database, because when it comes to unit tests, you don't want to actually invoke your database or call an external API. So you're going to learn how to do a lot of stuff with this next test. So we need to make sure we get this function out of this format. We don't want it to be an anonymous function. So I'm going to just copy that, and I'm going to go inside, let's see, not here, but inside my handlers file, or the users.mjs file inside handlers. And I'm going to go ahead and paste this here. And I'll name this function create user handler like this. And before I import all of the necessary functions into this file, let me just take this and let me just paste it here and import it up top over here. Okay. And now let's go ahead and go back to our users.mjs file inside the handlers folder, and we need to make sure we import all of the necessary functions that we imported that were in the other file. So validation result comes from Express Validator. That's a validation library that can validate post requests, request bodies, query parameters, all that kind of stuff. We need to also import match data. That's also a function from Express Validator. Hash password is a function that we wrote ourselves. Let's import that over here. User is the Mongoose model. So this is what actually allows us to interact with our database, but we're not actually going to call the database. We're going to mock out this as well. And I think that should be it. Okay, so now let's go ahead and go into our users.spec.js file. And then now I'm going to create a new test suite. So outside of this describe get users, I'm going to go ahead and create another describe, and I'm going to call this create users. So you can think of these individual it functions, these individual tests as your scenarios. Okay. So inside the create users test suite, I'm going to go ahead and create a simple test, and I'll just say it should, let's see, let's go back into our function. Okay, so this is a pretty big function. It does a lot. So I want to take this step by step so that way you all don't get confused. First, let me just remove these console logs because we're not going to need them. Whoops. So we want to take this step by step because there are a lot of things that are going on. So let's take a look at our code and understand what's going on. So when we call this create user handler, when Express calls this function to handle the create user endpoint, it's going to go ahead and call validation result. So when you're looking at the code, the important part is not to really worry about what these functions, these external functions, because we don't know what these functions, let's just pretend we don't know what it does. You don't have to care about what this function does. You have to care about what it returns, because we're going to mock the function anyways. We're going to mock the implementation. We're going to mock the return value of the function. So in the end, it doesn't really matter. Okay, what I care about is what it returns. So result, you might not know what it is. You might think it's an object, it's a number, it's a string. You might not know, but you can very easily tell if you just look at the rest of the code and look at where result is being referenced. So you can see right over here that result has this isEmpty method that's being called on it, and I immediately know that this is an object. Okay, there's also this array method on result as well. So what I can do is I can go ahead and actually mock out validation result, because this is known as a dependency. It's a function that can perform some kind of side effect, and we don't want to actually have any side effects in our unit tests. We want to make sure that we mock them all out, and we only want to test the function itself. We only care about the possible paths our function that we're trying to test can take. So again, you can see right over here, this is our first if condition. If result dot is empty, if it is, let's say if this results to false, and then we negate that value. So if it is not empty, then we're going to return this response status of 400 and then send back whatever this value is. Again, I know it's an array because we wrote this out ourselves, but we're just pretending that we don't know. Okay, so this is the first thing that it could do. The second thing that could happen is right down over here. So you can see that we have this new user.save being called, and then it sends back a status of 201 and it sends the user. Okay, so this is the second scenario. The third scenario is that an error could be thrown inside this try block. So the save method could have thrown an error, and then we catch it down over here, and then we send back a status of 400. Okay, now there actually should be another scenario where the hashing password failed, and we actually should have added this inside the try catch, but we're just going to leave it the way it is right now. Okay, so hopefully all of this makes sense. So now if I were to go back up top over here, again, the validation result is one dependency. Okay, so what we want to do right now is we want to test our function to handle this first scenario first, because instead of just having to do everything all at once, we're going to take it step by step. Okay, so what I'm going to do is I'm going to write a test that is going to mock out this validation result function call. We're going to have it return literally whatever object we want, but that object specifically needs to have this isEmpty method, as well as this result, as well as this array method on the result object, because they are both going to be called. Okay, so we need to make sure that whatever isEmpty is going to return, it returns false for this case, because I can see that we negate the value of result.isEmpty. So for example, if there are no errors, that's what this isEmpty method means. If there are no errors, you can see right over here, it returns true if there are no errors. So if this is true, the negation of this would not execute this line, and it would just go down over here, which means that there are no errors. However, if isEmpty is false, then result.isEmpty would return false, which means that we negate that, which means it would return this part over here. So for our first scenario, we want isEmpty to return false, just so that we can target this line over here. So what I'm going to do inside my users.spec.js file is this. So I actually already have some mock data defined up there. Just to keep things simple, I'm actually just going to define it inside test suite. So const mock request, and then const mock response. And then it'll be within the closure of this callback function, so we don't have to really worry about the ones defined up there. So what I'll do is for the test scenario, I will say it should return a status of 400 when there are errors. And we'll pass on our callback function. Okay, so now we need to go ahead and set up our mocks, our mock request and mock response to actually get this to work. So again, we have to look at our request object, and we want to see within these two lines where is our request object being referenced? You can see that it's being passed as an argument to a validation result. However, it's not going to really matter because we're going to mock a validation result. So we actually aren't really going to need to do anything with the mock request for this specific scenario. Okay, so let's look at response. I can see that response is referencing this status method right over here. So right over here, we're going to go ahead and do status just.fn. And you know what? I actually could just reuse mock response up top over here because we're going to be using some of these similar methods anyways. So you know what? What I'll do is I'm just going to remove this and I'll just reuse the mock response up here. And it shouldn't matter because we are clearing all of the mocks anyways before every test, so we won't have any leftover data from the previous test. Okay, so let's go ahead and implement the status method. And this is also going to be a mock function, so we'll use just.fn. Okay, now one more thing that I do want to point out is that after we call the status method, we actually are calling the send method as well, because when you call this status method, it actually returns the instance of the response itself, and you can actually call the status method on it as many times as you want because it just returns the response instance itself. So in order for us to actually detect calls on the send function, inside status over here, inside just.fn for status, we actually want to pass a callback function. And we want to actually return mock response, so basically returning itself. So that way, by returning itself, mock response would then have access to all these other methods as well. And if we don't do this, we wouldn't be able to actually test to see if .send was called after .status. And I'll show you that when we actually write the test. Okay, so we're not done yet. We're done with setting up our mock request and our mock response. We need to now mock this validation result function. And you're probably wondering, well, how do I do that? This is a function that comes from a third-party module, Express Validator. Well, I'll show you. So you can mock modules, and what that basically means is you can override the implementation and the functionality that module's API provides. So for example, inside the Express Validator module, we have a bunch of functions, we have a bunch of different things that we can import that we can use in our application however we want. Now, for our case, we only are using validation result currently, so we want to mock validation result specifically. So all the way up top over here, what I can do is I can reference jest.mock, and then I want to specify the name of the module. So I'm going to go ahead and say Express Validator like this. So this will mock that npm module. You can also mock your own modules that you create as well. So for example, later on when we need to mock the hash password function, we're also going to mock this helpers module as well. Okay, and that's our local module. So as a second argument, after we pass Express Validator for the first one, the second argument is going to be a factory. So this is where you're going to return an object, because if you think about it, your modules are kind of like objects, and those objects have the named exports. Okay, assuming it does. So what we want to do is we want to return this object like this. So notice how I have the parentheses wrapped around the curly brace. So that just allows me to do it shorthand instead of having to do something like this. Okay, so what I'll do is inside the object, I want to mock the validation result function. So I'm going to type validation result like that, and I'm going to do just.fn like that. So now I have successfully mocked the validation result function for the Express Validator module. And now this mock function, we want it to actually return something, so that way we can actually have this result value be something that is defined with the correct isEmpty and array methods. So we can do that inside our just.fn function. We can pass in a callback that also returns an object as well. And I can go ahead and define the isEmpty method. So isEmpty is going to be a mock function as well. But this mock function, remember, we're going to have it return false. Okay, so pass in that callback, return false like this. And then we also want to implement this array method on the return value of validation result. So this is a method, and it does return an array. So we will have it return an array like this. And then what you can do is you can add some random object with random fields. So you can just say message invalid username. Just like an example, you can literally put whatever you want, like invalid field, whatever it is. Okay? Because we can always actually modify, we can always override the return value of validation result, and I'll show you how to do that as well. Okay, so I think we're good to go. Let's actually go ahead and test everything out. Okay, so what I'm going to do is I'm going to go ahead and call create user handler. So let's go ahead and import that up top over here. Oh, whoops, I can just import that from right over here. Wonderful, because it's coming from the same file. Okay, so let's go ahead and call create user handler. Let's pass in the mock request, and notice how we're referencing this local mock request because this is the closure. We're inside this closure over here. And then we're going to reference the mock response, which is all the way up there. So we are reusing that same mock response object from earlier. Okay, and remember that this function is asynchronous, so we should also await the call. And we need to make sure we add the async keyword in front of this callback function for the it function, okay? All right, so let's just make sure everything is okay. So if I run npm run test, the test does pass, but we aren't writing any assertions, so that's okay. And you'll notice how now if I actually try to kind of like remove all this, all the mocks that we just did, you'll start to notice that a lot of stuff starts to error out, and you can see that it's actually trying to go to line, seems like line 8 over here inside the helpers.mjs. So it's actually, without mocking anything, it actually tries to call the actual express validator library. So it's actually calling the functions, okay? And then it's going to try to execute everything the way it is. But you can see over here, it tries to throw this error right over here because we don't have a value for password. But we'll get to that because right now our request body has nothing, okay? And we also aren't mocking match data yet. So don't worry, step by step, just wanted to show you what would happen if we removed the mock stuff, okay? So let's add that back in, and you can see that everything will work the same way. All right, so now let's actually write an assertion. So the first thing that I want to do is this. So when it comes to testing, there are different ways that you can approach testing. There's implementation testing, and that's where you're actually testing the actual implementation. So you're trying to verify that certain functions are called with certain parameters. That's known as implementation testing. There's also behavioral testing where you just give it some input. You don't care what it does as long as it gives you an output. So there's different ways on how you can test this. With backend, you can't really go wrong with either one. Usually on the front end, like if you're testing apps in React, you would want to use behavioral driven testing because you want to test based on output and you don't care about what actually happens underneath the hood with all of the state and all of the form fields and whatever is being called to the API, stuff like that. So I just wanted to point that out. Okay, but since we're just getting started, I'm just going to show you very basic how to write assertions. So what I want to do is I want to verify that validation result was called with the request object. Okay, so the question is, how do I actually write the assertion for validation result? Because in my whole test file, I don't have any access to validation result. Well, I'll show you. So the first thing that we can do, and I'll import this over here on line 1, is I'm going to import the entire Express validator library, but I'm going to import it as like a default import like this. So import validator from Express validator like this. And then now down over here in our test, after I call the create user handler function, I can write an assertion, and I can reference validator.validation result to have been called times 1. And let's run our test. And you can see that it passes. And if I were to set this to 0 to see if it actually fails, and it should fail, you can see that it was actually called once, so that verifies that it was actually called. And if I were to actually remove, just kind of like remove this whole thing right over here, you can see that our test begins to fail and it's not recognizing validation result as a function. If I remove this whole just.mock and if I try to run the test again, you're going to see that other stuff starts to fail as well. Okay, so hopefully this helps you understand the importance of mocking out your modules, and hopefully this helps you understand how to mock out these functions that come from the Express Validator package, or just any package in general. Okay, let's go ahead and continue. So I'll do validator.validation result. So I'm going to write an assertion to say that to have been called with mock request, because if you look right over here, we are passing whatever request object this is to validation result. So we'll write the assertion there. It passes. And let me just change this to have been called instead of to have been called times 1. Okay, that's a lot more better because this basically implies that's going to be called once, or to have been called at least once. Okay, so now we want to also write an assertion that response.status was called with a status code of 400. So let's do that. So expect response dot, I think it was status, and it's mock response to have been called with a 400 mock response. Okay, let's run our test. Okay, it passes, good. And let's go ahead and write an assertion to verify that the .send method was called. So we can do expect mock response, and this will be mock response.send, not mock response.status.send, because remember that when we call the send method, we're still calling it on the instance of the response method. So we would have to reference mock response. So to have been called with, and then we want to verify that it was called with this array. And that's whatever we had mocked over here. So I'm just going to take that, copy and paste it down over here. Let's run the test again. And it passes. And again, I can go ahead and just change everything up and make sure that our test is passing correctly. And you can see it throws an error when I pass in the invalid expected argument. Okay, so that's pretty good. Let's go ahead and move on now, because we've covered this whole part over here. So now we have to cover the next few lines over here, everything up until down over here. So we are calling this matched data function, but we aren't mocking it. Okay, so it's going to actually call the actual match data function, which comes from Express Validator. So we want to mock it, because what I want to do is I want to mock this function to return some object, which is going to be the actual user data. So again, to give you context, what this function does is it takes the request body and it gives you the validation result. Okay, so if there are no errors, then what happens over here with match data is match data will extract all of the valid fields in the request body and store it inside this data object. So all we really need to do is just mock match data to return a valid user object. So let's do this. Okay, so going back up over here, I'm going to do matched data just.fn, and we're going to have it return an object. And keep in mind that whatever the return value of matched data is actually just going to be an object, so there's no methods on it that we would need to worry about, because we're not referencing anything except for just the password field. So let's just do, let's see, username. Let's do test password, password. And then I think the other field was, I think it was display name, if I remember correctly. Let me check. If I go inside my validation schema, so we have username, display name, and password. Yep. So display name. Just do test name. Now, some of you might be asking, well, what's the point of doing all of this mocking? Because doesn't that kind of defeat the whole purpose of testing? Well, no, not for unit testing, because remember, our goal is not to actually test to make sure that, Express Validator works. Our goal is to test create user handler works, our own function. This is a unit test. Okay, when you want to actually test the entire application, that is where you want to actually set up an integration test or an end-to-end test, which you will learn about it later. Okay, so hopefully that kind of clarifies the confusion between mocking and actually testing the entire thing without mocking it. Okay, all right, so now that we've mocked match data, this function to return a mocked result, so we can safely run the rest of our code. And then we want to make sure that this match data function is going to be called, but we also want to make sure that we don't hit this if condition and make this true. So we need to actually make isEmpty return true this time, which means that there are no errors. But the thing is, though, I mocked it up top over here to return false. So what if I changed it to true, but then that would break my first test over here. So we can't do that. So I'll show you what we can do to actually change the return value for our specific tests, okay? Because we want this isEmpty function to return true for whenever we call validation result. So that way, this if condition results to false, and then it'll go down over here and call match data. Okay, so let me just make sure that we have our match data function mocked properly. Okay, this is good. Let's go down over here and let's write our next test. And I'm going to go ahead and call this test, let's see. So I guess the overall thing that we are trying to test for is making sure that the response.status is sending back a 201 and it's sending back the user that was created. So essentially we're testing for success for creating the user. So I'll just say it should return status of 201 and the user created. Okay, and let me actually go up here and let me fix this. Should return status of 400. Okay, so let's add the async keyword in front of our callback function for this test. And now we're going to go ahead and call create user handler. So after we call our function, we want to actually mock out the isEmpty method to return true. So that way it goes to the match data function call. So inside our test, here's what we're going to do. We're going to use jest.spyOn, and I'm going to go and reference this import up here validator. So that's the entire Express validator package. And then we're going to spy on this function right over here. It's validation result, like this. Okay. And then what I can do is I can use this mock implementation once. And then in here, this is where I can actually mock the actual implementation of the function. And I can have it return an object, so the same result object, but this time that object will have this isEmpty function. So this is also going to be a mock function, and it will return true like that. Okay, so hopefully that makes sense. So this is how I can override the mocked value of validation result into something else. So now what will happen is create user handler will be called. It's going to go ahead and call validation result, and then result.isEmpty will be called. And we can see that's going to result to true, and then negating that will cause this whole if condition to be false, and then it will go down over here. So what I can do is I can write an assertion to verify that matched data is called. So let's do expect. So remember, match data is a function that comes from the Express validator package. So I'm going to reference validator.matchedData to have been called. And let's save and let's run our test. And let's make sure that it passes. Okay, so it actually is, let's see. Okay, yeah, don't worry about this. So it is actually supposed to pass, but the reason why it's failing is because right now it's actually trying to call the next few functions. It's trying to call hash password, and then it's also trying to call the database by saving this new user to the database. So don't worry, it is working. It's just that it's trying to connect to the database, and you can see that it actually timed out because we don't actually have a database connection. So don't worry, we actually did the right thing. We just need to mock the rest of our function. Okay, so we know that match data is being called. And you know what? Let me just comment all this out and run the test again because I just want to show you all that it passes. Great. So now let's go ahead and mock hash password because again, we don't want to actually call these functions because remember these functions, these dependencies produce side effects. Okay. So we're going to go up top over here. And now I want to mock this hash password function that comes from my helpers module. So what I'm going to do is I'm going to call just.mock, and I want to pass the path to that module. So we're in the test folder, so we need to go out one folder into utils helpers.mjs like this. Okay. And what I want to do is I want to have hash password. I want to mock the implementation. So let me pass in the factory and return an object and just override hash password. And so this will be a mock function, but I actually want to have it return some custom logic. And all I want to make it do is take in an argument. So I'll just do password. So inside this callback function, I can pass in this argument password. And all I'm going to do is just concatenate hashed with password like this. I'm just going to literally prefix the password with hash. So that way it at least does something. Okay. All right. So we just mocked hash password or hash password. So now let's go ahead and import up top over here. We're going to import helpers from utils helpers. Okay, and this would allow me to reference helpers like an object, and I should be able to reference hash password, or maybe I need to do import as helpers. Yeah, there we go. Okay. I think I may have needed to do that as well for validator. I'm not too sure. But let me just run everything and make sure it's good. Let me go over here and just comment this out real quick. Okay, there we go. Perfect. Okay, just wanted to make sure that didn't break. Okay, so now we're going to go down over here and we have wrote an assertion for the matched data function, okay, to have been called. Let me also change this to have been called with mock request to be more specific. And then we're going to go ahead and write an assertion for hash password. So what I'm going to do is I'm going to expect helpers.hash password to have been called. And I want to verify that it was called with data.password. So data.password is going to be whatever matched data returned. So up top over here, matched data returned password. So I'm going to say to have been called with password, like that. You know what? For the rest of this test, let me just comment out all this stuff over here because I do want to actually see our assertions passing. Okay, good. So to have been called with password. And then I also want to make sure that hash password, so helpers.hash password, returns with the correct value. So to have returned with hashed password. And I know I'm just hard coding these values, but ideally for you, you would probably not want to hard code these values, so that way you can make it more dynamic. But I'm just doing this for testing purposes, okay? Just to show you an example. So if I run the test, you can see that it will, in fact, return hashed password, and that's just our mock implementation right over here, nothing special. But at least it is returning with something, so we can verify that data.password is storing the correct return value. Okay, so now the next part, we want to test this part over here. You see how we are creating a new user. So this is where we are invoking the constructor of a class. So now you're probably wondering, well, how do we test that? So what we can do is we can actually mock these ES6 classes. It's actually not that difficult, and I'll show you how to do it. So what we can do is right over in our test file, up top over here, I can go here, jest.mock, and I can just pass the path to our user right over here, this user.mjs file inside mongoose schemas. So I need to go out one directory to mongoose schemas user.mjs. Okay. And then up top over here, you know what, let me remove this mock users import. Let me import user from the mongoose schemas user.mjs file. Okay. So I just mocked that whole module right over here. And now what we can do is, so I uncommented this line over here where we call the new user constructor, and I can write an assertion and I can say expect user. So I'm referencing the entire model, which is a class, and that's coming from this import right over here. Okay, this is our model right over here. And then what I'm going to do is I'm going to use the to have been called assertion. And I'm going to run the test, and it's going to pass. So this verifies that the constructor was actually invoked. If I comment this out, you're going to see that it's going to fail because it actually was called, or it actually wasn't called, but we wrote the assertion to see that it was called. So let me uncomment that, and let's just change this to have been called with the correct arguments. So we want to make sure that it was called with the correct username, display name, and the hashed password. Okay, so in our test, let's go back up over here. So notice how this is the return value of matched data, because we are passing matched data, whatever this return value is, into the user constructor, only with the password being hashed. So what I can do is I can pass in that object and just change this to hashed password. And remember, this value comes from our mock function over here. We just prefixed hashed underscore with whatever the password is. So let's go ahead and run the test. And you can see that now it passes. So that's good. And now one more thing that I also want to show you is if you wanted to access the instance that was created, so the user instance, you can do that by referencing user, and it's going to attach this mock property onto that user. And then you can reference instances at subscript 0, because we only created one instance. And then let's run the test again. And you can see right over here, we have the instance, and this instance has this save method as well. And you could, of course, also reference the properties on it. So let's go ahead and continue testing the rest of our code. So I'm going to uncomment this out. And since we've already mocked out the user model, or mongoose model, I can actually just run my test, and we shouldn't get the same errors that we had before, because all that is mocked out already. Okay, this save method is mocked, everything. So what I want to do is I want to verify that the save method was called on the instance, this new user instance. So what I can do is this. I can actually create another spy on this save method so I can keep track of its calls, because there's no way for me to directly access this unless if I get the instance. So for example, if I wanted to, I could do user.mock.instances 0.save to have been called, like that. And this should work without any problem. Yep, and then if I try to negate this call to verify that it's not passing incorrectly, you can see that it actually was called. So this is one way that you can do this. The other way that you can do this is you can use a spy, and I'll show you how to do that. So I'll create a variable, I'll call this save method equals just.spyOn, and I can reference user.prototype, like that. And then what I can do is I can specify the actual method itself on the instance. So save is one of the methods, and then leave it like that. And what I can do is I can go ahead and replace this part to be expect save method to have been called. Okay, and if I run test again, the test will pass. And if I try to add the not operator in front of it, you can see that by adding the not operator, the test fails because it actually was called. So what I want to do specifically is I want to actually mock the return value of save. So what I'm going to do is at the end of just.spyOn, I'm going to call mock resolved value once. And I want save to just return the user that should be saved to the database. But I'm just going to attach an ID. You don't have to do this, but I'm just going to do it anyways. And then I'm going to copy that. So that way, like the reason why I'm attaching the ID is that way it makes it feel like it's being saved to the database, even though it's not, because MongoDB generates an ID for us. So now what I'll do is I'm going to go down over here. And what I'm going to do is I'm going to, let's see. So we are asserting that save was called. So now let's write an assertion on response.status. We'll verify that it was called with the status code of 201, and then we'll verify that the response object was called with the send method, or it called the send method with the saved user, which means that it includes that user over here that we are mocking the resolved value. So let's do expect mock response dot status to have been called with 201, and then let me just go down here. Let me change this to mock response.send, and let me just copy this object, paste it here, and we should be good. So let's test this out. Let me run my test, and you can see that our test passes, so that's good. All right, so we've covered 2 cases so far for our create user handler. Let's go ahead and cover the last case. This one's going to be pretty easy. We just need to get it to actually throw this error. So here's what we're going to do. We're going to go ahead and create a new test. So I'll go ahead and call this test. Let's see. It should throw error when save, or let's see, it should send a status code of 400 when save errors out. Okay, so everything else is good except for when the save method is called, maybe something failed the database, and then it throws this error and it sends a status of 400. So let's do, it should send status of 400 when database fails to save user. So I think that's good enough. And let's make this an async method. So we're going to, let's see, we're going to copy this create user handler right here. So everything is going to be roughly the same as the previous test. So I do also want to copy this just.spyOn, because we do want to make sure that we are going past this part. We're going all the way down, but then we just want it to fail when it calls the save method. Okay. So the thing is, though, we don't need to rewrite all of these assertions because we already did before. So let me do this const save method. Yep. So let me copy this save method equals just.spyOn. Let me copy this part. And now what we are going to do is we're going to go ahead and for the save method for this spy, we're going to mock the implementation one time. And remember, this save method throws, it could throw an error, but we're just going to mock the implementation. So when it does throw an error, then it's going to handle this catch block over here. But since this save method is asynchronous, it returns a promise. So we have to do promise.reject, and we'll just say failed to save user. Okay, so now we're basically overriding the save method to actually error out, return an error. So everything in our code should be good. And then once it gets to this save method, it's going to go ahead and error out. And then we're going to go ahead and write an assertion on response.sendStatus. Okay, so let's go ahead and do this. Let's do expect save method to have been called. And then what we'll do is we'll do expect mock response. That's send, or I'm sorry, send status right over here to have been called with 400. And let's go ahead and run our test. Let's make sure that it works. And there we go. We have covered all three cases. If you want, you can go ahead and write some assertions for some of these functions to verify that they were called, but you don't really have to, because it would just kind of be redundant with what we have up here. Because at this point in this test, we know that all of these functions are being called. It's just that we're trying to get to the point right down over here to make sure that we are testing for this send status being called with a status code of 400. And if I were to pass 401, that test would fail because it is supposed to be 400. And there you go. So hopefully all of this makes sense. I know this part of the tutorial was pretty long, but that's because there's a lot of stuff that I wanted to cover, and I felt like with this specific test, you learn so much with how to mock modules, how to mock classes, how to mock your own modules that you create yourself on your in your source code, so your local modules, and just a lot of stuff about unit testing. So hopefully this tutorial made sense, and I would highly encourage you to practice writing more tests, more unit tests for your other functions as well. So for example, one thing that I can encourage you to do is maybe for the local strategy, if this is something that you have, you can go ahead and take, let's see, you can probably take this part out. You can take this anonymous function out, put it in a separate file and import it in here. And then that way you can actually import that function into a test file and test the logic in here. And using the logic that I showed you with how to mock and how to override values of functions by mocking them out, you can write those unit tests. So hopefully all of this makes sense. In this part of the Express.js tutorial, I'm going to teach you how to write integration and end-to-end tests for your Express server. So integration tests and unit tests basically involve testing your entire application. At least with integration tests, you typically are testing certain scenarios and flows in your application. Like for example, create a user and then expect that user to return as a response, and then try logging in as that user after you've created it. That's an example of writing an end-to-end test. Okay, you have different scenarios. It's a lot different than unit tests, where unit tests, you are only testing one piece of your entire code base, like one single function. And many of you who have seen the previous section where I showed you how to write unit tests may actually find writing integration tests to be a lot more easier, because you don't have to worry about setting up a bunch of mocks, okay? Some people do get confused with how to mock and what to actually mock, but with integration and end-to-end tests, you just call your API and then you write assertions. So the first thing that I'm going to do is I'm going to actually disable the OAuth 2 configuration with the Discord strategy right over here. I'm going to comment it out, and I'm going to uncomment out the local strategy because I want to actually use local authentication. We're not going to be testing OAuth 2. We're going to be testing actual local authentication, where we create a user and then we can log in with that user, and then we will verify that the user was created and that we've logged in. So let me just do that. So just uncomment this file. Everything else is set up the way that it should be. And then we should have our both serialized and deserialized user functions. Okay, so we're done with this part. Just want to do that very quickly. Now let's go ahead and install supertest. So you're going to type npm -d supertest, and we're going to use supertest with Jest. They both work very well with each other, and we already have Jest set up already. So if you missed the previous section of this tutorial where we configured Jest and wrote some unit tests, check out at least the first 10 minutes of the video, or maybe like the first 5 to 6 minutes where we set up Jest. Okay, then come back to this video. But all the code is going to be in a GitHub link in the description, so check that out. So you don't have to watch the whole thing. You just copy the code and get the setup and then come back to this video. So I installed supertest. Now let's go ahead and go back to our code. What we're going to do is we're going to create a folder inside the source folder, and I'm going to call it E2E like this, because I want to keep all of my unit tests separate from my end-to-end tests, because it's good practice to do that, and it's also industry standard as well. And I'm going to create a new file, and I'm going to call this index.spec.js, or you can call it index.test.ts if you prefer. Okay. And I'm going to leave this blank for now. I'm not going to write anything just yet inside this new file. What we need to do is we're going to go into our package.json file, and we're going to add a new test script, but I'm going to call it test:E2E, so that way I can run either only unit tests or only end-to-end tests. For the test E2E script, the way it's going to look like is we're still going to be using the Jest binary. So again, make sure you have Jest installed and configured. And then we're going to use this test path pattern flag and have it point to the source/E2E folder. So that way when I run test:E2E, it's going to go ahead and only run the tests inside this folder over here. Okay, so we can run just the end-to-end tests and not the unit tests with it. Okay, so we're done with this. Now we're going to go ahead into our index.spec.js file. And what I'm going to do is I'm going to import supertest from supertest like this. And then I'm just going to show you a very easy example right now. I'm going to import Express, and I'll set up a very simple Express server with literally nothing, no middleware, nothing. Okay, whoops, didn't mean to do that. So I'm going to call the Express function, and I'm going to register a simple test route. So I'll call that route hello, and we're just going to send back a status code of 200. Okay, and then now to actually use supertest, the first thing that I'm going to do is I'm going to use the describe function. Again, this comes from Jest, so make sure you have Jest configured. And I'm going to go ahead and call this hello endpoint. Just something simple. And then I'm going to pass in that callback function, and inside the callback function for describe, this is where we're going to have all of our tests. So I'm going to use the it function that's part of Jest to write my actual test. So I'm going to go ahead and just say get hello endpoint. Or actually, let me do get hello and expect 200. Okay, so I have one test inside my describe callback function over here. And I can add more tests if I want to. So this is where we're going to actually call our API. So we're going to use this function actually. Actually, I'm sorry, it's not supertest from supertest, it's import request from supertest, or that's how you should name it, import request from supertest, because this is actually a function. So let me I just fixed that real quick. Sorry about that. So let me just invoke this request function, which is this supertest module over here. Again, this is the top level function that we're importing. And then we're just going to pass our app instance like that. And then what we're going to do is we're going to go ahead and call the get method. So whatever endpoint that we want to make a request to, and whatever method type, you would use that one. So for a get request, I would use get. For post, I would do post. So I'll do get, and then the URL, so hello. And then you want to pass in a callback function if you need one, but I don't need one right now. So after the .get, I can go ahead and use this expect method at the end. So I'm chaining this expect method on the return value of get. And then what I can do is I can expect a status code like this. I can do expect 200. And now let's go ahead and run the test. So we're going to run the test by using this test E2E command that I just set up earlier. So npm run test:E2E like that. And our test should pass. There we go. Okay, perfect. Awesome. Not sure why it took forever. It might be because we did not end the request, but I can do at the end of the expect call, I can do end, and then error res, and I can do if error, throw error like this. And that should fix that error in the last part. Yep, there we go. Perfect. So you can see that the test passes. And of course, if I were to change the status code inside this app.get, inside this request handler, if I were to change it to 201 to kind of like throw off this test over here, and show you what happens. So let's do npm run test E2E. So the test should fail. You'll see that the error actually is thrown right over here. The problem here, though, is that even though we are expecting 200 over here, and keep in mind this is the expect method that is on super test, not from Jest, okay? You can see that right now over here, it still treats the test as passing, even though the test shouldn't pass. And even if I were to write an assertion inside this callback function for the end method call, so if I were to do expect, and then we have this res argument, which is the response. So res.statuscode to be 200. And if I run the test again, the test actually will still be considered passing. Let me remove this expect as well. Okay, you can see that the test actually is still considered passing right over here, even though it actually is supposed to fail. Now to fix this, instead of having to do .end, like right over here, I'm going to go ahead and remove that. And so instead of that, we're going to go ahead and actually await this .get call, because this actually returns a promise. If you look at the end over here, you can use .then or .catch like that. So I'm going to add the async keyword in front of the callback function for the it function or test. And I'm going to go ahead and do const res equals await. So this is the response object right over here. You can see that the return value, the resolved value, is a response. Let me name it response. Okay. And now what I can do is I can write an assertion on the response, the status code, and I'll say response.statuscode to be 200. So this should fail because the endpoint actually returns a 201. And now the test actually fails. So this is exactly what we want. Of course, if you wanted to write an assertion on the response body, there's this body property on the response object. And then you can use assertions such as to be, or to equal, or to strict equal, or to contain, whichever matcher you feel like you need. So for example, I can do to be an empty object, and let's see what happens. Let me first fix this back to 200. And of course, you can see the test fails because we're not returning a response body. So let's fix that. Let me go ahead and set the status to 200 and also send some JSON and empty response body. And let's run the test again. And let's see. I think let's do to equal, since it's an object. Okay, there we go. Now it passes. Okay, it does suggest to use to strict equal as well, right up top over here. That's why it was erroring out. Okay, and if I tried to pass in the wrong object, like this, let's run the test. And you can see that the assertion fails. So hopefully this makes sense. Now, I just want to show you this quick example. We're now going to go ahead and actually set up our end-to-end tests for our application. So this will actually require us to grab our app instance right over here, because what we need to do is similar to what we're doing in here. We need to pass that app instance into the request function as an argument, as you can see over here. Okay, so inside our application, right over here, inside index.mjs, this is where we actually have our Express app created and we have all of our middleware set up. So the thing is, though, we need to make sure that we can export our app and import it into our test files, our end-to-end test files, so that way all of the routes and all of the middlewares and anything else is actually going to be registered. The other issue is that because in our file, we're not only just registering middleware, but you can see right over here, I am trying to also invoke the database as well. So there are actually a few things that we need to do just to get this to work. And so the good thing is it's not going to be a big deal to do this. So what I'll do is I'll create a new file and I'll call this, let's see, create app.mjs. And all I'm going to do is just export this function, create app, like that. And I'm just going to literally take, let's see, I'm going to take all of this stuff right over here. And I'm going to paste that in here. And then what I'm going to do is this. I'm going to go ahead and pass an instance of app like that. So then I can reference app right over here. And I also need to make sure I'm registering all of my middleware, which I am. And I also need to import all of the middleware as well. All the imports right over here, as well as right here. Okay. And let me see. Additionally, you know what? Actually, I'm going to create the app inside the function instead. And let me import Express up over here. So let me delete all of these imports in the index files because we won't need them anymore. Okay, so what I can do now is I can call create app, and I want to actually return the app instance. So when I call create app, it'll run through all of these. It'll call all of these functions. It's going to register all of the middlewares right over here, all of the routes, and it's going to return app. So once all of the middlewares and all of the routes are registered, it's going to return this app instance to wherever we called it. So now what I can do is inside the index.mjs file, I can go ahead and first let me import create app like that. And then I'm going to go ahead and do const app equals create app. And we don't have any asynchronous logic going on here, so that's good. So we can just call create app. And now the next thing is we need to also make it so that when we run our end-to-end tests or integration tests, that we're also able to connect to the database as well. So this alone is just fine for our development application. Like if I were to just run my code right now for just development, everything would still work the same way. You can see that's still going to reference the app and then call app.listen to actually start up the server. Oh, Mongoose is not defined, I think. Oh, I think, let me see, where was it over here? Did I reference that in here? Oh yeah, let me import Mongoose in here as well inside the create app.mjs method, because we do reference it down over here. Forgot about that. And then cannot init client, please provide correct options. Okay, so the other problem here is that it does require the Mongoose connection. So what I can do is I can move the Mongoose connection up top over here. And now it works. Okay, so it's just a matter of ordering things. So first I'm connecting to the MongoDB database. So I'm calling mongoose.connect. Then I am initializing the app because the application does require the connection to exist first. So now what I can do is let me remove this app.get. Let me remove all of this for now. And instead of just calling Express, I'm going to remove that. Let me remove this import of Express. I'm going to go ahead and import the create app like this. Okay, so now we actually have our Express app in this variable, like our actual app, not the fake one that we just created just now. But we still need a connection to the database, and that's okay because what I can do is I can actually just copy all this stuff over here and I can just paste it right in here, and I can just import Mongoose from Mongoose, and I can change the database that it is connecting to. So I can change it from Express Tutorial to Express Tutorial Test like that. And I can say connected to the test database. And now let's go ahead and try to test a very simple endpoint. So I have, let's see. Do I have any simple endpoints that I can set up? Let's do this one. Let's do the API/auth/status endpoint. Let me remove all these logs. So what this should do is we're going to write an assertion to return a 401 because we're not authenticated currently. So inside our test file, let's go ahead and do describe API auth. And then what I'll do is say it should return 401 when not logged in. And let me add the async keyword in front of the callback function for our test. And I'm going to do const response equals await. So I'm going to call the request function. That's the super test right over here. I'm going to pass in our app And then we need to go ahead and call get, and then go ahead and pass in the URL that we want to visit. So /API/auth/status, just like that. And then now I can write an assertion on the response .status code to be 401. So let's actually run our test and see what happens. So npm run test, or I'm sorry, npm run test E2E. Okay, and you can see, let's see, right over here, you can see that it is logging in the console right over here. It says connected to test database, and our tests are passing, so that's good. So it is actually calling the endpoint, and it passes because we are expecting the status code of 401, which it is actually giving it to us. And of course, we get this issue where the test did not exit after the test completed. So I think it's likely because of our database connection right over here, mongoose.connect. Let me actually do this. I'm going to copy this, and I'm going to go inside the describe block, and then right before the test, I'm going to go ahead and use this before all function. This is a lifecycle hook. So basically, this function takes in a callback function, and before all of your tests, that's why it's called before all, it will run whatever is inside this logic over here. You can see before all of our tests, it's going to connect to the database. So there's before all, there's also before each. Before each will run before every test, and we don't want that because we only want to connect to the database one time. And then let me just make sure this still works as expected. Let's see. Okay, so I think the problem is, oh wait, whoops. Let me do this. It does require a little bit of tinkering, but what I need to do is, because we're trying to create the app first before the database connection, so let me actually do this. Let me declare a variable up here called app, like that, using the let keyword, and I'm going to reassign the value of whatever create app returns to app, and so that way I can reference it inside here. Okay, there's a bunch of different ways you can set this up. So this is not only one way, this is not the only way to do it. There are different ways of how you can configure this, but this should work. Okay, perfect. And now to fix this part, we're going to go at the end of our test. I'm going to go ahead and use this after all hook. Okay, so it's pretty much the opposite of before all. So after all your tests, what we want to do, and this is the part where I mentioned earlier, or maybe in the previous section of this tutorial, where you want to actually drop the database as well as close the connection to the database. So you can do that by referencing mongoose.connection drop database. And then you can see it says helper for drop database deletes the given database, including all collections, documents, and indexes. So that will drop the database that we are connected to, which is the test database. And this returns a promise. So we will need to await that. So let's add the async keyword and await this. And after we drop the database, let's go ahead and close the connection. Yeah, I think it's, yep, close. And then this will close the connection right over here. And then this should fix that warning that we have over here. Okay, there we go. You see how now the tests actually gracefully exit. And this is important because if you have your end-to-end test, or really any test running in a pipeline, it's going to block your pipeline from proceeding to the next job. So it's very important that you resolve these situations. Okay, but we have a pretty good setup right now. So let's go ahead and actually continue. So what I'm going to do is I'm going to go ahead and write an end-to-end test. I'm going to write a scenario, okay? So what I'm going to do is I'm going to go ahead and create a user first, verify that the user is created, and then we're going to try to log in and then verify that we're logged in. I know it's a lot, but don't worry, we'll take it step by step. Ideally, you always want to make sure you are separating your tests. You don't want to like have them all together. So what I can do is I will go ahead and create a new file. I'll call this user.spec.js, or really whatever it is that you want to describe it as. And we can just literally copy this whole thing and paste it here. So I'll just call this create user and log in. And just have the same exact setup like this. Let's see. Yep, everything else is good. And then let's just delete that because our test is going to be different. Okay, so the first thing that I want to do is I want to actually create the user. So let me go ahead and do this. It should create the user. And keep in mind that we're not going to be testing everything in one single test block. We're going to be doing everything in sequential order. So first thing is we're going to test that the user is created. So it should create the user. And we're going to go ahead and make a request. So let's call the request function, pass in our app instance. And then we're going to go ahead and call a post request this time. And the endpoint is going to be /API/auth/user. And let me just verify that route right over here. Yep. Router.post API users. Or I'm sorry, I don't know why I added auth. It's API users with an S. And then it's going to go ahead and call this middleware function. This is the express validator. So this is where we can actually also make sure that the validation is working as well. We have create user handler is called, which is our request handler. And it's going to basically run through all this logic. So again, in the previous section of this tutorial where we went over unit testing, I showed you how to unit test this whole function. This time we don't have to worry about mocking anything. It's going to call this function and it's going to run the actual logic. It's going to call the actual functions from express validator. It's going to call our own hash password function. It's going to create the user and it's going to actually save it to the database using Mongoose. Okay, so let's go ahead and go back to our test file. Oops, sorry about that. Okay, so we're going to make a post request and let's go ahead and send a request body. So to send the request body, you can use this send method like that. Whoops, not sure why that is. Send. Yep. And then you can pass in an object. So we need to send the username. So for the username, I'll do Adam123 password. Let's do password and then display name. Just do Adam the developer. Okay, so when we send this request, it's going to handle it on the server side. We don't obviously care about what's going on the server side with this because we're trying to just care about what the response is. Okay, so what I'm going to do is after this whole thing is done, we also want to await this call because remember this .send method also returns a promise as well. So let's await that. And now let's write an assertion. Let's do response.status code to be 201. Okay, so let's run our test. So let's do npm run test E2E. So this should run all of our tests for us. And you can see both tests pass. And you can see in the console that I think that's the salt from the hash password function that's being logged. If I am correct. Yep, it's the salt. Let me remove this console log. But you can see that both tests are passing. So that's good. And you can see that they don't conflict with each other. And one more thing that I also want to show you is if I open up my MongoDB compass tool. Okay. And if I were to actually, let me see, not this one, but it shouldn't be connecting. Yeah, it should not connect to this Express tutorial database. It should connect to the test database. So you know what? Let me remove this line over here and show you what happens when I run the test. Okay, so now watch this. If I refresh the page or refresh this application, what is this new version available? Let me click X. You can see that now this Express tutorial test comes up and you can see that our collection, our users collection is inside the Express tutorial test database and so is our sessions. Okay, so hopefully this makes sense. But the reason why we didn't see it before is because we dropped the database. And the reason why we dropped the database is because we don't want the test data from previous test suites to conflict with other tests. Okay, I'll explain more about that later on. Because right now, you might wonder, okay, well, we do need the data with this user in the next test. But yes, that's within the same test suite. In other test suites, like in other scenarios, you don't want to have leftover data in the database conflicting with that scenario, because you might have a scenario where you're only expecting one user, but there might be 3 users because you didn't clear the database. Okay, all of those tests that you ran kept creating a new user, and because you didn't drop the database, the users kept adding on into the database collection, and your assertions are going to fail. So let's go ahead and continue. So after we create the user, let's actually log in. So what we'll do is this. I'm going to first manually drop my database. Let me just do that because it will error out if it creates a duplicate. Okay, so we dropped the database. Good. Let's go ahead and go back to our code. So now we'll do this. It should log the user in. And we're going to make a request, a post request, this time to /API/auth. Yep, I think it's just /API/auth. And then we're going to send our, whoops, I don't know why it keeps doing set encoding. Send username. So the same username that we configured up top over here. So Adam123, and then the same password. And then let's go ahead and get the response in a variable. Okay, so let's just go back to our auth. I think I put that right over here. Yep, so it should send back a status of 200 on success. Okay, I think with Passport, let me just double check everything. Yep, I think everything here is good. So let's continue. So expect response status code to be 200. Now let's go ahead and run our test. Make sure that it passes. Okay, so now it says, let's see, now it failed, and let's see what's going on over here. It says received 500, so it seems like the backend, there might be something wrong with the backend for it to send back a 500. So I'll actually just console log the response body and see what that message says. Because it sent back a status code of 500, so that's obviously not good. Let's see. Okay, so it says, maybe not response.body, but maybe let's just do response. Okay, so it says right over here that unknown authentication strategy. Okay, so I know what the problem is. The problem is that it doesn't recognize our local strategy, and I think it's likely because of the way that we moved everything into here. So I'm trying to think what would be the easiest way to do this, because if I were to actually remove this create app and then move everything back into the index file, I would need to export the app, and that would require me to import the index file, which would also call this mongoose.connect code, and I don't want that to happen. So the only other option is I would have to essentially move this to a separate file, and then it would also call this app.listen, which I don't want. So we don't want to import this index file at all. So I think the other thing that I might need to do is I might need to import this strategy into the create app, probably. Maybe like right over here. And I think maybe that might fix that. So let's try to run the test again and see if that same issue occurs. Okay, so you can see that the error goes away now. So it seemed like this import did fix that. I guess because we had it over here, it was what was causing the problem. So let me move this as well over to here. Okay. I guess it has to be inside the scope, since I guess this is where we are creating the app and we are initializing Passport here. So maybe that's the reason why. I'm not too sure, but at least we fixed that part. So now we can go back over here and let me remove this console log and let me just rerun the test. We know that it's passing though. Okay, and you can even see in the console log from the actual source code right over here, it is logging the user over here. And if we go to, where is the local strategy? Right here. Yep, you can see that it should be logged. I think, yeah, it's being logged right over here inside the serialize user function. And it says inside serialize user, and it logs the user itself. And then after successful authentication, the endpoint right over here sends back a status code of 200. Okay, so we verified that we were able to successfully log in. Now, additionally, what you can do is you can write some more assertions on the response object. They have this property called, I think it's headers. Yep, headers. And what you can do is you can check to see if the headers actually has the cookie that you expect, because this response.headers object is actually just an object that has the cookies property. So let me show you real quick what that looks like. Right over here. Yep. You can see that we have this set cookie property, which seems to be an array. So I guess what you could do is you can look to see if the array contains this cookie name right over here. So that's one thing that you could do, but I'll let you all take care of that. So now inside this second test, we are trying to log the user in. So now once we've logged the user in, then we should have a session and we should be able to visit the auth/status endpoint and get a response back with our user record, because that's who we are logged in as. So let's go ahead and try that out. So I'll say for the test, it should visit API/auth/status and return logged in user. Let me just call this authenticated user. And I want to show you what happens when we try to do this. So we're going to make a GET request this time to /API/auth/status. And we're going to assert that the status code returned is 200. And let's see if this passes. And you'll notice now that it actually fails. Okay, it gives us back a 401. And so I think the reason why this happens, I don't know the exact reason, but I will tell you what I think because I ran into this issue myself. So when we run our tests, they are running in order, okay? They are running this one first, and this one first. But when we run this test right over here, it doesn't actually persist the cookies for the next request. So for example, we do receive cookies inside this API call right over here. Okay, we do have cookies inside this second test, and those cookies are being sent from the server. However, in this third test, when we try to make a GET request to this protected endpoint, we need to obviously send the cookies, but in the context right over here, we don't have the cookies sent. So I think because of that reason, it is giving us back that 401 because it's treating us as if we never logged in. So the way around this is to actually implement this logic inside just one test. So I'll go into this second test over here, and I'll say for the title, should log the user in and visit API/auth/status and return auth user. Okay. And so what we'll do is after we call this send method, I can actually use the .then method, and then I'll get the response of the post request, because remember, I'm using the .then method to resolve the promise for this request.post method, and then that would resolve the value of whatever .post was going to return. Okay, whatever the promise was going to resolve. So inside this, then I'm going to pass in a callback function, which gives me access to that response for that post request to the API/auth endpoint. So inside here, what I can do is I can actually return request.app. So I can make another request right after this post request is finished, and I can make a GET request, and I'm going to paste that URL over here. And then what I can do is I can also set the cookies. So I can use this set function, and then I want to set the cookie. And then we need to just pass in this array of cookies, which we can easily grab if we reference res.headers. And I think the property was called set-cookie, I think, or set cookies. Let me actually just double check real quick. Let me do this. Let me console log this. Okay, but then what will happen is we send the cookies along with this request, and so this response, so after we await this whole thing, this response up top over here is the response for the actual GET request. Okay, so then right over here, we can write assertions on the status code, on the response body. So let me go ahead and remove this third test because we won't need that anymore. And let me go ahead and run the test again. And let's see, invalid value undefined. Let's see, headers. It may have been set cookie instead of set cookies. Maybe that's why it's giving us back undefined. Yep, it's set cookie. Okay, yep, that's fine. So let's go ahead and change this to set cookie. So this will pass all the cookies, send it to the server. And let's go ahead and run the test again. And now you can see that our tests pass, and specifically this second test pass with all of our API calls. And you can even see on the server side, it goes through the serialized user function, and then it goes through the deserialized user function. So this is invoked whenever we make a next request after we first log in. Okay, so everything is working as expected. And if I want, I can write some more assertions on the response body. So I can do response.body.username to be Adam123 for the display name. Let's do that as well. To be Adam the developer. And let's run our tests and let's see what happens. And you can see all of our tests pass. So I hope that this shows you how to write integration tests as well as end-to-end tests. I hope that you better understand how to do it and how to set it up in a way that makes it effective. And this will be the last tutorial for the entire Express.js series. I'm still going to make more Express.js tutorials. It's just not going to be part of this specific long series that I designed. So I hope that you all enjoyed watching this series. If you watched the whole entire thing, like I said before, the code will be on GitHub. I'm going to leave a link in the description as well, so you all can access it. You're more than welcome to ask questions down below in the comment section. I check my comments every single day, and I respond whenever I get a chance to. If you need additional help, visit the Discord server. The link is in the description as well. You can go onto the Discord server and get help with your programming issues, talk to other developers, just hang out and whatever. So yeah, like I said, I hope you all enjoyed this whole Express.js tutorial, and that is going to be it for this one. So I will see you all in my next episode. Peace out.